this 7 hours long end-to-end real-time streaming project which will teach you a submodel of Apache Kafka, sending events from web application and storing it in the event hub, using Kafka connectors to stream data using PySpark, build dynamic ingestion pipelines using Azure Data Factory. Then you will build metadata-driven notebook with Jinja templates to make your code modular, which is the hottest topic right now in the industry. Not just this, then you will build the complete star schema using Spark Declarative pipeline, which is the modern upgrade in the Apache Spark. In short, this is a complete end-to-end project which focuses on the tech stack that actually matters because it uses Azure Data Factory, Databricks, managed Apache Kafka, Spark Declarative pipelines, which is the hottest tech stack right now in the industry. I have literally put my best efforts to create this 7 hours long project and providing it for free. Just hit the subscribe button if you want to support my hard work. Are you ready to upskill yourself with this amazing project? If your answer is yes, just write down in the comments that I will upskill with this project, and let's get started with this amazing end-to-end data engineering project.
So what's up my fam? Happy Sunday, and finally we are going to build this project today. And finally, after receiving so many messages, I was like, let's build a kind of real streaming real time project because we have built so many amazing batch processing projects. So now finally we are going to build this project. I won't take your much time. Directly let me just take you what are the prerequisites for this project. You should have a very basic understanding about Python and SQL. You should not have any kind of understanding about Azure, event hubs, real-time processing, Kafka, Spark, structured streaming, declarative pipeline, nothing, because everything is covered from scratch. So this is, yes, a kind of beginner-friendly course. Basically not course, a project. But why I am just considering it as a course? Because you will learn a lot of things in this project. Simple, clear. Let me now just talk about the architecture. So this is an amazing architecture. Let me just tell you, because just look at this piece, just beauty. So what are we just trying to do in this project? First of all, we will process real-time data, and as you just saw in the introduction, as and it was also mentioned in the thumbnail, that this is a kind of project where we will be using ride, or you can say taxi confirmation system. So we as data engineers need to build an end-to-end solution for an organization, and that organization is a kind of, you can say, taxi or ride booking system. Simple. For example, Uber, Ola, but Uber is like famous worldwide. So let's take an example of Uber. So now how Uber works, if I just ask you how Uber works. So Uber has a web application, or basically a mobile application. User goes there and book a ride, and that's it, right? And that particular information will be directly stored in the, you can say, a kind of system where they can just track the all the events basically. It can be Apache Kafka, right? And when we just talk about managed instance of Apache Kafka, because obviously we do not need to host our own Apache Kafka instance, it is a kind of headache. But we will be using Apache Kafka in a managed version that is called Event Hub, which is available in Azure. In AWS, we also have something similar, okay? And in Fabric, it's called as like Event. So different names, but the thing is same. So now I have also built a web application, yes, using Fast API, very basic web application. I will give you the code as well, so you can also run that application. Let me just show you right now. So this is a kind of web application which we have built. So it will simply say welcome to the ride booking service, and I will have a button to book a ride. So I will simply click on this button, and it will say your ride has been successfully booked. Thank you for choosing our service. So welcome, and just send the ride immediately. So now what this will do, this will directly write this event into my event hub, and let me just show you that as well. So I will just go to my Azure, and I can just show you, this is my event hub. See, so this information will be written here in the real time. Yes, this is my Uber topic. Don't worry, you will create everything. I'm just showing you the overview. So this is my event hub, and this will have all the information. See, all of the events will be listed here, and the latest event will also be here, and this is this one. See, perfect. So this is the event that is stored in the real time, and don't worry, you will get everything from scratch. So just imagine you will build everything. So this is step one. when we have the information stored in the event hub, that means we have created a system where we can build an architecture based on a model called pub sub, basically publisher subscriber, or basically producer consumer. This is a very famous term that we use whenever we want to build something real time. When one system is a producer, the other is consumer. Simple. These are the basics and fundamentals of Apache Kafka that you will learn in this project. Very good. So once we have the real-time data, along with the real-time data, we have some bulk data as well. We have some mapping data as well that we have stored in the form of internal API. And obviously, just to mimic that internal API, I have used GitHub API just to store my all of the data. So this is the GitHub API, and here we will be seeing everything in the data folder, and we need to pull this data. And in order to pull this data, we will use Azure Data Factory like this, and we will build this application, you can say pipeline. This will just fetch all of the information dynamically, and this is a kind of metadata driven pipeline where you do not need to hard code anything. Everything will be dynamically running. So this is your ADF pipeline. So far we have discussed our bronze layer. So this is our bronze layer. That means we have everything stored. We have stored everything in our bronze layer. That means our raw data is ready. Like exact replica of our source is ready. Web application is running. Perfect. GitHub is loaded. Perfect. One more thing. This application will be live. So whenever we will be receiving more taxi confirmation ride, it will be keep on adding my stuff, basically my ride confirmation into the event hub continuously. This will be like never stopping. Okay, simple. Then once we have loaded our data in the bronze layer, and I can just also show you the structure, which will look like this. So this will be a person. This person will go to the web application as you just saw, and this will store the data in the event hub. Simple. Very good. The next step is very, very interesting. Obviously data factory, this is also done. The next step is very interesting when we need to process this data in the real-time manner. That means we will be using Spark structured streaming to create the structured streaming tables on top of our event hub, which is a kind of managed Kafka. And here we will be leveraging something called as Spark declarative pipelines here. Why? Because Spark declarative pipeline is a kind of modern Apache Spark framework, or you can say modern upgrades in the Apache Spark framework, which has actually revolutionized how we write our code in PySpark. And you should also learn about it. I have created like full-fledged course on Apache Spark declarative pipelines. You do not need to watch that course before this particular project, but I would recommend you should just learn that as well after this project. Simple. So in the silver layer, what is the agenda? Agenda is very clear. Agenda is we need to create one big streaming table. Why? If you are working in an industry where we are using modern approaches, modern architectures, modern frameworks, one big table, OBT, is a very popular approach which is becoming even more popular nowadays, because this table contains all of the data at one place. Because the thing is, now we do not use a traditional approach where we simply hand over the same data to all the teams. Now teams have different requirements. So now what we need to do, we need to build one big table which will have all the information, and we can hand over this data to some domains of our organization where they can just build the model by themselves. This is becoming even more popular now. Simple. Very good. But obviously star schema is a standard that you build in gold layer. So yes, at the end, we will be building star schema, and not just a star schema. We will also build the slowly changing dimension as well, and everything with Spark structured streaming approach, which is a kind of complex thing, but you will learn everything from scratch. Make sense? So let me just show you that particular thing as well. So when we will be just loading our silver layer, this will be like very interesting zone, silver layer, because here we will be building streaming tables along with the mapping tables, and we will use something called as Jinja. I can say this is the heart of this project. Let me just tell you why. So now, if you are well updated in the industry, you would know that every other service provider is focusing on a concept called metadata driven structure, metadata driven architecture. And I have been shouting since last year that you should learn metadata driven approaches, you should build metadata driven projects, and finally I have also added this particular approach in my current project. I think I also added this approach in my previous project. I don't remember, but this project will also follow that approach. What is the meaning of metadata driven approach? Metadata driven approach means you do not need to tweak or modify your code for the future enhancements. If you have new requirements in the future, you just need to make changes in the config file and that will handle everything in the code, which is a big deal when you build it. And you will build this thing using structured streaming that is even more complex. More complex doesn't mean that you need to require some knowledge. No, nothing, everything from scratch. So this is that particular piece which is very, very important for this project, Jinja. Jinja is a templating language that I have combined with the normal Apache Spark and Spark SQL code, and you will love this a lot. Simple. And if you are updated about the Microsoft Fabric as well, I think Microsoft Fabric has also recently introduced a special notebook which they claim as like this is a kind of metadata driven notebook which will do everything. So that everything is nothing, but they are also promoting this kind of architecture because this is the future. You cannot even like keep on writing the same code again and again and again and make the changes in your code and break the code and just spend some time to debug it. No, you need to build code one time and reuse it multiple times. This is the concept. This is the heart of this project. Once we have silver layer ready, then obviously we will build our gold layer where we will building this amazing star schema where we'll be having one fact table and 5 to 6 dimension tables. I think, yeah, there's one more dimension table. I missed it. It's fine. So there are 6 dimension tables and one fact table, which will be creating from this OBT table. OBT table. Okay, perfect. Simple. So this is a very high level architecture that we are going to follow for this particular project. Obviously, there's no need to discuss everything in detail during the architecture phase because you need to learn step by step. You need to focus on pieces, then go to next pieces, then go to next pieces, and then repeat the cycle, right? Very good. So this is like a very high level overview. Yes, you would need to put some extra efforts to learn this technology, not like this just technology, this set of technologies. Okay, so now are you excited to kickstart this project? And if you are excited, see, I have literally put my heart while building this project and I actually mean it. So if you also want to support my hard work, my love towards you, and if you also want to gain more and more knowledge from this channel, just hit the subscribe button. It actually matters a lot. It will hardly take like 1 second, like clicking like this, doom, but it actually matters to me a lot. So just hit the subscribe button, leave a comment, whatever you are thinking in the initial phase of this project, excited, whatever you are feeling. Okay, just write it. You should just communicate with this video. There are some other people who can communicate to each other in the comment section, help each other. That's how community builds and grows together. Okay, this is not a rat race where you just want to win alone. No. If the domain will win, then only you will win. This is a very deep line if you can decode it. Okay, so we have to first of all grow the domain, and then you will also grow, because when the entire domain is in demand, then also you will be in demand. Simple common sense. Okay, very good. So let's get started with this project, and we have discussed everything that we should discuss. Now rest of the things will be discussed during the building phases. That's it. We do not need to just cover theory and all. We just need to learn by doing it. So agenda of this particular video is very, very clear. So you are a total beginner. Okay, and then once you complete this video, you will become a confident developer with this amazing tech stack. You know the tech stack, right? So this is the agenda. Now let me just start congratulating my lovely family members who have recently cracked the offers. Okay, this will obviously make you feel happy as well, because they are someone who were with you and who are with you, obviously, like who were like learning like you and looking for jobs, and finally they have cracked the offers. So now congratulations to all of you, congratulations to all of you, congratulations to all of you, congratulations, 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 congratulations. Wow, wow, amazing, amazing, amazing. I want this list to be so long that we will be spending at least 2 to 3 hours to say congratulations. Then we'll be having special sessions to congratulate people. See, this is the agenda of this channel, just to help maximum number of people. Simple. So if you also want your name to come here, Hard work is the key. Consistency is the key. And obviously, learning from this channel is the key. Okay. So, and at the end, let me just show you my profile as well. This is me, and you can definitely check this particular profile. This is me, and yes. So let's get started with this amazing end-to-end streaming Azure Databricks Event Hubs Kafka data engine project. Let's get started. So now let's try to understand Event Hub first of all, because as we know that we will be using Event Hub for our data streaming and data ingestion plus data generation as well, because this is like a kind of end-to-end solution. So let's try to understand what is Event Hub first of all, because once you understand this concept, you can actually build the real-time streaming solutions, real-time pipelines with ease. Simple. Okay. So Event Hub, let's forget about everything that you know about Event Hub if you are already familiar with it. And some of you will say, hey, is this similar to Apache Kafka? Is this similar to this, that? Forget about everything. Okay, just for a few minutes. Now let's talk about what is Event Hub. Forget about Kafka and all. Simple? Very good. Because when we need to learn something, we need to first of all get rid of all the questions and everything. Just for a few minutes. So first of all, let's say this is a kind of Azure service that we have in Azure network. Very good. Now this particular service works on a model called PubSub, which is popularly known as publisher subscriber. Okay. So let's say publisher subscriber. This is a kind of very popular concept. What is this thing? Do not need to worry. Just remember the name first of all. Simple. Okay. PubSub. There is one more popular name for it. It is called producer and consumer. Okay. Producer and consumer. So I will simply say pro-con. Pro-con. Simple. Producer and consumer. Simple. Now what is this thing? PubSub and pro-con. What is this thing? So this architecture means there will be two parties, publisher and subscriber, or producer and consumer. Let's use the word called pro-con, producer and consumer. Why? Because in the Azure network, we do not use PubSub more, we use producer and consumer. Okay, and I also use producer and consumer. So let's say producer and consumer. But PubSub and producer consumer are same things. Simple, very good. Now what we're gonna do, let's say we are working in an organization and that organization has an application, has a web application, anything. Okay, let's take that example. So now this web application will become my producer. Why? Let's answer this question. Why? Okay. Producer or publisher. Okay. Both are interchangeable words, but I will just use only one thing. Okay. Let's say producer. Now, why this web application is the producer? Because this will produce something called as event. Okay. Event. How this event will be generated? Let me tell you. So let's say we are working on a realistic use case of our project where we are building the solution for the taxi booking and ride booking. Simple. So let's say we have the web application for that particular system. So if any user or any customer, let's say this is the customer, this customer books the ride with our web application. Obviously, there will be a method to book the ride. Simple. So let's say this user books a ride. Okay, simple. Now when the person will hit the book button, this event will be stored in something called as Event Hub. Understood? Very good. So now this Event Hub is a kind of channel. This is what? This is a kind of channel. And this Event Hub will store the information in the form of events. So this event will be stored here. Let's say event 1. Simple. Event 1. Okay. Make sense? Good. So this is connected to this channel. Now let's say there is another person who booked the ride after this person. So let's say this is the another person, and this person also wants to use the ride, or you can say use the web application. So this person also books the ride. Perfect. Now do you know what? This event will also be created. Why? Because this is a producer. This is what? Producer. Simple. This is a producer. I hope it is simple and straightforward. Okay, good. Now this producer will generate another event. So we will be having one more event. Okay, perfect. Now do you know what? All of these events will be stored in a kind of ordered list, or you can say in an ordered manner. Why? Because then only we will get to know that event one, or basically this person, booked the ride before this person. Simple, makes sense? Very good. Now this part is clear, producer. Now what is consumer? Let me just tell you. So now we have a kind of storage. We have a kind of storage of events. Now obviously I want to just process this storage, this data. So what I will do, I will bring my consumer. Now the beauty of this architecture, or you can say this model, is that you can have as many consumers as you can. Here our consumer is what? Who is our consumer? Our consumer is Databricks. So I will bring Databricks as my consumer. Make sense? So this will become my consumer. Okay. So now what this consumer will do? This consumer will access this information. Make sense? This information. How? In the order in which these events are stored. Like obviously consumer has the power to just read the data in any order or whatever it can do, but just to simplify the procedure, we can say that this consumer will read the data in the same order. Now this consumer can be this as well. Let's say I have one more consumer. Let's say Synapse Analytics. This can also be a consumer. Make sense? This can also be a consumer. Because that is the beauty of Azure Event Hubs. You do not need to just rely on one consumer. Make sense? So let's say this is also one of the consumer. Okay, perfect. Let's say this one. But in our case, it is Databricks, but I'm telling you that this can also be the consumer. Why? Because this event hub is not just restricted to only one consumer. I can put as many consumers as I can. Simple. So producer, which produces the events, consumer, which consumes the event. Very good. Now let me just tell you one more important thing. Now these events, now you will say, Ansh, Lamba, this is so good and we can just use the events as much as we can. It is fine. But you know what? You cannot access all of those events for lifetime. There is a kind of expiration date, or you can say expiry date for these events, because Event Hub cannot keep on storing all of your events. Because see, let's say you are just working in a big organization, okay, where you are just receiving so many customers. So you can have millions, billions of events created within, I would say, months or years. So you cannot keep on storing all of these things, right? So what we do, we also set a kind of expiry. You can say a kind of expiry. Do we have any time? No. So let's say these are subject to expiry. Simple. So there is a kind of expiry date. Kind of. Simple. So these are not like which will be always storing your data. Simple. You need to remember this thing, that there is an expiry date for it. Okay, simple. So when we have expiry date, that means we can use the past events as well for that expiry date. So let's say event 1 was generated around, let's say 11:30 a.m. Okay, currently it's like 11:30 a.m. So now if I set the expiry time for 1 hour, I can access this event for 1 hour. I have 1 hour to pull the data and to process it. Simple. Okay. After 1 hour, this event will be gone. So I have to process this data within 1 hour. And usually it is like a big time frame, 1 hour, because in the real time data analytics, 1 hour is like a big deal. Okay. So this is your Azure Event Hub. Now let's talk about some similar services. If you have heard about Apache Kafka, this is very similar to Apache Kafka, and yes, everyone knows that Apache Kafka is a kind of open source framework that works on the similar model which is called pub sub, or you can say producer consumer. Make sense? Very similar. And then Ansh, Lamba, can we say that Azure Event Hub is just Apache Kafka but managed by Azure? You can say that it is a kind of Apache Kafka service, but it is not a managed instance of Apache Kafka, but it works exactly same as Apache Kafka. And you know what? When we create Azure Event Hub in Azure, and you will be just creating it very, very soon, you can actually use this data the same way that you used your Apache Kafka data. The same connectors, the same Spark code, everything same. That is the beauty of Event Hub. Make sense? I know that a lot of cloud providers allow you to just host managed instances of Apache Kafka, but they also have the dedicated resources for streaming solutions such as Event Hub, because it is better, because they have added so many optimization techniques as well and much well integrated with their cloud ecosystem. So yeah. So if you are thinking that this is similar to Apache Kafka, yes, you are right. This is exactly similar to Apache Kafka. In the industry, you will see that yes, a lot of organizations use Apache Kafka, but you know what? The bigger organizations, or which are, you can say, big enterprises, they do not like hosting Apache Kafka on their own. So if they are already working on a specific cloud ecosystem, if they are already working with services available with specific cloud ecosystem, they simply go with the related service available in that ecosystem. For example, Azure. So if any organization is working on Azure ecosystem, then they can simply work on Event Hub instead of hosting their Apache Kafka. It doesn't make any sense. Simple. So now you should know, like, why are we using Event Hub, why Event Hub is in demand, and what exactly Event Hub is solving in the real industry. Plus, after learning Event Hub, we can say that we also know how Apache Kafka work under the hood and how we can work with Apache Kafka. So it is actually giving you so much of knowledge that you can just apply in your real world. But this is the concept that you should know. Okay, pub sub pro con, basically publisher subscriber and producer consumer, and this is the solution for that. Very simple. Okay, I hope you understood the high level overview, because when you will be seeing everything with your eyes, you will understand all of the things. But if you understand 10% of the concept, very well done. Okay, so now let's try to create our Event Hub, then only we will understand the things. So what I will do, I will simply create my Azure account. So yes, you need to create your Azure account. So I will be just showing you how you can also create your free account. Azure gives you free service for 1 month. Oh, wow, yeah, just for the learning purpose. So simply go to any browser and search Azure free account. Perfect. So here you can just click on very first link, create your Azure free account, and here you have two options: try Azure for free and pay as you go. So basically, whenever you get started with any cloud provider, every cloud provider will give you some free credit so that you can learn the technology and you can just use the technology. So you can simply go with try Azure for free. So here you can just put your Microsoft account. If you do not have any Microsoft account, simply create one by clicking here. And you can even use your existing Gmail account, but you need to register under Microsoft ecosystem as well. So simply go and click on create one. Just a pro tip: if you are creating a very new account, if you do not have any Microsoft account, simply try creating Microsoft account using your mobile phone instead of computer. You will get better experience, just my personal experience as well. So just up to you. Once you have your Microsoft account, then you can simply click on try Azure for free again, and then just simply sign in. Simple. Then it will ask you for your personal information, your card information, so that it can verify that, okay, you are the real person who will be using the services, because they give you $200 in credit so that you can use the services. So they need to verify, right? But do not worry, it is free. After 30 days, you do not need to pay at all. If you do not want to, you can simply cancel your subscription. And even if you do not cancel your subscription, they won't charge you until and unless you upgrade your account. Simple. Now, if you are already have created one Azure account in the past and you want to still use that account and your credits are over, then obviously you can upgrade the account and you can pick pay as you go, and then you will be just charged for the services that you use, and that's it. It is as simple as that. Okay, so I hope everyone will be able to create Azure account, and it is very basic thing, bro. You are trying to become a data engineer. This is a very basic step. Just go and quickly create your Azure account. So let's imagine that now you have your Azure account with you. Okay, so now let me bring my Azure account. So here is my Azure account. Okay, perfect. So Ansh Lamba, before pulling your Azure account, just show us how you can just log into Azure account. Very good question. So once you have your Azure account, now what you need to do, simply go to any browser and search for this link, portal.azure.com. So this is the URL that you use to log in into your account. Simple. Hit enter and then it will take you to the login page, and then after you log in, then you will see this thing, this particular web page. Yes, it might look a little bit different in your case because I have these services listed here. In your case, it will be totally different. So it is fine. Do not need to worry at all. Simple. Okay. So now let me just give you a very quick overview of Azure. If you are new to Azure, by the way, they have like very smooth and very simple UI, but still let's have a quick overview. So first of all, you just click, you need to click here in the 3 menu bar. Okay. And here, this is the area that you will use to quickly create the resources. Let's say all resources, that means all of the resources that you have created, then resource group, then app services, then function app, then Cosmos, and blah, 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 all of the services. To be honest, I do not use this pane, or you can say this particular tab at all. Why? Because if I want to use any service, I simply go to this search bar and I simply search for that service. But because it is the part of UI, so it's my duty to give you a quick overview. Simple. Very good. Now, by the way, this area is very important in this particular tab, because here you can just see your cost, your monitoring, your budgets if you have defined any. But if you are new to Azure, you do not need to set budgets, and if you are on free account, then you do not even need to care about cost. But yeah, this is the area that you can explore if you want to set some budgets for your cloud account. Simple. Good. Now let's talk about this area. This area is the area that you'll be using 99% of the time. So here you will see that you have some resources listed. These are the resources that you would have used in the past or more recently, right? So now let's say you have not used any resource. So what you should do, first of all, you should create a resource group. That is the non-negotiable. Ansh Lamba, what is a resource group? Resource group in Azure is nothing but a kind of folder. Just a folder. Yeah. So why did they just call it as resource group? They just like keeping names fancy for their resources. Okay. So resource group is nothing but just a folder in which we put our resources. Now, what are resources? Resources, all of these things are resources. Resources means services that we use from Azure. Simple. Very good. Resource group means folder. Resource means service. Simple. Good. So how you can create a resource group? Simply go to search bar and search resource group and click here. In my case, I will see a lot of resource groups because I have so many resource groups. I will simply click on create. Okay. You can also click on create because we'll be creating a new resource group. And resource group name, I will simply say RG, abbreviation for resource group. And let's call it as or let's say Uber project. Simple. Region, you can pick any region, your closest region if you want to pick. Okay, in my case it is Canada Central. Then I can simply say review plus create, and that's it. Create. So my resource group is created. and you will see it here. I have so many, so just ignore. I can simply search for my newly created resource group, which is let me just refresh. So where is that? I think it will take some time. Yeah, now it is here. RG Uber project. So this is the resource group, and currently you are seeing no resources are there, obviously because we didn't create any resource, right? So now what we need to do, we need to create the resource. So you can simply click on plus create button. Simple, very good. This is one way of creating resource within the resource group. I always recommend this thing to all of my data family members, that just always go to resource group first of all and then try to create a resource. But sometimes they do not listen to me and they simply go to home button and then they directly create the resource from here, which is not a wrong thing, by the way. Let me just show you the difference. So let's say I want to create event hub resource. So I will simply go to search bar and I will simply say event hub. So just click on event hubs. Okay, click here and then you will see all of the event hubs that I have. I created this for demo. Okay, now let's create another one. So now when I be creating the resource from directly the home page, like directly from the home page, then my resource group tab will be empty and I would need to manually select my resource group. You will say, Ansh, Lamba, you can easily select your resource group from this drop down. What's the big deal? The big deal is when you just have 1 to 2 resource groups, it's fine. But when you have so many resource groups, it's a pain to find your resource groups and sometimes you can just mess up with your resources. Okay, so just a quick tip, not a mandatory thing. So let's try to find our resource group from here. RG Uber project. Perfect. So now I have selected my resource group. Perfect. Now we need to just pick our namespace. Namespace for what? Our event hub namespace. Simple, event hub namespace. So I will simply say Uber events. Simple, Uber events. And region, again I can pick the closest region. Let's say Canada Central. Where is Canada? Yeah, here. Perfect. So pricing tier. Now this is very important. Do not rush. So now you need to click here on the drop down and you need to pick the standard, premium or dedicated. Okay. I know recommended is premium or dedicated because it is assuming that you have a very big enterprise, but you are learning. So you can simply pick standard. Ansh, Lamba, why not basic? So see, whenever you pick basic plan, then your Kafka topics would not be enabled by default. What does it mean? See, if you pick basic plan, you can still work with event hubs. You can still use SDKs to work with event hubs. You can still do all of the things that you need to do with event hub. But if you want your event hub to behave as a Kafka topic, you need to pick the standard, at least the standard pricing tier. Then they just give you the Kafka, you can say methods, Kafka protocols, Kafka connectors, everything. Simple, very good. Throughput is enough because we are simply learning. So we are not assuming that you'll be having so much of throughput. Enable auto inflate, bro, it's fine. Click on review plus create and that's it. And it will simply say create. Now it will create our event hub namespace, not event hub namespace. There's a difference between two. Let's see. So it will take some time, like hardly a minute to create this resource. Basically it is deploying your resource because event hub is a platform as a service. You do not need to manage the infrastructure. You do not need to worry about the hosting, because whenever you host Apache Kafka, you need to worry about the infrastructure as well, right? You need to worry about, hey, what will be my cluster size? What will be my machine size, VM size? Azure says, bro, you do not need to worry at all. I will take care of infrastructure, hosting, everything. You just need to use the service and that's it. That is the biggest advantage of Event Hub using Event Hub in our industry. Simple. By the way, I love Kafka as well. So, but obviously we always prefer ease. We always prefer productivity over the managing the infrastructure and all. Simple. So this is deployed, by the way. You can click on go to resource or you can go to home, or you can just go to resource group. That is the best way. and then you can search RG and then Uber project. Then within this RG, you should see event hub. Simple. Very good. Now just click on this event and you will see this is your event hub resource. Simple. This is your event hub resource. Now, the very important thing that I just told you, this should be enabled, and you can see this is enabled. And this will only be enabled if you have picked the pricing tier as standard, not the basic, standard. Simple. If you didn't pick the standard, just create a new resource with standard, or you can even edit it from here. You can just go to settings and you should just see some option to update the information. But if you do not want to mess up, just create a new resource and simple. Okay. Now, I told you that this is not an event hub. This is just an event hub namespace. So Ansh Lamba, what is the difference? There is no difference. Event hub namespace is like a bucket, because within the bucket you can create multiple event hubs. Oh, okay. So this is a kind of folder that you carry within your event hub resource. Makes sense? But usually we do not create multiple event hubs within the namespace. You can create only one and it's fine. So when you have just one event hub, it's equivalent to namespace. Do not worry, it's not very confusing, but I'm just giving you some extra knowledge. So you will see that we have Uber events as our event hub namespace. Now I need to create my event hub, my Kafka topic, kind of Kafka topic, right? Kafka topic. So now what I will do, I will simply go to overview, and this is the overview obviously. And here we have all the dashboard for request, messages, throughput, empty obviously. So I will say event hub. Let's create a new event hub, and this is the topic. Now I can say Uber topic. Why? Because this will behave like a Kafka topic. Simple. That is a folder, and within that we have topic. Let's say Uber topic. Simple. Partition count is 1. It's fine. Partition count is 1 is fine, because we do not have like much parallelism that we want to apply on partition count. By the way, I just want to give you some extra knowledge just for 1 to 2 minutes. It is helpful to you as well, for you as well. Partition. Whenever you work with real-time data, whenever you work with systems like, let's say, Apache Kafka, we create partitions. Why? Because it promotes parallelism. And one more thing that you need to remember, that when we create partitions should always be created on top of, you can say, a kind of category. Kind of. What it will do, it will simply allow better performance so that multiple consumers can read the data in a better way. Initially, if you're very new to this concept, let's forget about it. Okay, partition and all, because you'll be like totally lost. But when you will be working with this project, when we just you can say going along with this project, you will learn about all of those things as well. Okay, why I just told you this small information? Because you saw this thing, partition count. Because whenever you see something, you should know about those things. And the best thing that I find about all of these things is this I button. You should always read about these things. So see, partitions are a data organization mechanism that relates to the downstream parallelism. That means consumers. See, required in consuming applications. The number of partitions in an event hub directly relates to the number of concurrent readers you expect to have. Oh, okay. So that means when, let's say, you have like multiple consumers, then you can have like multiple partitions as well. Simple. Okay. Makes sense. So now retention. This is very important. Remember, while explaining the concept of event hub, I told you that we have an expiry date as well for the event. So here we have set the expiry date as 1 hour. Okay, 1 hour. Makes sense. And maximum is 7 days. That means we can go back to our data maximum for 7 days. And after 7 days, the data will be gone. In this case, if I just put 1 hour, then what will happen? We can only go back to our data till 1 hour. Okay. And I would say 1 hour is like too less for creating this tutorial. So let's say 48 hours. Okay. Let's say. And then we can simply say review plus create. Perfect. So now this is validated. Now click on create. Perfect. So now if you just scroll down, you will see this event hub. See, so this is my event hub. In the overview, then go scroll down and then Uber topic. If I just click here, you will see the information related to this topic only. See, this is the Uber events, which is the event hub namespace, and Uber topic, which is the event hub itself. See, event hub instance. Simple, very good. So now obviously this is active and this is ready to share the information with other. So now we should now create something called as policies. Why? Let's talk about it. Why? So let's say this event hub will receive the events by producer. Simple. Yes. Simple. Okay, good. Now tell me one thing. Event hub will allow the producer to send, or basically to, like, you can publish the events to my event hub. It's fine, but producer should be validated. Producer should be authorized to send the events, right? So let's say your web application, you built your web application and you want to send the events to my event namespace, or you can say event hub. Okay. And I will say, oh yeah, just send your events to my event hub. Yeah, everyone is allowed. Should I do that? Obviously no. I need to authorize some people. Hey, only you are allowed, not you. Like only I am allowed. Okay. So if I want to do this thing, I need to set some policies. I need to set some, you can say that, okay, let's take an example of college or university. I always take this example in all of my things if I just want to tell about the authorization. Best example. So let's say you want to enter into a university, into your college, and I hope that you went to university in your days, or you are in the university or college. I hope so. Okay. So let's say you want to enter into the university. What you will do? You will simply carry your ID card and you will show the ID card to the security guard, and security guard will allow you to enter the university. Simple. You need to show that ID card. So where is that security guard? Security guard is here. Let me just create that security guard. So this is the security guard. Not this one, let's say. Yeah. Let's say this one. This is like scary. So let's say this is a security guard. So this security guard is standing here. So this event, all the events need to have the ID card. So it will say, hey, you are trying to enter into my event hub. Who are you? Are you the student of this university? If yes, show me the ID card. So now when we just talk about this ID card into the Azure space, we call it as policy. Simple. And you cannot enter into the university if you do not have ID card. You can if you are Ansh Lamba. If not, you cannot. Okay. Ansh Lamba, you didn't carry your ID card? No, not at all. The security guard was my friend, was my best friend. I was like, because I hardly attended the classes in the university, and whenever I used to go there, security guard was like, oh bro, finally you came here, enter into the university. You do not need to see your ID card and just enter. I was like, okay. So now let's talk about the policies in Azure. So we have policies and I won't tell my college name obviously. So now, and I'm not talking about the college in Canada, I'm just talking about college in India. Okay. Chill scenes. Okay, so now here, can you see this settings button? Okay, if it is collapsed, you can just open it. Here we create those ID cards. Okay, so here you will go shared access policies. Perfect. And we do not have any kind of policy here. Very good. One thing that I need to mention here that is very important in terms of security. If I go to Uber events, if I do not open any kind of topic, if I am just at the namespace level, I will also see this shared access policies. If I click here, I will see one policy which is already created for me. I should never create the policy directly at the namespace level. Why? Because if you create the policy at the namespace level, you will allow that particular producer to send your events or send the events to all of the event hubs. Let's say I have let's say 10 event hubs here. Okay, currently I have just one. Let's say I have 10, But if I create access policy at the event hub namespace level, I would allow publisher to send the event to any event hub, which is not a good thing. You should always go to a specific topic, basically event hub. Then you should go to shared access policies, and then you will see no policies are attached by default. Simple, very good. Now just click on add, and here you have three things: manage, send, and listen. So obviously, if you want to provide the ID card to the publisher, so what exactly you are trying to say? That you can send the data, right? So you could simply say send, and policy name will be, let's say, send policy. Simple, and then create. So this is my send policy. Similarly, now if we talk about this thing, now what will happen? Now this is security guard 1. Okay. Now we have second security guard as well. Now, whenever this consumer wants to read any event, we have security guard here as well. Yes, we have so many security guards. So this security guard will say, okay, this time you do not want to save any information to my event hub, but this time you're trying to read my data. Are you authorized to read this data? If yes, show me your ID card. Okay, show me your ID card. So you can just imagine it like, let's say you appeared for the board examinations, right? You are not trying to enter into the school to study. You are simply trying to enter into the school just to sit for an examination, right? You can just treat it like that analogy. So you do not need to just write any data, but you need to read this data. So for that, we need to create a policy. So let's create that. Click on add, and then this time you will create the listen policy, because you want to provide the listen rights, basically reading rights. Simple. Simply say listen, and policy name will be listen policy, because I'm just using the same Azure naming space. Okay, listen policy. Simple. Send policy, listen policy. So these ID cards are created, and very, very good. This part is done. And you know what? Your event hub infrastructure, basically the platform is done. And good job. Very well done. So now let's try to talk about this part, web application to event hub. So now our event hub is ready to allow the producer to feed the events and consumer to read the events. But now we need to produce the events. We need a system which will produce the event. In the real world, Ansh Lamba, you said that this will be a web application. Yes. So Ansh Lamba has done a special work for you. So we will be working with the working web application. Yes, a kind of web app that I have created, and don't need to worry. I have just provided all of the code as well, so that you can also work with that thing. So we will actually simulate the real world scenario. I will host a web application, and there the person will go and book the ride, and then the event will be saved directly into the event hub. Let's see how we can just do all of these things. Because when a data engineer works with, you can say, event hub, yes, data engineer doesn't need to create this particular connection, but sometimes, and I would say in the AI era, data engineer would need to build this as well. Why? Because now the roles are not like very, very structured. Now you need to wear multiple hats if you want to grow in your career. You cannot say, hey, I am a data engineer and I should not build this connection, and you should just assign this task to a software engineer and blah, blah, blah. Bro, just try to say this thing. Just try to say this thing. And you should know about all of these things. This is not like a rocket science. You should just upgrade your skills, and you should be like open to learn all of the, not like actually build those things, but you should know about those things. Make sense? Okay. And do not worry, we will just use this web application. Don't worry, we will not be building web application from scratch. Do not need to worry. So now what we gonna do, we will take this web application. Okay. So here web application will be built, and it is already built. I will just provide you the code. So this web application has a function. Okay. So this web application has a function. So let's say this function. Now what this function will do, because obviously what is web application? Web application is nothing but just a kind of CRUD operations, right? Create, read, update, delete, and on every URL, on every button, it routes the user to a specific web page, and it performs something behind the scenes. Simple. So what this will do, this web application will have some function. Okay. So this function will do what? Whenever a user, let's say this user books a ride, and let's say this person books a ride from this web application. Simple. So what will happen? This function, this Python function will create a kind of pseudo, okay, a kind of simulated data related to ride confirmation. Simple. Okay. Then this function will also send this data to the event hub. Okay. Yes. We'll send this data to the event hub. Simple. And this time this function will also have the ID card. Don't need to worry. So we will use that particular policy to send the data to this event hub. Simple. That is a concept. And this time we can also say that this has this particular key as well, a kind of key. Simple. So that it can validate, okay, you are the authorized publisher who can just send the data to my event hub. Okay, very good. Now how we can just achieve this thing? Let me just show you the official documentation, because I am not cooking this code by myself. Everything is written in the documentation. Yes, everything, like how to send the event to the event hub. We have the SDK, Azure SDK, that we can use for this thing. Let me just make you aware with that thing. So let me just open Google and let's search, let's say Azure event, or let's say send events to Azure event hub, and just search something like this. You will get the documentation. Send or receive using Python. Okay, so maybe this one. Yeah, this is the documentation. So just try searching like this. You will get the official documentation and no need to worry at all. So this is the events of documentation, and within that we have Python language. You have .NET, Java, JavaScript, Spring, Go, C, and blah blah blah. We will use Python. We are data engineers. We love Python. So what you need to do? First of all, you need to have Python. Obviously, you need to have VS Code or any code editor. You should have event hub namespace. We have already created it. You should have subscription, obviously. So you should have all of these things. So now what you need to do as a prerequisite, you need to download Python in your system, in your laptop or in your computer. And I hope if you are a data engineer, you should have Python in your system, and you should also have one code editor. If you have VS Code editor, it's good. If any other code editor, it's still good. It's fine. Now you need to install these libraries that you can install. Okay. By the way, these all are not recommended, or you can say required. You can also go to connection string and you can simply install this one, because I'll be using connection string. Very good. Now we need to authenticate. The user to send the data to the event hub. We talked about this thing. Very good. We will use connection string. Use a connection string to connect to event hub namespace. If you are new to Azure, you might find the connection string option easier to follow. Okay. And obviously it is like easier to follow. So now what you can do, first of all, you need to get the connection string. Now how you can just get the connection string? You can simply go to this particular shared access policy and you can just get this thing from here. Don't worry, I will just show you how you can just get that. Simple. Very good. Now, if you want to send any event to the event hub, you have simple 2 to 3 steps. First of all, in your code, you need to create a function. Okay, you need to create a function. So this is the function. What this function is doing, first of all, this is using asynchronous functions. You do not need to worry about asynchronous behavior in Python for now. You can simply use your basic Python functions. But what exactly we are doing here? We are simply creating, first of all, producer client. Okay, this is the producer client. Producer client means you can build a connection through your laptop so that you can just connect with the producer. Simple. Then what you do, you simply create a batch. Why batch? Because every event is a kind of batch, right? So you simply create a batch like this. Makes sense. Then what you do, you add the event in that batch. Now, simple question, and you should answer this question. What is the event here in our case? The event is the Uber confirmation, right? Very good. So that is the event in our case. Simple. So we will simply add each event to our batch, and then we will finally send this data, send this batch to the event hub. That's it. This is the only function that you need. This is the only function that you need. Wow. Yes. So I have created the similar function, very similar function, but obviously with some changes, because in this example, they are simply sending this textual data, first event, second event, third event. But in our case, we are simulating the real world experience, and we have obviously set up our function in such a way that will create the data, which will mimic that how real Uber confirmation will send the data to the, you can say, any particular event hub. Simple. So here, obviously our code will look like something different to this, but the approach is exactly the same. Simple. Very good. So this is the base for your information, and you should understand this thing. So now I have opened my VS Code editor, and you should also open your favorite code editor, and you just need to do one thing. Open one folder, empty folder. If you see, go to file and click on open folder and create a new folder. I have created this folder, Uber DE project. Simple. Very good. This should be empty, and you can see it is all empty. Simple. Very good. Then you just need to go to my GitHub repo, which is this one, and then you will find this repository where I have put the necessary things for this particular project. Obviously, when you will see this repo, you will find data and all the things, but currently I have only put the scripts and the files that you need. Simple. What you need to do, simply go to this link. I will also provide this link in my description. So now you just need to go to, let's say, code, okay, and then go to this copy button, copy to clipboard, because you need to copy this thing. Okay, before doing this thing, you should have Git in your system. Being a data engineer, I would assume that you have Git in your system, but if you do not have, do not worry, I will help you out. Simply go to Google and simply say download Git, and you can say git install, and you can say Windows, and simply go to ARM64 or x64, and then simply click on this setup and download. Once you have Git installed, simply refresh your system, because sometimes it doesn't work if you do not refresh your system. And if you want to confirm, you can go to your VS Code or your CMD, open the terminal, and you can simply say git -- version, and you should see git version if it is successfully installed. Simple. Very good. This is the first thing. Second thing, you need to install UV. UV is the modern Python package manager. You can simply say pip install UV like this and hit enter. Okay, like this. Requirement already satisfied, because I have already downloaded this thing. In your case, it will be downloaded. Simple. Both the prerequisites are completed. So now what you need to do, you simply need to go to this code button and copy this thing. Simple. Go to VS Code and simply say UV init. UV init command will first of all initialize your virtual environment as well, plus Git as well, both the things. Hit enter, and you will see all of these things. See, so many things. Very good. Now, obviously, you will see so much of things when you will just do git copy or whatever. So simply ignore what you have done so far. It's fine. So UV init is done. So with your UV init, you will see .git folder here. Sometimes you do not see if your folder is hidden, but do not worry, .git folder is there. Simple. Very good. Now what you need to do, you simply need to clone my repo. You will simply say git clone and paste that particular, you can say, your URL. Simple. Then you can hit enter, or what you can do, you can obviously skip this part UV init here, because we will be just creating our virtual environment after going into that particular folder. But it's fine if you have created it, it's fine. We will simply ignore it. So I'll simply say git clone and this URL, hit enter, and then it will clone the entire project here, Uber Data Engineer project. Simple. This is the project that I want to use. So now what you need to do, you need to go inside this folder. Okay, so what you need to do, you need to go to file again, and you need to go to open folder, and this time you will not select this folder. No, you need to select this folder and then you need to click on select. Makes sense? Because I want to keep this folder as my root directory. Okay, so let me just quickly do that. So this is the folder that I have opened and this is the inner folder that I have. Simple. As you can see that this is my root directory. You need to open this folder as your root directory because otherwise you can just mess up with things, and you should never see this folder here. You should always see this folder here at the top. Simple. Very good. And I hope that you would have opened this folder like this. Very good. So now let's get started with the installation of our packages, because we need to use so many packages in order to work with our files. So what I will do, first of all, open the terminal and make sure that this folder name matches this folder name, so that it will make sure that we are at the right directory. Sometimes it opens a folder at this level, but you need to open the terminal at this level. Simple. If you are at this level, Uber DE project, then just write cd and just type this folder name and that's it. Simple. But we are at the right level, so we are good. So what you need to do, first of all, you need to create a virtual environment because we do not want to install our packages in the global environment. So I'll simply say python -m vnv, then name of the virtual environment. .vnv is a generic practice. Hit enter and it will create this .vnv here. Very good. Now I will activate it. So I will say .vnv, then scripts, and then activate. You should see this thing .vnv, that means this is activated. Now we need to install all of the packages. Now all of the packages are listed here in the requirements.txt. So I will simply say pip install -r and then requirements.txt. Hit enter. It will obviously take some. You may have installed Python into a global environment which can cause conflict. So now let's wait for it to install all of the packages in our virtual environment. Okay, very good. So this is done and I can confirm this thing manually. I like doing it. I will go to library and I will see all of the things. Very good. So my virtual environment is created with all of the packages. Now I need to show you the code finally, because now you are good to go to run this code. So first of all, I will just show you the data.py file because these three are the major files. Data.py file is a file which takes care of all of the data generation. So in this file, first of all, you do not need to worry about the code because this code is just written to generate the data which simulates the Uber ride confirmation. Make sense? So I have created this function, generate Uber ride confirmation, and here you will simply get the data that you would receive in the real world, or you can say if you are working in an organization, that you would receive from the web application. Simple. Okay, so this function is just doing that thing, nothing fancy. And we are not even running this file because we simply import this function in the connection.py file. So you will see that I have written this file from data, that means a file name, import generate Uber ride confirmation. Okay, and obviously some packages, obviously. Good. Now this is very important. If you would see the documentation, you would have seen that we use always two variables, connection string and event hub name. Now what are these things? These things are written in the Azure network itself. So if you will see the policy, send policy, this is your connection string. Why? Because if you open the official documentation, you will see that get the connection string. How we can just get the connection string? It will show you this method. Go to shared access policies. We do not need to go to root manage shared access key because we have created our own manual shared access keys using send and read policy. So we will go there and we will get the primary key connection string. Simple. Very good. So I will go to my Azure and I will go to send policy because we are allowing publisher to send the data. Perfect. So I will simply copy this thing, primary connection string, and I will paste it here. Now, instead of pasting it in the main file, which is not a good practice because this information is sensitive, you should always create a .env file like this, and you should paste the key here. So I will create connection string variable, connection string, and then I can just paste my key like this. Make sense? Very good. Obviously, I will just revoke it, so it's not a big deal, but I'm just showing you how you can just do this thing. Make sense? Very good. Then, yeah, you can just revoke your policies and all if you just go here Here you can simply delete it, obviously, so no one can just use it, okay, for your future use cases, but I'm simply showing you how you can also do it. Okay, so my send policy is done. Now I need another variable which is called event hub name. This is your event hub name, not your namespace. So we know that our event hub name is Uber topic. How does it know? Okay, I think it would be written in the connection string. Okay, makes sense. Okay, so we just need these two things. So I can just now create the environment variables using those two methods. Using which function? Using load.env. So these are like very basics of Python, so we do not need to worry about that. So this way you can import those environment variables in your environment. So this is the function which is called send to event hub. So this function, what this function will do, first of all, this is like very similar to the documentation. Okay, so what this function will do, this function will first of all create a client, producer client, same thing. Then it will simply get the right data. Now you will say, Ansh Lamba, how will it get the right data? We need to pass it as a parameter. See, oh, so whenever we want to call this function like send data, we need to pass the data. Hey, send this data, this that I'm providing. Simple. Then event batch, same thing, the same code that we saw in the documentation. Then we use event data built-in function. Then we just add that event. Then we simply send that data and close the connection, and that's it. Okay, very good. So now that is exactly what I'm doing here. So simply, first of all, get the data using generate Uber ride confirmation. So ride will be having our data, the simulated data, simple. And then I am also printing it just for your reference. And then I'm simply calling this function which is called send to event hub. Simple, nothing fancy, just two steps. Generate data, send data, generate data, send data, generate data, send data. Simple. Now, in order to work with this thing, you simply need to run this particular button, or basically run this file, and that is it. That is it. Let me just show you. So if I click here, run Python file, let's try to run this file and let's see what will happen. Let's wait, and it is activating the environment, and done. So everything is coming on my terminal. It is saying single write event sent to event hub, successfully sent to event hub. Very good. Let's see if we have sent the data successfully. So if I go to, let's say, Uber topic, our event, right? This one. If I go to overview, and if I go to data explorer, and if I go to view events, because I want to view my events, so I should see that data here if everything is fine. Let's see. Perfect. We have got our first data from the publisher. Sequence number 0, because this is the very first data. Offset 0, partition ID 0, in queued time when it was like queued, and then this is the data event body. If I click here and if I just expand this, scroll down, you will see this data. Wow. So this is the data that we are getting from the publisher. Wow. And this has all the things: ride ID, confirmation number, driver ID, pickup location, passenger name, blah 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 blah, because we are using simulated function which generates this data, and this is a random data, just pseudo data. Wow. Yes. So you need to simply run this file every time you need to generate the data. Simple. Very good. Now, just to give you a better experience for learning, I have created this API here so that you can enjoy while learning. If you are building this project, you do not need to run this API first of all. Okay. First of all, I will just still show you how you can just do that, but it is not required. You simply need to run this connection.py file and it will do all the things. But just for the better learning experience, I have created this API. So I will simply click here in the api.py file. Okay. And I will now run this particular API. So I'll simply say uvcon API app reload. And I will host this application on my local host, this thing, and this is my application. So it is simple application. It is saying welcome to ride booking service, book your ride with us and enjoy a seamless experience. Okay. So I will simply say, I want to book my ride. Okay. Let's book. I will click on this button and it will say your ride has been successfully booked. Thank you for choosing our service. But let's confirm if our ride is booked or not. Okay, so let's go here and let's go to, and let's refresh or click on view events. Now this time we should see two events. Okay, because I just booked one ride using the UI as well, and perfect. You can see that I have got this thing 1576 and NQ time is this one, and then ride ID. Wow. Let's say I want to book another ride, or let's say another user is booking a ride. Let's say book a ride again. Now let's see if we get that particular request. Let's see view events. Now we should have 3 rides, and perfect. This is working absolutely fine. So this is a kind of UI that I have built, or you can say API that I have built for you. You do not need to run this thing. First of all, let me just tell you, simply run Python file, everything will work for you. But if you are enthusiastic and if you just want to put this project in your resume, and if you just show if you if you just show end-to-end project, it obviously gives you a better edge over others. So if you want to run this fast API, it's very simple. You already have the fast API dependency here. I think we installed it. Yeah, we have UVCon as well, and we have fast API. Yeah, we have fast API as well. So what you need to do in order to run this thing, simply go to terminal and run this command that I have ran. Okay, and what was the command? Where yeah, here it is. UVCon API. API means the name of this file. Okay, then app, the instance that we have created here, and then reload. That means whenever you make some changes, it will be automatically reflected. Sometimes this command will not work, sometimes. Okay, so what you can do in that particular scenario, there is one more command. It is called let's say Python and then api.py. Hit enter. This time it will run the application, but it will give you this particular URL. If you will click here, it will not open the, you can say, application. You can still try. It will simply say site can't be reached, but the app is running because you can see it in the terminal. Makes sense? But what you can do now, you can simply type localhost and go to port 8000 and hit enter, and you will see this application running. Simple. This is the simplest way to run the application, because sometimes UVCon is blocked or UVCon is not allowed to run the application. That's fine. Now if I click on book a ride again, we should see the event here. So this is like a kind of connection, or you can say pipeline, small pipeline that we have created. Whenever a person clicks on this button, the data will be automatically sent to the event hub, because we are using the routes here. See, I am using first of all the home page, then this route book will automatically call these two functions. See, these two functions, and it will simply return the new template. And I am using some templates here, like the HTML templates, very simple code, nothing fancy, like very basic code. Okay, simple. So now let's see if we are able to see the fourth data, because we just hit the book ride again. Okay, perfect. 0 1 2 3. Yes. So finally we have seen like how we can just generate the data, and I hope like this particular UI UX will actually give you that experience how you work in the real world. Because see, when you want to learn something, you need to see the things in practice and in a practical approach. Okay, so I hope this small, because it's not a very fancy API that we have built, but this small thing will actually give you a better learning experience. I personally feel so. So I hope this small addition will make the difference. I hope so. Okay, do not just keep on clicking this button. I know like it's fun when you host your own API for the first time, but do not do that. Like you can, because you have the event hub, but yeah. Okay, simple, very good. So this is this particular part is completed. This one, where we have this person going to the web application, function is automatically calling the you can say routes, and data is going to the event hub. Very good. This is the backbone of the entire project. Okay, so our event hub is ready to listen all of the things. Simple. Now what we need to do, we need to say another source that we have. This time will be API to data lake. Simple. Or you can say ADF. Not ADF 2, because ADF is not a source. ADF is just like a kind of pipeline solution that we have. ADF data lake like this. So now what we need to do, we know that we have some data. We have some data sitting in the GitHub repository, or basically a kind of web application again. But this web application is not for the real-time processing. This web application is just for storing the long-term data, storing the, you can say, bulk data, storing the static data. So this is a kind of internal web application that we create within the organization. This can be a GitHub repo, this can be a data lake, this can be anything. But for this project, we'll be using GitHub repo as our source. Simple, very good. Now what I will do, I will simply use GitHub repo as my data source, a kind of web application to store my long-term data and static data, which will not be like changed very easily. Okay, makes sense. In the real world, you can simulate this thing with something called as internal web applications, which is just for the internal teams. Make sense? Okay, so now what I will do, I will use an amazing technology within Azure. It's called Data Factory. Okay, so I will use Data Factory to pull the data from GitHub, and I will push this data to the data lake. Perfect. Make sense? So we will build the pipelines as well, because we use Azure Data Factory a lot whenever you want to work with the orchestration, data fetching, data migration using Azure network. We use Azure Data Factory 99% of the time. Yes, because I have worked with like many tech stacks, I have not seen any framework, technology, software, anything better than Azure Data Factory to work with data fetching and data orchestration and data movement and data migration. I have never seen any tool and technology better than ADF. I have never seen. Do not say like Synapse Analytics. In Synapse Analytics as well, we have ADF embedded. Okay. Do not say Fabric, because in Fabric as well, we have ADF embedded. I have never seen a technology like ADF. ADF is like next level, is on next level in terms of UI, in terms of UX, in terms of ease, everything like top notch. So obviously we'll be just using ADF because ADF is actually in demand. ADF was in demand and ADF will be in demand. ADF is like evergreen backbone of Azure tech stack. Simple. So we will be just using ADF to work with this particular piece, this data migration. Simple. Let's do this. So now what we need to do, we will simply create an Azure Data Factory instance. Okay, similar to Azure Event Hub. Simple. Just go to resource groups and then just search your recent group, RG Uber project. Where's that? Okay, perfect. Here. So now here we will create Azure Data Factory instance. Simple. Very good. So let's quickly create that thing. So it will open the marketplace and then simply search Azure Data Factory. Perfect. So just pick this one. And this is a kind of Azure benefit eligible. Okay. There would be something. And then you can simply click on create and this will create your Azure Data Factory instance. Perfect. Good. So now it is asking for name. Let's give it as, let's say, ADF, and then just pick the Uber project and then let's say dev. Simple naming convention, ADF hyphen Uber project / dev, because this is a dev environment. Region is East US. Yeah, just pick this one. It's fine. Version V2. We recommend you upgrade to Fabric Data Factory for a modern unified data integration experience. Try Fabric instead. Yeah, we know that Fabric Data Factory is the future and Fabric Data Factory is the enhanced version of Data Factory, but 90% of the things are same. By the way, it's fine. So now it is done. Click on create. So now this will deploy my Azure Data Factory resource. Now what is an Azure Data Factory? Let me just tell you if you do not know about this. It's very simple. We can go to resource. So now quickly talk briefly about Azure Data Factory. So basically Azure Data Factory is your low no code solution available in Azure for ETL/ELT. If you want to migrate the data, that we are going to do in this scenario, moving data from GitHub to ADLS Gen 2. What is ADLS Gen 2? Data lake basically. So you can just do that thing. If you want to perform some transformations while migrating the data, you can do that, but it is not recommended to apply the transformations when you are moving heavy data, okay, big data basically, because that is why we have a concept called ELT. First of all, extract and load and then transform. ETL was used in the traditional approaches when we didn't have like much bigger data, but now we deal with a lot of big data, so we do not perform ETL, we perform ELT, and that's the thing we will be performing here. We will simply extract the data and we will load the data in the ADLS, then we will perform the transformations using Databricks. Simple. Okay, perfect. So now let me just take you to the Azure instance. Okay, so if you just go here in the resource group, I just need to open my resource group, which is this one. So now this time you can see this ADF project. I would need to create one more thing, one more resource, which is called data lake. Why? Because obviously data factory is not data storage solution. It is a kind of data orchestration, data migration solution. So I would need a data lake. So for that, I will simply search storage account, and you just need to pick this one. Just make sure you are picking the services which are offered by Microsoft. Simple. Then create, and then finally storage account name again. So here I will simply say data lake DL, and then Uber project, and then you can say dev. Simple. Oh yeah, in the data lake we do not put hyphen, so yeah, it's fine. DL Uber project dev makes sense. Okay, now Canada Central and standard is fine. Just pick LRS for low cost. Okay, and then preferred storage type, I will simply say ADLS Gen 2 because it will automatically pick the primary workload, and then primary workload is big data analytics. Just make sure you're picking this thing, because otherwise you would need to manually check this box, which is this one, hierarchical namespace, which is for data lake storage instead of blob storage. What's the difference? Nothing much, but you cannot create hierarchical folders in blob storage, but you can create hierarchical namespace, basically folders, in data lake. Okay, just a quick knowledge. Then you can say review plus create, and then perfect. This is like very quick deployment because data lakes are very easy, very quick to deploy, very cheap. Data lakes are like amazing. So it will be just deployed within few seconds. And meanwhile it is deployed, I want to show you one more thing. So as you know that this is our GitHub, right? So within this GitHub, now you have one more folder that I have recently pushed, which is called data. Within this data folder, we have some important data for our project. And in this use case, you can say important data for our solution. If I open this data folder, what do I have? I have, first of all, this important file. Do you know what is this file? This is called bulk writes. What does it mean and what this file will do? Bulk write means initial load for your data. So for example, let's say you are working with this solution. Here, let's say like this. So here you have real-time data where you are immediately loading the data into the events hub, and then you are processing it, right? And you are then traveling that data and building medallion architecture. Then you are just creating slowly changing dimensions and so many other things. But before applying, or you can say while applying this particular method, you also need to initially load the data, like all of the data that were already generated before this solution existed. Make sense? So this concept in the real world is called as initial load. So let's say you are a data engineer, you are onboarded on a project, right? And you are supposed to build this solution in Azure and Databricks. Simple. Let's say you are onboarded on 27th of February, like let's say today. Now, obviously you can just develop the solution, but you will simply ask one question. Okay, I can just develop the solution for future request, for future bookings, but I would need to store the historical data as well. Make sense? So historical data always migrated through an approach called lift and shift. You would have heard this concept called lift and shift. That is specifically used for your historical data. So let's say you want to just load all of the data so far, maybe let's say 10 years of data, 5 years of data, 2 years of data, 1 year of data. It depends like how old your organization is. So you always perform something called as historical data load, or you can say lift and shift. Simple, you need to remember this concept: lift and shift, historical load or initial load, whatever you want to say, the concept is same. Simple. So this file is actually that historical load, and in this particular file we have 2000 plus writes because our organization is new and we do not have much writes, but 2000 writes are there. Simple, very good. Now what about these files? These files are called mappers, or you can say mapping files. So whenever we are loading the data, or you can say whenever we are generating the events, we are getting some information which is very useful. Let's say ride ID, location, customer ID, and all of those things. But sometimes we need to provide more context to that data. For example, city, for example, payment method, for example, status, for example, vehicle make, vehicle type. So for all of these things, obviously you will not generate this data using a publisher, using a producer. Your organization need to create these mapping files which are related to the data which is being generated on a regular basis, or you can say on a real-time basis. Makes sense? Because you cannot generate all of this data. Why? Because these are the mappers, these are the mapping files that provides context for your events, which is not subject to vary as per you vary. Let's say as per you just go from one customer to another customer, or let's say if one customer has a specific detail around a city ID. Yes, city ID can change, but the information or the context regarding that ID won't be changed, or even if it will be changed, it will be changed through the event, not from these files. So that's why these are called mappers, or you can say mapping files, or you can say mapping tables as well. Simple. So we need to load this data. Now the real task is started. Now the task is we need to use Azure Data Factory to load this data. Now you can say, Ansh, Lamba, data is sitting in GitHub. We need to use Azure service. How we need to connect these service? Like how it is possible? I will just show you how is it possible. So in Azure, we have something called as, first of all, let's open the Azure Data Factory and then we will just talk about it. So RG and Uber project, perfect. So launch studio, perfect. So now this will open the Azure Data Factory portal. Yes, we have a dedicated portal for Azure Data Factory because it is a kind of end-to-end tool, end-to-end software. That's why we do not run this software inside Azure network. We have a dedicated portal and dedicated domain as well, which is called adf.azure.com. See, and setup code repository. No, we do not need to worry about that because we are the single developer for now. Start assessment. It's fine. So now they're just promoting Fabric, so it's fine. So now what we need to do, this is our Azure Data Factory. And obviously if you want to learn Azure Data Factory in detail, I have a dedicated course on Azure Data Factory that you can definitely check. I can even show you Google Azure Data Factory full course, and then just type Ansh Lamba. You will find a dedicated course on Azure Data Factory. There are two courses, by the way. This is the beginner one and this is the pro one. That means this is for beginners and this is the pro course that is for advanced developers, because I have covered some advanced use cases and scenarios in this one. Okay, so if you are a total beginner, just go with this course. Ansh Lamba, do we need to learn ADF completely for this project? Not completely, but if you have a very basic understanding, it will be good. Very basic. And do not worry, I will just tell you a lot of things meanwhile doing this thing, because this project is built especially for that particular purpose. Even if you do not have knowledge, you will still learn it, because this is a kind of project guided learning. So you will directly learn the things meanwhile working on the project. But after completing the project, if you want to gain strong hands-on on Azure Data Factory, if you are, let's say, sitting in the interviews where Azure Data Factory is one of the main tools, then yes, After completing the course, or basically after completing the project, you can check out this course, which is also available for free on YouTube. Simple. So it is just a kind of tip, or you can say gift for you. You can just enjoy. So let's get back to the point. So this is our Azure Data Factory. Here, the things are very, very simple. Let me just tell you. This is the home page that we never use. Yeah. And this is the pencil button, which is called author. And this is the tab that we use most of the time. Simple. Because this is the canvas where we build our pipelines and all of the stuff. Then this is the monitor tab, which helps us to monitor our pipelines. If any failure is there, anything regarding that. Then we have this manage tab. This is very important because in the manage tab, we manage our all the connections, our all of the, you can say, linked services, data sets, everything. Do not worry, I'll just tell you what is that thing. And at the end, we have knowledge center. If you want to learn something using official documentation, this is the place for it. Learning center. Okay. So now let's quickly go to the author tab, directly jump onto the hands-on, and they should just add one button to replace this ribbon because this is so irritating, but it is what it is. They are just promoting the things. It's fine. So now this is our canvas. Here we have pipelines, CDC, datasets, data flows, Power Query. So these are basically the categories that we have within the ADF. Like this tells us like how and what exactly we can do with ADF. And obviously we need to build pipelines. So we'll simply click on this button and this will show nothing because we do not have any pipelines, right? So let's create our first pipeline. Click on these three dots and click on new pipeline. Perfect. So this is our pipeline canvas. Okay. First thing first that you have to do is rename this pipeline. So I will just name this pipeline as HTTP to you can say ADLS. Okay, this is the name of my pipeline that I have provided. You can just pick any name. By the way, this is also a good name, so you can pick this one as well. So this name is good. You can click here to collapse this space. Perfect. So far so good, simple, easy going. Okay, now let me just level up. So now we need to migrate the data, right? Very good. Now in Azure Data Factory, we have low no code solutions available. That means you do not need to write any code. No, that is the best part of ADF. But that doesn't mean that you do not need to know about the things. That doesn't mean that it is not powerful enough to do all of the custom things. It can do literally everything. That is why I said low code, not exactly no code. It is not just drag and drop. People are mistaken. They think like ADF is just like just no code drag and drop thing. Exactly not. For very, you can say, beginner level tutorials where you are exposed to some drag and drop ETLs, it seems like it is just a drag and drop ETL. But when you actually work with this particular technology, when you use expression builder is the backbone of this particular technology. And when you need to write the expressions with variables and loops and if conditions and switch cases and so many things, then you feel like, okay, we need to write a lot of code. But obviously you need to land on the right channel for all of that information. And luckily you are landed on the right channel finally, and just hit the subscribe button if you want to stay updated with the insightful videos. Okay. And I know you have already clicked the subscribe button. Thank you so much for that. Now, so these are the activities that we have in the ADF. These are nothing but, you can say, a type of categories that we can perform within the pipelines. So let's say I want to move my data. So I can click here and I will find all of the relevant activities, copy data and data flow. If I want to, let's say, use any kind of Databricks services, so I will see all of the Databricks activities. Simple. When you use ADF for 2 to 3 times, you will hardly click on these things because you will remember the activity name. For example, I want to migrate my data. The most popular activity name for moving the data from one place to another is copy activity. Everyone knows about it if you are from Azure background. Okay, if you are not, now you know. So it is called copy activity. So I have 2 ways to do that. I can click on this thing or I can simply search copy, and this is the activity. I can drag and drop it here. Simple. Okay. and this activity is there, and I can now collapse this thing just to have more space. So now this activity is here. This activity will simply perform the data migration. So I will provide a name to this activity quickly. I will say HTTP ingestion. Simple. HTTP ingestion. Makes sense? Very good. Now, just tell me one thing. If you want to load data from one place to another, yeah, what are the things that you need? Use your common sense. Let's say I have this data, right? Let's say this one. So if I want to load the data from GitHub to ADLS, first of all, I would need to build the connection, right? I would need to build the connection so that my ADF can talk to GitHub. Common sense. Common sense. GitHub can talk to ADF only when there's a connection, right? Very good. ADF can talk to data lake if there's a connection. Yes. So in ADF world, we have a fancy name for connection which is called linked service. Linked service, right? So let's try to create those connections. And here is the thing. So now there are two ways to create those linked service. Let me just tell you the best way. Just go to manage tab, and here you will click on linked services, and here you will click on plus new. Simple. Click here, and here you will see all of the options that you have to create the link services. But here we just need to build the connection with GitHub, right? So if you will just search GitHub, you can find GitHub. It's fine, but we usually do not create connections with GitHub. We just use HTTP client, this one. Okay, why? Because we can directly fetch the data which is available in GitHub using HTTP connection. Now there is one more service similar to HTTP. It is called REST API, like this. Okay, you can just use REST API as well, but with REST API, you will get the response in JSON format, and then you will be just applying your brain to clean and do all of the things. So it's simple to just apply HTTP. HTTP is a kind of linked service that you use whenever you want to make any API call, right? And obviously we'll be making an API call to our GitHub to fetch the data. Simple. So click here, HTTP, and click on continue. And here you need to provide the link service name. I will say ls, that is link service, and then GitHub. Simple. And now integration is fine. Base URL. Now I need to provide the base URL of my GitHub repo. So here I will just provide the base URL till .com, because this is the base URL, github.com, or not github.com. Actually, it is not the base URL, because this is the base URL for this GitHub page, GitHub web page. But I want to download the data, right? So I will simply click on any JSON file, right? And this is, sorry about that, we cannot show files that are big right now. Okay, no worries. I can just open any other file. Perfect. So this is, just open any file. Why? Because then you need to click on raw, because then this is the base URL that you would need. Simple. This is the base URL. Just mark this thing, because this is very important. So I will use this base URL here. Perfect, right? So it is saying information will be sent to the URL specified. Yeah, we know that. Authentication is basic. I would say anonymous, because that repo is public, so anyone can just access it. And I will simply test connection here. Okay, perfect. That connection is successful. Simply say create. Perfect. So my linked service is created. I simply created my link service, basically connection with GitHub. Similarly, I want to create one link service with my data lake as well, so that I can push my data, right? Perfect. So here I will say data lake. So here you cannot write data lake, right? Like this. Like you can write, but the good way is always write Azure Data Lake Storage Gen 2, because sometimes people just make mistake and just type Gen 1. Always pick Gen 2. Okay. Then continue and ls data lake. Perfect. And now authentication type is account key. It's fine, because we have the ADF and data lake both in the same resource group. So it will automatically authenticate it, and it's fine. And if you use Azure Synapse Analytics, then yes, you have to use managed identity for reading the data, but it's like you can say admin level stuff, so you can simply ignore. And Azure subscription is simply this one. and storage account name. Now it is asking which storage account you want to use while making the connection. I will simply find my connection. I will say, I think it was data lake and then Uber project. Yeah, this one. This is the data lake that I want to use. And I will say test connection. Once it is approved, perfect. Then I can say create. So both the connections are created. Perfect. Very good. Now, here comes the critical part now. Okay, now listen to me carefully. Now our base URL is ready, which is this one, till .com. Tell me one thing, if I make an API call, if I just make, you can say get request on this URL, will I get this data? Obviously not, Ansh Lamba, because this is a very generic URL. Exactly. That means I need to provide rest of the URL. This one. Yes. So that rest of the URL we provide in the form of data set. So once we create a linked service, then we create data set. Why? Let me tell you why. So let's say you have built a connection. So the connection is perfect. Now you have created a connection with GitHub. You now need to specify where your data resides. You created a connection with GitHub. Simple. Simple. Here. Now you need to tell within the GitHub space, because GitHub is so huge, where your data resides. That is called data set. Simple. Very good. Now let's do that. Now, how to create data set? So you cannot create data set from here. If you want to create data set, you have to go to author tab. Okay. And within the author tab, you will see data sets here. See, so let me create a new data set here, and it will ask which data set you want to create. I will simply say HTTP. Simple. And then continue. Make sense? So here now we need to pick the data format. It is saying, if you want to tell me the data, like where your data resides, also tell me what type of format your data will be in. So I'll simply say JSON, because my data is in the JSON format. Simple. Okay. Because we have the JSON files. Click on continue and name. This is the name of data set. So I will simply say DS, which is data set, and I will say GitHub. Again, GitHub. Link service, we have already created one, so we do not need to click on plus new. Simply pick this one, ls GitHub. Simple. Now it is asking me to create the relative URL. Okay. So the relative URL will be the rest of the URL. So if you go to GitHub, this one. So here you can copy rest of the URL till the end. Okay. After .com/. Okay. Just look here. You do not need to copy the slash just after the slash, because it will automatically add the slash. Simple. Very good. Do not need to import schema. So simply say none and click on OK. So this is my data set, and I have opened this data set here automatically. Now comes the amazing thing. That is a kind of real-time scenario as well, which will be there in your interviews for sure. Okay. Like if the interviewer is good, obviously he or she should ask this question. If I'll be your interviewer, I'm gonna ask this question, but I would know like you have already watched my video, so you can answer this question. So now the thing is, let me just ask you one question. We know that our data resides here, right? Here in this URL, and I can easily bring this data using this relative URL. That is fine, but that will only work for one activity, right? That will not work for all of the other files. Yeah, that is fine. Not fine. This is not fine, because let's say currently I have how many files? I have 1, 2, 3, 4, 5, 6, 7 files. Why do I need to create 7 different activities just for 7 files? So what? So where you are saying we do not need to create files? No, not at all. What you need to do, you need to create a config file. And this is the basis of metadata driven ingestion. Oh, okay. So what we are trying to do, we will simply say metadata driven configuration means, or basically metadata driven ingestion means, you will create the pipeline once, like this pipeline, and you will reuse it for all of the other sources as well. Simple. All of the other sources as well. So now what will happen here, I will say I want to provide relative URL, right? So instead of hard coding the URL, I will parameterize it. What do I mean? So if I just click on, let's say, this file, I will have this URL, click on raw, and then this URL. So I know that rest of the URL from the start till the end, only and only this part will be changing, right? File name, but rest of the things will be exactly same. Yes, yes. So if that is a scenario, I can parameterize this thing. Oh, wow. Yes, that's exactly what we need to do. So I will simply create a parameter here and just go to parameters, click on plus new, and I will say file. Okay. Or I can say p file, which is a standard practice, and value string. Very good. And then connection. So now what I will do, I will go to my relative URL, click on add dynamic content. Okay. This time you need to paste the entire URL, this one, like after slash, and just copy the whole thing for better typing, this thing, and remove this map cities.json. Simple. And here you need to put the parameter. And how you can just put the parameter, simply click on this parameters like this, and just a small fix you need to make, because by default it will add the parameter at the rate at the beginning. You need to add the rate here. Okay. Once you add the rate, then you need to add a curly braces like this. This is very similar to f string. Now this thing is not a string, this is a variable. This is the way we add a variable in any activity. Simple, 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 simple. Now click on OK. Now this has become your dynamic URL. Now if I click on the connection like here, okay, now I can just reuse this particular data set for all of the files. Simple. Very good. Now you will simply say, Ansh, you have created the variable there, basically parameter in the data set, but how will you feed that parameter? Because we have 7 files. Let me ask you this question. How will you feed this parameter if you are working in your programming language? How? If let's say you have a variable and you want to pass the value, how will you do that? It's very simple. I can create an array and I can run a loop and I will just feed that thing like this. Let's say I have an array. So I can say for I in array, whatever array is, and then I can say I. Exactly. Here as well, you need to do the same thing. Exactly same thing. Okay. So we will create an array with all of the values that we need to write. Oh, okay. So let me just create an array with online notepad so that you can also create it with me. So here's a notepad. So in the array, we need to say, like this is the array opening. Okay. And we will create a dictionary. Why? Because we need to create multiple objects. The first thing will be file name. Okay. File name will be this one, mapcities.json. Simple. Map city. Oh man, so many ads. Mapcities.json, comma, second object. Second object will be location, where we need to write the data in the data lake. Oh, so whenever we just want to write the data in the data lake, we also need to provide the folder as well. Simple. So I'll simply provide the folder, and here I can remove this .json. Makes sense. Then it will be a very quick one because I can just use this thing for the folder as well. Yeah, let's use this thing only. Let's say 5. Simple. So this is my first dictionary, and same way I can create multiple dictionaries like this. Some people will say, do we need to create this dictionary? Like when I created one project, and in that project as well, I just showed something similar to this. So the person was saying, hey, yes, it works with all of the solutions, and we can just create metadata driven pipelines, but we are still creating this config file. Is there any way to automatically bring data without config file? Very good question. And it is called magic. And in data engineering, we do not perform magic. We build something logical, which is very, you can say, understood when you work with data domain. So the answer is you cannot bring the data without doing anything. It is not like thinking about it and data will appear. You need to build something. You do not need to build everything from scratch. That's why we are building the config file. Now you are saying you do not even need to build config file. Very good. Very good. Very good. So you need to build config file. There are smarter ways to build config files. Instead of manually building config file, you can create a Python script to populate that thing. You can ask these questions. It makes sense. But do not say like, oh, do we need to still create config file? How will you ingest the data? Is there any special button that you need to press and it will be automatically loaded without telling what is the source, what is the destination, what is the file name? Amazing, amazing. So now what we need to do, let me just write all of the file names quickly. So the file name is, first is map cities and then map cancellation. Let me just quickly complete it. So all of the items of the array is completed. Let me just copy and paste it in my ADF. Perfect. So now what we will do, we will paste this array, but where? Now I have two options. Okay. Let me just tell you both of the options because I just want to share all of the information. The first option is you can create a pipeline level variable. Let me just click on this blank canvas. You will see parameters. That means we can even create the pipeline level parameters. Okay. You can click on plus new. You can create a parameter like this. Let's say files array, and I will say array type, and I can paste the array here. That is one way of doing it. Second way to do is you can go to your data lake. Let me just show you. Go to data lake, and here you can go to containers on the left hand side. Okay, under data storage. If it is collapsed, open it. Under containers, you can create a container. Container is just like you can say root directory. I will say raw. Okay, let's say create. So this is raw container, and within this container, this is empty, obviously. Now what I can do, I can create one file, or basically I can upload one file. So what that file will do, that file will contain this array information. That is a second way of doing it. And that is all obviously very good way, to be honest, but it's totally up to you how you want to do it. Okay. So now let me show you that way as well, so that you can be more skillful. So what I will do, I will simply go to my GitHub and I will directly create this file, create new file, and let me just say config, or let's say file config, files config, or let's say files array.json. Perfect. And let me just paste this array. Simple. Let me just say commit changes. So this file is created here called files array. You can even download it as well. Let me also download it. So I have downloaded the file. Let me just quickly upload it here. And let me just open my file explorer. Yeah, here. Perfect. So files array.json. Perfect. Click on upload. So this file is uploaded here. Perfect. Very good. Now what I can do, there is a special activity called lookup activity. Lookup means when you want to just look up for the file, when you just want to search for the file. So I'll simply say lookup like this. Simple. I will simply say files array. Simple. And if I just click on this activity, this page is very simple. You do not need to change anything. Go to settings. It will ask for the data set. Now what is the data set? And second thing also, you also need to uncheck this box, because otherwise it will simply give you the first row result, which is not we want. So you can now create another data set. Okay. So you can click on this data set pane that we used before, or you can click here as well. Let's click here. And then this time we will pick the data source. So this time again, the data source is Azure Data Lake Storage Gen 2, because our file is in the data lake. Click on continue. And the format is again JSON. Good. Continue. And this time I will say ds files array. Link service is this one. And now I need to pick the location. So let me click on browse. So I will go to raw. I will pick this information. Perfect. So import schema none. Click on OK. So this is the lookup activity. Simple. Very good. Let me just disable this activity first of all, because I want to show you this activity first of all. So I have deactivated it. Very good. So this is the files array. Okay. If I just click on debug, just to debug this pipeline, you will see something. And what you will see, let me just show you. So this is the output panel where you see all of the outputs of the pipelines. So here you can see this is inactive, so it didn't run this. So now this activity is running, files array. and let me just refresh. Perfect, it has succeeded. Now if I want to use the result of this particular file, because the end goal of using this activity is we want to read the content of a file so that we can use it in our further activities. So I will click on this output button, this one, and you will see the output. As you can see, value. What is the value? The array. Wow, this is the way that we use in the production environments in the real world. Oh, that is amazing. Yes, this is the production level, you can say, activity that we use. We also use parameters, but parameter is not a very good choice sometimes. Okay, when you have like very hierarchical pipelines, so always use lookup activity for JSON. Simple. So now what I need to do, I need to use this array in the loop. Exactly, that's what we discussed. So I will bring the activity called for each. Now in ADF we have for loop activity with a special name called for each. Simple. Okay, now I will just rename it. I will simply say for each file. Simple. Very good. This is exactly same as for loop. What do we need to pass in the for loop? Array, iterable. Simple. So here, go to settings, you will see that it is asking for the items. Items means iterable. Click on this box and then click on this add dynamic content, because we want to add the dynamic content. Click here, and now what will be the array? Now obviously I can just copy paste the array, but if I would be just copy pasting the array, then why did I just create this activity? I want to build a dynamic solution. So what I will do, I will use the output of this lookup activity and I will pass it in the loop. Wow, can we do that? Yes. This is called stateful orchestration, where we use the state of previous activity into the subsequent activities. This is called stateful orchestration. Simple. So what will I do? I will simply go to this thing and then I will go to not functions. Basically I just need to do one thing. I need to connect this thing with this for each. They are like basically 4 nodes. I will just connect this with this node with the success activity. That means if this activity is succeeded, only then run this activity. Simple. Now click on this box, you will find much more things. See, activity outputs. So now I want to use the activity output of this one, files array activity output, but this is not completed because we also need to add dot value, because we want to use a value key inside the lookup activity. Simple. Go to OK. So now this for each activity will use the array of this particular output. Simple. Then we need to move this activity and we need to click on this pencil button and we need to now paste this activity inside it. Why? Because now we are running this copy activity inside a loop, because we want to run this activity multiple times, right? Very good. Now let's activate this and just go to source. Okay, in the source, what is the data set? Remember, you just created. Click on drop down. It is called DS GitHub. Perfect. Click here. It will ask you to provide the file name. Why? Because if you remember, we created the parameter called p file. So now you need to pass that value. Simple. And now what is the value? You already know this. The value is I. What is I? So remember, we discussed about for loop. For I in array and then I. That I should go here, right? And that I is called item in the ADF language. Just click on this box, click on add dynamic content and then simply say @item. Simple. Only item. Now item is the entire dictionary. Within that dictionary, we need to pick a special key which is called file, right? If you just go to our GitHub, I can just show you, or not even GitHub, I can just show the output as well. If you go here in the succeeded button, so what is the key name called file? So we need to say, hey, item, that means I dot file. Fundamentals of Python, bro. Fundamentals of Python. Make your fundamentals strong. Simple. So the file will become @item dot file. Simple. Okay. Now these things you will also learn with the practice and with like using ADF more and more. Okay. So do not feel like, hey, how you just remember all of these things. It's fine. So now what are we just trying to do in this particular copy activity? We are trying to make a GET request on the URL. Simple get request, no post, nothing. So if there is no post request, then obviously we do not need to pass any header. We do not need to pass any request body as well. Simple. Okay, very good. Now comes the sync part. Sync part means destination. Okay, sync means destination. Now we need to provide information where we need to migrate our data. So I will simply pick the data set. Now we do not have data set because we didn't create the data set for our you can say destination. Let's create a new one. Let's say plus new and data lake storage gen 2. I want to store my data in JSON. I can even store it in Parquet, but I want to store it in JSON. It's fine. Click on continue and here I will say ds ingest. Link service is this one, data lake, and then for the file path, okay, I will not pick any file path and I will just tell you why. Just click on OK for now. Okay, so this is my data set. Now just click on open button to edit this thing. Perfect. Now you know this very well that we want to create or basically run this pipeline in a parameterized manner. You learned how to parameterize the source, but use your common sense while writing the data in the data lake. We also need to create this particular thing parameterized. Why? Because if I specifically pick a location, if I just specifically pick a file name by myself, what will it do? It will simply try to copy only one file, but I want to copy all of the files, right? So what will I do? I will simply provide this thing in a dynamic manner in the same way that I just provided in the source. Simple. Okay, so now the file system will become, just click on browse, or basically file system means your container name. Container name is raw and I will create a new directory within that. I will simply say ingestion, and for the file name I will use a parameter. So let's create a parameter. I will simply say p file. Simple. And here use add dynamic content and p file. That's it. Click on OK. Simple. Very good. Now this is the file name. Now we also need to add .json as well. So what I will do, I will simply say I can use concat function as well, or I can use this as well. So let's say curly braces and then .json. Why? Because this will behave like a parameter now. Simple. And this is the value that I have hard coded. That means .json. That is a file extension. Simple. Perfect. So this is parameterized. This is the parameter name, but we have also added .json after that. Simple. Nothing fancy. Okay, makes sense. So now if you go to this HTTP to ADLS, now you will see this parameter. Why? Because we have created the parameter. Now in order to provide the, you can say parameter name. So what we need to do, click on value, dynamic content, and then @item dot file. Simple. Perfect. This is the thing that you need to do, and that's it. Wow. Yeah. Simply click on this parent pipeline. This is your entire end-to-end pipeline. Simple. Let me just click on publish all just to save our work, and this will just save our development. Okay. Now I want to run this end-to-end pipeline, and I hope you understood all of the things. If you are new to this world, Azure world, let me just tell you the reality. That do not feel like if you didn't understand everything in one go that you are not understanding or you're not capable enough to understand. Not at all. Whenever someone learns a new technology, person needs to put more efforts to watch the content multiple times in order to grasp the knowledge. Do not feel like you will watch the tutorial one time and you will understand everything. Okay. So if you understood, let's say 50%, 40%, 30%, it's fine. Just rewatch this section. Try to build this thing on your own. Like you need to build everything on your own. I know that I will provide all of these things in my GitHub repo, but still you need to build everything on your own. Make mistakes, see errors, resolve those errors, and then only you will grow. Simple. Okay, so now let me just click on debug button and let me just click on OK. Because in data engineering, it is not possible that you will not see the errors. It is not possible at all. A data engineer spend at least 50%, or I would say 60% of time in just debugging, and 40% of the time will be you can say devoted towards development and doing some admin stuff and doing some architecture level stuff and all of these things. Debugging actually is the part of this particular domain, data engineering. Okay, just click on this refresh. Let's see the progress. See, I also saw the error. Let's see what is the error. So let me just click on this thing. So it is saying status code 404, please check your activity settings if you configured, and HTTP ingestion is failed. Okay, HTTP ingestion is this particular copy activity. And let me just wait for all to complete so that we can just debug in a better way. So it is saying that, okay, so this is the source. Okay, and let me just read the message. So the message says, please make sure it ends with slash. Okay, and request URL, this is a URL that it is trying to use. Payment methods. Okay, I found the issue. It's very much obvious by just looking at it. So it is trying to make a request at this URL, and at this URL it didn't find .json. So I just need to add .json. Simple. That is called debugging. See, so simple. Just read the message, and with experience, obviously, you will just you will be able to just resolve the issues. So here I will simply say .json. Simple. Publish, and then debug again. Here, perfect. So let's wait. Let's see if that issue is gone. If not, then obviously we'll do something else. Let's see. Files array is fine. Okay, this is queued in progress. Let's wait. Now it is in progress. Hope so it will. Oh, again some errors. Let's see what is the error this time. Now it is saying, hey, it is saying not found. I think I didn't publish and I just ran the thing before. Maybe. Let's see, because it is saying payment methods not with .json. Okay, payment methods not found because I saved it. Maybe I just triggered my pipeline before saving it. Yeah, because that is the issue. It didn't have .json thing. So let me just make sure that it is having I think I didn't save it. Oops. I think I didn't save it. Okay, and publish all. Okay, yeah, I think I didn't wait for it to complete and I just ran the pipeline. Okay, let me confirm it has. Yeah, now it has JSON. Perfect. Let's try to run it for one more time. Now let's see what is the issue or result. So now our data, oh wow, how is this possible? Some are succeed, some are failed. Let's see what is going on. So let's click on this thing. It is saying map rides.json. Okay, do we have map rides? I think so. Let me just bring my GitHub because it is saying it is not available. So here we have, what are the files do we have in the data? And we have, we do not have map rights, we have bulk rights. Okay, so typo in our JSON. So I can quickly edit this JSON, click on this JSON and then click on edit. And then it is called bulk rights. Simple. Save. What else do we have? We have an error here. It is saying map types. Okay, so what do we have instead of map types? What do we have? Map vehicle types. Okay, it happens. Save. And what is the third one? Let me check. The third one is, oh yeah, that is just like parent failure, so that is fine. So now let's try to quickly rerun this thing for one more time. Let's run this. But I know this time this will run because the major root cause is like gone. The real root cause. Okay, this is done. This is done. So okay, all of the ingestion is finally done and we should just go to our Azure Data Lake and we should see this data. So if I just go to, we have this ingestion folder, perfect. And within this we have all of the files listed in one go and that is amazing. That is amazing. So see, 1, 2, 3, 4, 5, 6, 7. All of the 7 files are here, but I can see .json, .json, .json. I think when we just write our data in the sink, we do not need to put .json because it automatically adds the .json extension. Okay, so that is fine. We can simply say delete, and then I can simply change the sync activity. That is fine. That will not throw any error, but I still want to keep everything clean. So let me just remove .json. And let's do just this @ and okay, publish, and then just click on debug. Perfect, debug. Perfect. So now I know it will work because that was the major thing. Now meanwhile it is running, we need to now go ahead with our second technology that we want to use to ingest our data, which is Databricks. Now let's talk about that as well. And this is also done very quickly. So let me just go and refresh. Perfect. Now everything is looking amazing, amazing, amazing. So this is the data. If I just click on any data, let's say .json, I should see this data. Amazing, amazing. So this is your ADF pipeline that we have built for ingestion. Simple. It was very, very easy. I know. So now what we need to do, our second part is of the ingestion. The second part is very, very interesting. It is called event hub to Databricks. So now what we are trying to achieve here, we want to use our events that we have created in our, you can say, event hub. Simple. Now this will be used as a source finally. So now what we will do, we will just pull our events that we have just ingested, or you can say we have published, or our application, web application has published to event hub. Now it's time to pull that data. I'll simply say Databricks, simple, and let's try to ingest this data. Perfect. This will be fun because you will be learning how to use Kafka, because Event Hub acts as a Kafka topic. So that means whatever code you will write, it works with Apache Kafka as well, and vice versa. Simple. So now the good thing is we will not be using Azure Databricks. Why? Because I know some of you cannot create Databricks instance in Azure. I was seeing some comments that in Azure you do not have the capability to create the Azure Databricks account if you are on free trial. But I know some of you are on free trial as well. So I do worry about you a lot, and I do care about you a lot. So we will be using Databricks free edition, which is completely free, which is end-to-end free. So for that, what you need to do, simply go on Google and search Databricks free edition. Hit enter and simply click on this thing. This is not a community edition, by the way. Free edition is different. So you can click on sign up for free edition, or you can click on try Databricks, whatever you want to do. So here, this is very important. So here you will see something called as get started for free, no credit card required. So this is a kind of free workspace that you get with Databricks, and obviously without any credit card. That means you do not even need to register, and you will not get something for, let's say, 1 month or 2 months. It is like completely free. That is why everyone loves Databricks free edition, because it is completely free. So now what you can do, you have two options. If you do not have any kind of account, then you can simply sign up using Databricks email, or you can say Gmail or Microsoft. And once you have completed that registration, then you can simply go to login. Simple, like this. Okay, makes sense. And also you can just click here, sign up for free edition, and you will land on this page, sign up for free edition. Simple. And it is saying, do you want Databricks for work? Try it, and no, it's fine. So you can just click on this page as well, sign up for free edition. Makes sense. And if you click here, try Databricks, this is get started for free. I would say just click here. It will be a better one, sign up for free edition, because you need to make sure that you are signing it for free edition, because there is like one more edition. It is called, I think, what was the name for it? There was a like special name for one more type of Databricks. It is also free, but it is free for just 1 month. You get some credits and then it is not free. So just make sure you are signing up for the free edition. and you just make sure Databricks free edition is written. Okay. Oh yeah, it is called Databricks Express. So Databricks Express is a different thing. That is free for just 1 month, but free edition is like free. Okay. So quickly create your account, and I assume that you will create your account, and it is very simple. So once you create your account, let me just show my Databricks free account so that you can also see. So let me just pull the screen here. Perfect. So this is my Databricks free edition. Simple. Now you can just pick any account and just make sure you pick AWS account. There will be like 2 icons, Azure or Azure AWS. So just pick the AWS one. Okay. So just click here, and this will just show you the home page for Databricks. Wow. So this is the home page, and very soon they are going to add my picture or video here, bro, obviously. So now what we need to do, we need to know about Databricks. First of all, if you have ever used Databricks, it will be very easy for you. If you have never used Databricks, if you want to learn Databricks, then I have a dedicated course on Databricks as well. You can definitely go and check it out. It is available on YouTube for free. Simply search Databricks. Let me just show you. Databricks Ansh Lamba. So here you will find this video and this video. So one is called Masterclass Databricks and second is called Modern Databricks with Unity Catalog. So the difference is, this is a kind of generic Databricks overview, and this is specifically for Unity Catalog. Unity Catalog is the modern way to deal with the mounting and accessing data lakes. So what will be my recommendation to you? Watch this overall video first of all, and then go to Modern Databricks full course. Simple. And then you will simply master Databricks. Okay, simple. So if you do not know anything about Databricks, still you will be able to understand some of the things that we will be just going to perform here, because that is a kind of project guided learning. Okay, very good. Now what you need to do, you simply need to bring the data into the Databricks workspace. Okay, and let me just give you a quick overview about Databricks. So this is the panel left hand side that is used 99% of the time. Okay, so here is a home page. Here is a workspace that you will be just using. I will just show you, don't worry. Recents tab is for your recent work. Then you have a catalog. Catalog is the backbone for Databricks nowadays. It is called Unity Catalog, where you create databases, schemas, tables, views, volumes, everything. Jobs and pipelines are very important for data engineers, because in this area you will create the ETL pipelines, and specifically SDP, Spark Declarative pipelines, which is the modern way to work with Apache Spark, or basically PySpark. Simple. In our project as well, we'll be using SDP for ingestion, real-time ingestion, and then we'll be just using our own PySpark code. Simple. Because you need to learn all of those things first of all. And then you have compute. You do not have much convenience about compute in free edition, because it is free edition. You cannot create as many compute as you can. You simply get one basic by default compute, which is serverless. And you do not even need to create that, because it is already attached to your notebook. Simple. Okay. Then you have marketplace. Then you have some SQL editor and all, so that you can just run SQL queries, and data engineering, again, data ingestion, data runs, it's fine. Then AI ML stuff. Obviously, this is not a Databricks masterclass, but we are learning Databricks by doing the project with it and learning amazing real world scenarios. Perfect. So now what we are going to do, we are going to create our workspace first of all. Okay, just click here on the workspace. Here I have so many workspaces because I just keep on creating stuff with Databricks, but you need to click on create and click on create folder. Okay, and then I will simply say Uber project. Click on create. Simple. So this is a project that we have created for us, and it is an empty project. Simple. Very good. Within this, you need to create something special. It is called ETL pipeline. See, if you click on create, you will see ETL pipeline. Click here and it will open this panel. Now, what is this thing? First of all, rename it, then I will just tell you. I will say Uber rides ingestion. Okay, this is the name of our pipeline. Simple. Then we have something called as workspace. So we have not created the catalog yet. Okay, so you can create a catalog. If you have not created the catalog, let me just quickly tell you how you can just create a catalog. Simply go to catalog tab here, and here you will see, I would say, just two catalogs. One will be like this and second will be like this. Okay, and some samples. So here you can click on plus catalog button and just click on create a catalog. Let's quickly create a catalog. Let's say Uber. Okay, Uber and standard, and that's it. Create catalog. Catalog is basically a kind of database in, if you want to create it with or compare it with other things. But Databricks uses 3-level naming spaces, so it has schema as well within the database or catalog. Okay, configure catalog, and that's it. So assign, yes, and then grant, that's fine, then next, and then save. This is your catalog called Uber. See, perfect. So now in this Uber catalog, what you need to do, first of all, you need to create a schema, because by default you get two schemas, default and information schema. Both are useless. We need to create our own schema, bro. Click on create schema, and the schema will be called as, let's say, bronze. Okay, bronze schema. Do not pick external location. Click on create. So this bronze schema is also created. Very well done, and that's all we need. Now just go back and here provide this information in the section. Simply pick Uber. Where is Uber? I think I just need to refresh. Okay, so now let me just pick, yeah, Uber, and schema is bronze schema. Make sure you pick these things, otherwise you have to change it in the settings. Okay, just make sure you have picked this thing. And pipeline will be, let's say, Uber writes ingest. Simple. And you have now two options. Start with SQL, start with sample code in Python. Always go with Python. Simple. Now this is your setup created. Boom. Now you need to take a pause. Why? Because now we will learn what are SDPs. Okay. Now comes the best part. Let me just open SDP Databricks. Let's open this one. This is also called as Spark, or basically Lakeflow Spark Declarative Pipelines. So now let me just tell you something very, very special, and I hope like you would also know this. Spark Declarative Pipelines were known as DLT, which is called Delta Live Tables. So yes, it is a kind of rename, but it is not just a rename, because Databricks has added so many amazing APIs and has modified some APIs, such as apply changes is modified to auto CDC, and similarly we have other changes as well. Okay, so now DLT is renamed as SDP, Spark Declarative Pipelines. Plus, why now it is even more important. Earlier DLT was just Databricks product. But now Databricks has contributed DLT, or you can say SDP, to Apache Spark. And now in the Apache Spark 4.1, we have SDP available. Can you imagine? And that is why if you just follow any Apache Spark official pages, social pages, you will see that the entire Apache Spark team is promoting SDP like crazy. That gives you a clear signal that SDP is the future of writing PySpark code. Yes, within the next 1 to 2 to 3 years, 3 years I would say is a very long period. I would say within 1 to 2 years, you will see that all of those legacy PySpark code will be transformed into SDP. Everyone will use SDP. Ansh, Lamba, this is a big change, but why it is happening? Let me just tell you. So what is SDP, by the way? SDP is a declarative framework. What does it mean? That means you declare what you want to do. You do not need to worry about how you need to do. You take care about what. You do not take care about how. This is a very popular saying about SDP available on their official pages. You just need to take care about what, and you do not need to take care about how. What does it mean? So let's say you want to use PySpark to transform your data, and everyone knows about it. Like, why do we need to use Apache Spark for transformations? So let's say you will read the data, then you will transform it, okay, then you will write the data. Now you just need to do this thing, how you want to read the data, how you want to transform the data, all the transformations, and how you want to write the data. You do not need to optimize this code. You do not need to take care of the you can say DAG. You do not need to take about the dependency. You do not need to take care about the you can say runtime optimizations. Nothing. Databricks, or I would say Spark as well now, will take care of everything because SDP is capable of doing everything. And this is such a kind of framework that you can use with both batch and streaming. Wow. So that means you can use this framework to process your batch data and streaming data as well. And on top of it, in both the languages, SQL and Python both. Wow. So as you can see here, so it is like written some promotional thing, but what are the benefits? The benefits are very simple. Automation orchestration. Automation orchestration. SDP orchestrates processing steps like called flows automatically to ensure the correct order of execution. That means, let's say you are creating a pipeline, because with SDP we create the entire pipeline. It will automatically fetch the dependencies and it will create the flow. And obviously you will see it here as well, don't worry. So it will automatically create the flow. Wow. Then declarative processing. It has an amazing API called Auto CDC, which takes care of your slowly changing dimensions. You can easily create slowly changing dimension type 1 and type 2 with just one parameter. Wow. And then incremental processing. SDP provides an incremental processing engine for materialized views. That means if you create materialized views, it will automatically process the incremental data. Okay. To use it, you write your transform logic and batch semantics. The engine will only process the new data and changes in the data sources. This is amazing. You do not need to worry about anything like incremental data as well. Then we have some key concepts. As you can see, streaming and batch source, both are allowed and both are very well organized and integrated with SDP. Okay, here we have some flows called Auto CDC append flow for streaming tables. And here we have something called as materialized view flow for our batch processing. But obviously we know that we are working with real-time data. So we will use streaming source and you will learn how to work with streaming tables. And the best part, you do not even need to take care about checkpoint tables, checkpoint files, nothing. You just need to tell that you want to create a streaming table. Everything, state management, you can say idempotency, everything will be taken care automatically. Okay, amazing. So these are some of the flows, Auto CDC, materialized view, and these are the streaming tables. So these are the three major pillars: streaming tables, materialized views, and sinks are like normal your tables, but they have extended this capability to write your data in the data lake. For now, you can simply ignore it, don't worry at all. So what is the third thing? The third thing is normal view, streaming table, materialized view, and a normal view. You can create a normal view as well, like normal query view. Because materialized view means you are also storing the data as well. Simple? Okay, very good. Now you have SQL pipelines as well, but I will prefer you to use Python API because when you are working with PySpark, you are already familiar with the PySpark functions. But choice is yours. You can even use SQL as well. No one is stopping you. No one can stop you. Okay. So now what we can do, now let's see this thing in practical because only then you will learn about it, right? So now what we need to do, I will simply take you to this particular section. So here we have amazing thing. It's called code editor for SDP. Earlier, when we used to work with DLT, we only had one option to create the pipelines using notebooks. But now we have this particular code editor, and I personally love this code editor because here you have your file system. Here you will write your code and here you will see the DAG for your pipeline, and it's amazing. I have been using this code editor since beginning of I would say mid of last year because it was in beta version, and when it was in beta version, it was not even launched. I was randomly checking their documentation and I just saw this thing. I was like, what is this thing? So I immediately went to my Azure instance of Databricks instance. I enabled this thing because it was not even enabled at that time. I enabled it immediately and I tested it, tried it, and I was like, wow, this is amazing. Since then, I have been using this thing, and now they have made it by default version as well. But earlier it was not by default. We had to go to the previews and we had to enable it. But I have been using it since the beta version of it. This is amazing feature, like this code editor. This is amazing. So now what you need to do in this particular section, so exploration folder is for you, where you can just create your notebook just for testing. This will not be the part of your development. Transformations is the folder which is responsible for your pipelines, or basically for your DAG. So whatever you create under this folder will become the part of your pipeline. Okay, and there's one more small thing, small observation. You will see one pipeline button as well here in the transformations folder. That means this is the folder which is responsible for developing the pipeline. Simple. And this utilities, obviously everyone knows, whenever you build with complex and whenever you work with complex pipelines, you need to build your complex logic. So in order to build those complex logic, then you can simply use this utilities folder and you can import it directly within your code. Like let's say from utilities, import your class, function, whatever. Simple. So this is the thing. If I just show you the demo files, because they have created the demo files for us, you will see some code written for us and we do not need to worry at all for that code because we will write our own code, but I'm simply showing you the thing. So what they do, they simply import the pipelines using this code from PySpark, import pipelines as DP. But I personally like using SDP because SDP is a standard in Apache Spark as well, but we can just import it like DP as well. Then they simply created this table, and this is a kind of, you can say, your batch table. Okay, batch table. And let me just tell them that they are using the older version of their connector, because now we do not call it as table. Now we call it as like @dp.matview, because whenever we read the data using .read method, we do not use @dp.table. And let me just confirm this thing, but I'm so sure. I am so sure. So if I just go here, if I go to develop pipelines, not develop, I would say developers, then Python language reference, and then append flow table materialized view. Yeah, see, I think they are using their older version of code. So just update it, Databricks. So what is, so what do we do now? We do not write dp.table. We used to write dp.table when .materialized view method was not available. But I think this method is available since past 3 to 4 months. So now they need to update this code, but that's fine. It happens. It's fine. So now you can see that this code is a kind of outdated, but here we write it like this. Let's say materialized view, because we use table if we are creating a streaming table, and we use read stream method for that. So do not need to worry. You will just you can say talk about that as well. So okay, so let me just delete both the files because we will be just using our own files. Perfect. So move to trash. So now I will create my new file, and I will say create file, and I will say ingest.py. Simple. And just make sure this is a Python file. So first of all, I will import the pipelines. So from PySpark, let me just increase the size. From PySpark, import pipelines as, let's say DP. I like SDP, but yeah, let's say DP. And I will say from PySpark.sql.functions, import asterisk. From PySpark.sql.types, import asterisk. Simple. Very good. Now what we need to do, we need to create a data frame on top of the data sitting in the Azure Event Hub. Remember? Now let me just tell you how you can just read the data sitting in the Event Hub. So let's see, read Events Hub data, Databricks. That's the way you use documentation in the real world. Okay, so perfect. Let's click here and create a pipeline. Perfect. So you have got the code. So this is the code that you need to use. Obviously we'll be just modifying this thing, and let me just copy and paste this code from here. Perfect. Let me paste it here. So here, what do we have? Here we have, first of all, EH namespace. That means event hub namespace. We know that in our case, the event hub namespace is different, right? So what is that thing? Let me just bring it here. So let me just bring that screen. Perfect. So if I just go to my resource group, RG Uber, and here I have events. So my event hub name is Uber events. Perfect. Perfect. So I can just paste it here. Perfect. EH name. EH name is, I think, Uber topic. And now it is saying EH shared access key name, secret scope, shared access key, and then connection. So I actually do not need all of this thing because I can directly paste the connection string name. And instead of pasting it here, I can create a variable. So if we want to create a variable in SDP, we have a special thing which is called configuration. Just go to settings here and just go to configuration, add configuration. And here I will say connection string. And here I can just paste the value. And what is the value? The value is, and here, let me just ask you this question. Which policy will you use here? Which policy? Obviously read one, listen policy. Okay. So let me just copy this code. Perfect. And let me just paste it here. Okay. Perfect. And I will say save. And I can bring this thing here. So EH connection string will become spark.conf.get. And the configuration name was connection string. Simple. So this is the connection string. Perfect. So this is done. This is done. Now if we just see Kafka topic, now I told you that we can just read our events data like a normal Kafka data, right? So here we have bootstrap.servers, which is our namespace. Okay. Namespace means like your event hub namespace, the entire bucket. Within that we have topic to which we subscribe. Simple. Then we have these configuration, just keep it as it is. And then plain module required username, connection string, this is fine. And this is the password is our connection string, that is fine. Now we can simply change these numbers. We can hardcode these numbers. Let me just do it. So just for now, you can just give any value, any random value. So let's say we just pass 10,000 to all the values. Simple. So let's say 10,000, fail on data loss. That means true, obviously. And starting offset will be earliest. That means we need to fetch all of the events from the beginning, but you can also provide the number as well, starting offset, if you have the specific offset, but you do not need to remember any offset if you are just performing the data load. Then these are the Kafka options. Now I can create my data frame using this thing. So I will simply say df equals spark.readstream.option, or let's say dot format. The format is Kafka, and then you can say dot option, and option will become my Kafka options. Simple. And now I just need to perform this thing. Okay. Dot options. Now I want to do this thing. Yes. But before creating a streaming table on top of this data, I need to explore this data first of all. And I want to see like what's going on. So if I want to do all of this thing, I will simply copy this entire code and I will go to exploration, sample exploration. So this is a notebook that DLT provides to us so that we can just test some things. Okay. So I will delete this cell, delete it, delete this cell, delete it, delete this cell, delete it, and create a new cell. So simply paste that code here. Simple. So here, let's say dot load, and let's try to run this entire cell and let's see what do we get. Simple. Okay, perfect. cannot import pipelines from PySpark. Wow. Why? Because we do not need to import it in the pipelines. Simple. Like in the exploration. So now let's wait for it. Let's see what do we get. And we have provided almost all of the configurations, all of the passwords, all of the keys that are required to read the data from our event hub. And you should know what exactly we're trying to do. We are trying to read this data, which is here, which is this data. Let's say Data Explorer. And if I go to view events, I should see all of my events because the expiry data was 48 hours, which is a good thing. Yeah, we have all the 4 events created. Perfect. So it is saying configuration connection string is not available. What does it mean? Configuration string is not available. So basically, whenever we need to just use our notebook, we cannot use spark.conf.get. That is only available for the pipelines. So here I have to hard code it for exploring, but in SDP, I will use that particular thing. Don't need to worry. Connection string, and here I can just copy and paste the value. I can go to ingest.py, settings, configuration. Okay, edit configuration, copy. Perfect. And just close it. Just paste it here. Simple. Okay. So now let's try to run this cell. Kafka dot servers. Which thing you got extra? Let me just see. Bootstrap dot servers, data stream reader. I think what is wrong? Oh, I see. So we are passing the dictionary. That means multiple variables at a time. So we have to use options, not option. So let's run this. Oh, perfect. That worked fine. So let me just display as well because this worked fine. So let's see what do we have. Okay. Display df. Okay. Implicit. Yeah, that is fine. This was like expected. I knew about this error. So now in order to work with exploration with streaming data, we have to provide the checkpoint location, right? Yes, when we work with SDB, we do not need to provide checkpoint location, but before creating the streaming tables, we have to do a lot of cleanup that will require a lot of efforts as well. So in that particular scenario, we have to provide the checkpoint location. So now how can you provide the checkpoint location? It's very simple. Simply go to your catalog, okay, and just open your catalog and click on bronze and click on these 3 dots and click, I think you can go to open catalog explorer. Okay, just go to or duplicate this tab so that you do not lose this progress, this one. So now just go to catalog because you just need to create a volume and that's it. Go to Uber and go to bronze. So this is a schema. So now you need to create something called as volume. Now you will say, what is a volume? So see, in Databricks, volume is a kind of folder that you register under a schema. Have you ever created a table under a schema? Good. Have you ever created a view under a schema? Good. So volume is a new feature that Databricks introduced. That means you can now even create a folder as well under a schema so that you can just govern your files. Amazing thing. Okay, I know they just do amazing stuff. So I will simply say my volume, simple, and simply say create. So now this volume is created. Okay, and now just go back, simply refresh and open this catalog, bronze. This catalog is there, and just create a directory as well in this. Create directory, and you can say volume folder. Simple, because you should have a folder. And now you need to simply pass the checkpoint location every time when you will be just displaying the data. So here, what is the location? You can you can click on this volume and click on these 2 arrows to automatically fill this particular location. Simple. And then now just click on display. This should work now. Yeah, as you can see, stream initializing, it is working fine. Makes sense. So this time we should see the data in the appropriate format and it is good. Let's wait and let's collapse it. and you will also see the graphs. And here is the schema for the data frame: key, value, topic, partition, offset. This is the exact schema that we have here. Exact schema. See, sequence number, offset, partition ID, enqueue, time, and whatever. Okay. So this is the data. Key is null, which is fine. Value is this data, which is very, very weird, but don't worry. I will just convert it into string because currently it is in the binary format. And then we have a topic. Topic name is Uber topic. And then partition is 0 because we just created one partition and it is 0. Offset is 0, 1, 2, 3. That means order number in which it arrived. Simple. Then timestamp, at what time it arrived, and timestamp type 0. So now let's try to encode this thing. Okay, not encode, basically decode. So I will say df equals df dot with column. Simple. And I want to create a column, let's say rides. Simple, rides. Okay. And I will say column of value dot cast. I can use string type as well. Simple. And then now let's try to see it. Now we should see the data. This output mode is not supported. Yeah, makes sense, because whenever we just perform any kind of transformation, it behaves like this, that what is that particular thing, what is this particular thing. So that is absolutely fine. That is not a big deal. So now our major work is done. We just wanted to test that we can read the data. So now let's go to our data and let's copy paste everything. Not everything, because we know what we are doing, so that is fine. So now we will just go to ingest.py and perfect. Because see, now we need to first of all dump the data. Bronze layer means dumping the data, and that's it. Dumping the data. We do not need to perform any kind of transformation in the bronze layer. Okay. If you do not know about this thing, now you know. Bronze layer means your exact replica of the source, and that's it. Simple. Good. Now this code is running fine. We know that, and we can say dot load, and that's it. Simple. And we just need to perform one transformation, and I can say converting values to string. Perfect. And I can say df equals df dot with column. This will be rights, and then column of, yeah, let's use this one. Okay. And then that's it. Now here comes the magical part. This is my what. This is my what. What means what? This is my what. I want to perform what. That means I want to read this data. I want to apply this transformation, and now I want to write this data into the destination. Simple. I do not need to worry about how. I do not need to worry about all of the overhead that I need to manage with streaming table. I do not need to manage checkpoint location, schema location, anything, right? SDP will do everything for me. How? Let me show you. So here comes the magical part. So we will create a special function def, and we need to pick the table name that I want to create. The table name will be rides raw. Simple. Rides raw. And this is my function, and I will just put all this code inside this function, and I will say return df. Now in order to convert this function into, you can say, a streaming table, there's a special decorator called dp. That means our Databricks pipelines, or you can say Spark pipelines object dot table, and that's it. That's it. Yeah, that's exactly what we need to do. Do you know what? Now if I run this pipeline, this will create a table, a streaming table automatically in my catalog, and you will literally see that. And let me just show you. So before running that thing, you should always dry run this particular application, but it's up to you if you just want to directly run the thing. I love running this pipeline in the dry run mode first of all. So I will click on dry run, because in dry run you will see the DAG. Just click on pipeline graph and you will see the DAG here. So it will take some time. It will render the code, and then it will finally show you the final code. Okay, now let's wait and let's see what we are just trying to do. And I hope you understood this transformation. We are simply converting binary object to string, and that's it. And by doing this, we will get the you can say your string version of JSON. Simple. Okay, let's wait for it to complete, and here you will see all of the stuff performing. Try run. Okay, and currently we should see only and only one object because we just have one table that we are trying to create. Okay, perfect. So you can see the table. If you do not see the table, that means something is wrong. If you see the table, everything is right. Perfect. And do not worry, I will also give you this code. You can just reuse it. Simple. So that means our rendering is perfect. Now I can directly run this pipeline to create the object. Now do you know what will happen? Real execution will take place. Real execution means real pipeline will run to create a table in my catalog. And you will see the table here in the catalog right away. So it is running everything. This is also running. And you will see all of the records that it will run, everything. So you can see 4 objects are successful because we have 4 objects, right? Wow, this is successful. If I go to catalog, if I go to Uber, if I go to bronze, wow, we have one table. It's called rides raw. I didn't create this table manually. SDP created this table automatically using streaming. Exactly, using streaming. Okay, makes sense. So this source part is automatically done. We have successfully loaded the data into the bronze layer using our SDP from the events hub. Was it amazing? Obviously, obviously, right? So this way you can also perform these things. Make sense? Very good. Now what we need to do? Now we need to load all of the other data as well in our bronze table, obviously. So that part is little tricky because when we use Azure Databricks, you can access data sitting in the data lake with much ease. But when we use the free edition, you can still use the data, but you need to just find some ways. So I will just tell you about those ways as well, how you can just read the data. Okay, so let's now try to load and migrate the data into the bronze layer, or basically bronze zone, from the Azure data lake raw container, right? Because that's where our data resides. Let's try to see how we can just do that thing. So now this data that we are ingesting in the real time, obviously, like you can just book more rides, but for now this is like in the development phase, so obviously we do not need to keep on clicking on the button. Okay, so now so far we have 4 rides, so this data will be ingested in the real time. How? Because obviously we have this particular pipeline. Where is that? This one. So this pipeline, we can just keep it as up and running, and obviously this is like free edition of Databricks, so you cannot spend much compute resource in the beginning because we still need to perform a lot of things. And when you aggressively use the free cluster, it will show you a pause that you have exhausted your resources, and then you just need to wait for 1 to 2 hours once it is like reset. Okay, so do not keep it up and running, but don't worry, I will just show you how you will just keep it up and running, or you can just trigger it in every 2 minutes, 3 minutes, 5 minutes, right, in the production phase. But currently this is in development phase, so do not feel like, hey, this is not running. You can imagine that, okay, we are receiving the orders, or you can say your rides here in the real time, and now it will be pulled automatically using our Databricks pipeline that we have created it here, because this is a streaming table. Simple. And we have used the Kafka offset as well, like Kafka options, so it will only read the new data only. Simple. So this part is very good. Now if we go to our Azure, if I go to my RG, and if I go to my data storage, if I go to containers, raw, and perfect. So here I can see that inside my ingestion, I have these files that I need to obviously load in my Databricks, obviously. So now let's see how we can just load this data. So now usually whenever you want to load the data from the Databricks, let's say WebApp to event hub, so let's say we want to do it now, ADLS to Databricks. Simple. So usually, okay, we use something called as access connector whenever you want to load the data from the ADLS or any kind of data lake. Okay, so let's say this is Databricks. Perfect. So we use something called as access connector. Usually, do we have access connector? No. Okay, it's fine. So access connector is a kind of permission. Again, the policy thing here as well, because see, Databricks is a kind of different service, different resource. ADLS Gen 2 is a different resource. So in order to work, or you can say in order to let Databricks use the data sitting in the data lake, we need to allow Databricks to use the data. Makes sense, obviously. So now how can we just allow Databricks to use the data? So it is very simple. We can have actually multiple ways. Okay, so traditionally we use something called as access connector. Okay, access connector. But now we use access connector when we have the paid version of Databricks. Okay, and to be honest, access connector is not the only way to read the data. There are other ways as well, and other ways will be just seeing it in this particular project as well. So now what I will do, I know that the data that I have here, let's say this one, all of this, all these files, this is my data. This is my data lake. So forget about Databricks. If I want to read this data, if I want to, let's say, access this data, what is the way to do that? That should be your very first question. So let me just tell you what is the way to do that. So there is something called as public URL. So if you just go to properties, you will see this URL. So you use this URL, and when you use this URL, you can access this data from anywhere. Forget about Databricks. You can use this data from anywhere because this is the public URL. So does that mean I can access this data using this URL? Actually not, because this is just a URL. But obviously this data lake is secured, right? So you need to show that credential. So here we have something similar, which is called access policy. So we go here in the access policy and we create something called as, or you can say shared access token, not access policy, because like you can just use access policy as well, but it is not recommended to use access policy here. So you can simply say shared access tokens. It is also called as SAS token. Makes sense? So whenever we just create a SAS token, see, generate SAS token in URL, I will just show you how you can just do that. So here you define some permissions. So first of all, you will define read permission, add permission, create, write, delete, whatever. Simple. So you create this kind of permissions. So if you just want to allow read permission, simply say read and that's it. If you just want to allow add, create, write, delete, list, move, execute, ownership, permission, then you can just check all of these boxes. I just want to say read because read is enough. And SAS tokens are set to expire. Yes, you have to just set the expiry date. So I will simply say the expiry date will be, let's say, till first, I would say. Today is 27th, okay, 28th, yeah, till 28th. And the time, let's pick PM maybe, and let's say 8. Okay, simple. So now what will happen? It will expire automatically after this time. Simple. No one can access this. Simple. So I can also say generate SAS token and URL. So I can click on this thing and I can simply copy the blob SAS token and blob SAS URL. Okay, this is the token. This is one way to do it. Let's say, let me just copy to clipboard and that's it. So this is the blob SAS token. Okay, simple. Now I can also go to, let's say, one level up till here to the container, to the raw container. If I go to shared access tokens, I can also create token at the container level as well. Let's say like this. So it's up to me. Let's create the token at the container level and let's try to see this. Okay, so I have just copied the token and let me just save it in my notepad so that I can just reuse it. So now let's go to our Databricks. Okay, so this is our Databricks. So now what I will do, I will simply go to this workspace And actually let's click here and then let's go to workspace. So this is our workspace. Not really, or this is the one. Yeah, because it has just opened the folder. So this is our workspace, Uber project. Okay, and this is our folder where we have created our ETL pipeline. So this is a special folder, that's why you see it with this logo. Okay, so this is an ETL. So now what I need to do, I will create one notebook. Okay, and this notebook will be called as let's say, and first of all let me just collapse it. So let's give a good name. So I will simply say bronze ADLS. Yeah, bronze ADLS. Simple. Because we want to load the data, basically read the data, read the mapping files which are sitting in the data lake. Very good. Now let's start this code. So now just a tip, whenever you want to read the mapping files, we do not need to directly create a PySpark data frame. Why? Because whenever you want to create a PySpark data frame, you create PySpark data frame because there is a reason behind it. When you are working with a big data, which is a scenario with the data that we are receiving in the real time. So that's why we created the PySpark data frame, because fact tables are big data, like big tables. But when we just want to load the mapping files, static files, we should always go with pandas data frame. Simple. Very good. Second thing, we are reading mapping files from data lake, and if we want it to directly use it with the SAS token, we have to work with pandas data frame. Do not worry at all. Pandas data frame is just for loading the data, basically creating a data frame on top of the static files. That doesn't mean that we will not be using PySpark data frames. It is just for building a data frame on top of JSON files, and that is it. I hope it makes sense. Okay, just creating a data frame on top of JSON files. That's it. Simple. Once we have the data frame, then obviously we have the full power to work with the PySpark data frames, right? Simple. So this is just a way to read the static file sitting in the data lake. Very good. So let me just write import pandas as PD. Simple. So now I'll be just loading the data, obviously. So what I can do, I will just show you first of all how to load one data, then you can just load all the data frames easily. So for that, we first of all create the URL. So now what is the URL? You simply need to copy the URL from here, which is, if you go to raw, and you can also go to properties just to get the URL. So this is my URL. Simple. After this URL, I know that I have a folder called ingestion, right? See, I have this folder, ingestion. Within that ingestion file or folder, I have, let's say, this file, map cities. Okay, simple. So I will simply say map cities.json. And after this, I need to paste my SAS token by adding a question mark. This behaves as a query parameter. If you are familiar with the APIs, then you would know whenever we pass the question mark, it behaves as a query parameter. Okay, query parameter, not a path parameter. Path parameter is different thing. Path parameter is something like when you just create the dynamic routes. This is not a dynamic route. This is just a query parameter in the API, because this is a public URL, right? We are making a, you can say, a kind of API request, and then we are passing the query parameter. So simply paste that token now that you copied before. So this is the token I created. So let me just paste it here. What was the expiry that we just set here? Let me just see. If I go to shared access token, okay, so it is just for today because I just copied from here. Yeah, but it's fine. Perfect. So let me just copy it here. Simple. So this is my URL. So now I will say df equals pd.read JSON, and then I can say URL. Simple. And just to show you the data, I will say df.show. Data frame object has show, not show, basically head, because this is a pandas data frame. So perfect. See how easily I am able to read the data using this public URL along with my SAS token. Makes sense? Simple. Okay. Now I want to create multiple data frames, obviously. So what I will do, I can create multiple data frames. Yes, for sure. How? So I know that this is data frame for map cities, right? Let's say like this. Okay. I can parameterize this thing. Let's say like this. Let's say I will use f string, and instead of putting here map cities, I will simply say file. Perfect. And remember our JSON, or basically not JSON, our array. I can just use that array. I will go to overview, file array.json, edit, and I can use this thing. Perfect. So I will simply say files equals to this. Okay. Then I will say file name should be replaced with this file name, right? One by one. Make sense? Nothing fancy. So now I can run a loop like this. Let's say for I in, or let's say for file in files. Okay. And I can just put it inside this loop, and this will create this df automatically, right? One by one. Make sense? Okay. Now I know that I do not want this particular df.head. I just want to convert my data frame. So in order to convert a pandas data frame into a Spark data frame, the process is very simple. You simply need to say df, let's say Spark equals Spark dot create data frame, and you simply say dot df. Simple. Okay, makes sense. So now once our data frame is also created, what we need to do? We simply need to write this data into our catalog, into our bronze schema. Makes sense, because we need to apply the join, right? So we can simply dump this data into the bronze layer, and we can create a table on top of it. Simple, very simple. So what will I do? So I will simply say, I will say df spark, or let me just go to the next line. Writing data to the bronze layer. Simple. df spark dot write dot format. Format will be, let's say, delta. Okay, because I want to store my data in the delta format, or I can also store the data in the JSON format as well. Not a big deal, but let's say delta. It's good. Then I will say dot mode. Mode will be, let's say, override, because these are static files. So override mode is good. And for bronze layer, we should always pick override mode, because bronze layer is a kind of, you can say, transient layer. It's not a persistent layer. Simple. Then I can say dot save as table, because I want to save this data as a table. Simple. So table name will be, let's say, our catalog name, Uber, then bronze, then dot, and here I can use f, and here I will simply say file. Simple. So this will dynamically save all of my data with these names. Wow. Simple. Okay. Let's try to run this code and let's see what will happen. URL can't contain characters, raw ingestion, file. Okay. One silly mistake. I forgot to add this particular key in my code. File dot file. Simple. Good. File dot file. Let's try to see. Dictionary object has no attribute file. I think it has this particular thing. Okay, makes sense, because this doesn't use that particular dot notation, but that's not a big deal. We can use this dictionary notation. So this will create all of the tables for me with just this code. And I love performing dynamic coding, because obviously, like, you cannot write the same code again and again 10 times. Just create the code one time and reuse it. Okay, so this is my code for bronze ADLS. Let's see, let's wait, and then we will simply verify it. Okay, 8 tasks are done. So it has created, okay, 13 tasks. Makes sense. Okay, okay. Oh, perfect. It is done. So if I just go to my catalog now, if I open my Uber catalog and I open bronze, I can see 8 tables. Obviously, one table is my streaming table and 7 tables are for these 7 files. And this is amazing. Wow. All of the tables are created. See, I didn't hard code any table name. I didn't hard code any kind of file. I simply created a loop and that's it. That's it. Okay. So this way you can also like, so this is again a kind of, you can say, config. If you have multiple files in future, you do not need to touch this code. You simply need to add the file in the config and that is it. Amazing. So we have this data. Let's try to see one table just for the testing purpose, right? And just a quick note for you, you will see a special difference between the table. So here in this table, you are seeing waves like this. See, because this is a streaming table. Other tables are not streaming tables because other are just the mapping tables. That's why these are the static, or you can say batch, or you can say materialized tables. Okay, simple, good. So let's try to query one table just for fun. So I will simply say select asterisk from Uber dot bronze dot, let's say, map cities. Simple. Oh, this is working absolutely fine. Wow. Let's say I want to query bulk rights because that is our initial load table and one of the biggest table where we have the historical data. Let's see, everything is good. Wow. Ride ID, confirmation number, passenger ID, vehicle ID, pickup location, ID. Okay, that is amazing, man. Okay, and we have see all the historical data. This is amazing. I am really happy with the results. This is amazing. I have all of the data. Wow. Amazing. Okay. Perfect. This is something that I was expecting. Okay, very good. So we have prepared our bronze layer. We have initial load table for our real-time data. We have our streaming table, right? And obviously we need to combine these two tables because we need to add initial load as well in our streaming table. Obviously this is like silver layer work, and we have all these static or basically tables which will be joined with this big table, because then it will become OBT. What is OBT? OBT means one big table. This is an approach which is becoming more and more popular, and we create OBT, which is one big table, in the silver layer, because not every domain uses data model. Some report builders or decision makers prefer building reports using silver layer, basically one big table, so that they can themselves break the data one big table into a data model of their choice. This is becoming more and more popular because this is a kind of decentralized approach where each business domain, each domain, or you can say unit within the business, creates their own data model on the basis of their data size, on the basis of their data requirements, and all of these things. Make sense? So this is becoming more and more popular, and obviously if something is becoming popular, Ansh Lamba will tell you. So makes sense. So we have all these things, and I just want to perform a quick test as well. What is that test? So if I just query this table, rides raw. So let's say select asterisk from, because obviously we didn't query this data. So let me just run this, and I forgot to add catalog bronze.raw. Let's see this data as well. How does it look like? So perfect. We have key, we have value. This is the default columns, and we created the new column called rights. Perfect. And within this rights, we have this particular, you can say, column, which is a kind of JSON string, as I just mentioned, right? Yes, we will transform this thing. Do not need to worry at all. Okay. And we have total 4 rows. Simple. Now I want to do a quick test. So what I will do now, so now I will turn on my API. So let me just start my web application. Okay, perfect. So I now want to book a new ride because I want to see if we are able to incrementally read the data. So I will simply click here, book a ride. Perfect, ride confirmed. Let's see if our ride is confirmed or not. Let's see. Home, event hubs, Uber events, and then Uber topic, then data explorer, then view events. So we should see the fifth event as well. Let's see. Perfect. I have received this event 6:42 p.m. Perfect. So this is the data. Now if I go back to my Databricks, right? If I go to recents, not recents, let's say workspace. Yeah, so I will go to Uber project. Let's go to this pipeline. Simple. Let's click here and let's go to transformations. Let's go to ingest.py. Perfect. So this is my pipeline. Perfect. Now let's try to run this pipeline for one more time. And this should not bring 5 records this time. This should only bring 1 record. Why? Because we just have one new record and we do not want to process the data which is already processed, right? So if everything is fine, then we should see only one output record instead of 5. And only then we can say that our offset is working fine and our data is like running fine and going through the pipeline smoothly. Let's wait and let's see. So it is saying updated all. So perfect. As I just told you that it has generated only one record as the output. Very well done. And just for the, you can say confirmation, I can do a quick test. So I can simply go to workspace. I can go to Uber project, bronze ADLS, and I can query this data for one more time. Let's say like this. Rides raw, not rides. Yeah, rides raw. Let's say like this. Perfect. So I am now seeing only 5 records, not more than 5. So everything is running fine, which is a very good thing. Okay. So now what we are going to achieve? Now we are going to achieve the silver layer. And in the silver layer, do you know what we are trying to build? Let me just show you step by step. Try to build our silver layer, because the biggest challenge in the silver layer is, or you can say the beauty of the silver layer is transforming our data. And in our case, it's not just about transforming the data, because we need to also apply the union between the initial load and the incremental load. So we need to create the complete table for it. So in our case, what is the scenario? So we have, let's say, bronze layer, which looks like this. Let's use this color for bronze, or let's use this one. This one. Okay, perfect. So we have this bronze layer. Within this bronze layer, we have basically 2 tables. So if I say 2 tables, so I will simply call it as, let's say, this is my table for initial load, which is a bulk load as well. Okay. And along with this table, I have the streaming table, which will be synced with the live streams, right? Stream table. Simple. So I have these 2 tables in my bronze layer. Simple. Now, in order to generate the silver table for this, I need to be very, very careful. Why? So now what will happen? I need to first of all create a staging table before creating the final silver table. Why? Because if you notice, if you would have observed, we have these 2 tables, yes, for sure. But along with these 2 tables, we have tables such as those small tables, right? Mapping tables. So you can say map. So there are so many mapping tables. So let's say 1, 2, 3, 4, and I think there are total 6 mapping tables. Perfect. So these 6 mapping tables are also in the bronze layer. And now our goal is, you already know what is our goal. Our goal is to create the one big table, like one big table having everything, right? So this is our goal, OBT. Now what we need to do, we first of all need to create a staging table where we will simply apply the append between these two tables. Okay. Now we cannot apply a normal union here. Why? Let me just tell you. And this can become your interview design level question as well. Okay. Architecture level question. Okay. So now what will happen? I have this initial load. Let's say I create the staging table where I apply the union like this. Let's say this plus this. This plus this. Let's say like this. If I perform this thing, it is absolutely fine, absolutely correct for one iteration. Okay. But what about the second iteration? Because this streaming table, this one is continuously appending. So let's say I want to run my solution in every 10 minutes, in every 15 minutes, or let's say in every 5 minutes, right? Let's say in every 5 minutes. Then I will be running this piece of code in every 5 minutes. Can you imagine the load it will just take, or you can say resources it will consume to perform this operation? Because initial load means very big data, very big data. This can be the data for the entire decade as well in some cases. So obviously this is not a good approach at all. So Ansh, Lamba, what is the solution? The solution is with the SDP. Really? Yes. So now what we need to do, we need to create something called as, let me just remove this. Now what we will do, we will create something called as obviously the staging layer, that is non-negotiable. Staging layer, let's use this color. Perfect. So now what we will do, we will create something called as a new streaming table. Oh, okay. Okay, a new streaming table like this. Okay. So this will be the streaming table for sure. But you know what? This table will become a streaming table by appending these two tables. Let's say like this. Let's say like this. Okay. And this piece of code is called as append flow in the SDP called Spark Declarative Pipelines. So what we do in that particular scenario, we create an empty streaming table. Simple empty. And we can insert our initial load. Makes sense. So this will go here, obviously. And this data will go here for the first time. Very good. Makes sense. Simple. And this will be appended like this. Let's say like this. Simple. Very good. Now this is fine obviously for the first iteration. Now in the second iteration, this is still fine. Do you know why? Because now this will not keep on appending this data again and again and again, because this data is stale. This data doesn't have the new records. This is initial load, finish. This data will be appending and we are good with that. So this is the approach that we need to build. So once we have the streaming table ready like this, then finally we will apply join between this table, and this will become one big table. Understood? Understood? See, like this, like not directly like this. So it will be joined with this one, or you can say this will be joined and this will become something called as one big table. So this is my join. Okay. Wow, Ansh Lamba, your drawing. So this is join. Okay. And this will become finally one big table. Perfect. So this is the architecture for silver layer. Wow. This is the thing that we are going to achieve. Are you ready? Are you ready? Yes. Then just type in the comment, I am ready for the silver layer. Let's try to build. Just type it right now. Why are you so shy? And I don't know, man. Are you actually a data engineer? Are you actually trying to become a data engineer? Where is your excitement? Where is your curiosity to know the things? Data engineering is not for everyone. Data engineering is only for the enthusiastic people, not for boring people. Okay, so now let me just show you the documentation for append flow. By the way, this is very simple. Append flow SDP, simple. And append flow was there in the DLT as well with the same name. So let's open this documentation because I like Microsoft documentation more. So see what we do. The same thing that I just told you. First of all, we will create an empty streaming table like this. Perfect. After this, we simply need to say what we need to append in that table. So here we just need to say our normal function where we have that table. Okay. And then we simply need to say target. What is our target? And we simply need to say, okay, target is this table. Simple. Okay. Simple. Okay. Very good. Let's try to implement this and then you will learn better. Okay. So now what I will do, I will go to my workspace and here I can go to my transformations and ingest.py. Perfect. So this is my UI for SDB. So within the transformations, I will create a new file and I will call it as silver. Not silver. Yeah, kind of silver. Yeah, silver. Let's say silver.py. Simple. So silver.py. So now what I need to do, first of all, I need to import that boilerplate dictionaries and classes and blah, blah, blah. So perfect. So now what I will do, first of all, I will create the streaming table. dp.create streaming table. Create streaming table. Create or like simple create? Yeah, create streaming table. Create streaming table. So now I need to pick a name for the streaming table. So obviously, in order to pick the streaming table name, I can simply say, let's say STG writes. Simple. STG writes. Okay. So this is my streaming table. I can also say empty streaming table. Perfect. Now I will create my stream append flow. So for that, I will simply say def and here I can say writes bulk. Simple. Writes bulk. And here I will simply append the decorator, which is dp.append flow. Simple. We do not need to write table, materialize view, nothing, because we are not materialize this thing. We are simply appending the flow to this table. Simple. Appending, adding the flow. Simple. And then I can just get the properties for this thing. So we have target and blah, blah, blah. Let me just copy all the things, even if we are not going to use all the things. Perfect. So we need target, obviously. So target is staging rights and name. No, I don't need this. Perfect. Once, not really once. I can say once, yes, for bulk, because I don't want to do it again and again and again. So I will simply say once equals to true, just for the bulk one. Okay. Spark configuration, I'm good. I don't want comments. So just these properties. These are good. Simple. Okay. So now what I will do in this, I will simply read the data. So I'll say df equals spark dot read stream dot table. And we know that we have a table for bulk and it is called, I think, writes bulk, if I'm not wrong. Let me just check. So I will go to Uber, bronze, tables. Yeah, bulk writes, simple. Now I'm not sure if I need to mention the catalog and schema name. I can test. Okay. So we will simply run this code. If we see the errors, we can just change it. Don't worry. And I will say return df. So this data will be appended to this particular table, streaming. Perfect. Now what I will do, I will append my second table. So this is my bulk table. Bulk or initial load, simple. And this is my streaming load. Simple. And here I can copy the things. Perfect. And here I will read this read stream dot table and the table name is I think stream writes. Perfect. So this is df. So this is good. Why it is like red? I don't think so. It is fine. So stream writes. So this is also good, right? So now what I need to do, I will simply say dry run just to see how it is behaving. And you will see that if everything is fine, obviously, you will see that in the DAG, we will see the dependency automatically. What do I mean? If I just show you the files, so I am using stream writes, and where is my stream writes? In the ingest.py. See, remember? So I am using this particular source as my dependency, right? So it will automatically detect the dependency and it will build the DAG automatically to show you the complete flow. Isn't it amazing? Obviously. That is why I love using DLT whenever I can. Okay. So let's see the DAG and then you will understand what I'm trying to say right now. Let's see. And it should be done if everything is fine. It is throwing this red thing. I don't know why. Sometimes it just gives wrong warnings. No. Okay. So it is saying cannot have multiple queries named uber.bronze.writesBulk for uber.bronze. What is this error? Let me just see. Append flow df dot read stream dot table append flow. Okay. dp dot append flow target equals to staging rights. Streaming load. Let me just check this error. Cannot have multiple queries named uber.bronze. I think something is wrong with the same name. I think I have just done something wrong with the naming. Let me just check. Oh, I found it. Haha. So see, I didn't change the function name. So this is not write bulk. This is write stream. I was like, something is wrong with naming. I'm so sure. So let me just say dry run. Now let's see. Because we were just using the same function name for both the functions and we cannot have that. We can have that if we just specify the name in the decorator, but now it is saying cannot be found. This is a different, you can say, issue. Stream writes. What is this stream writes? Oh, it is not stream writes. I think it is stream raw. Stream writes. Or I think it's writes raw. Let me just check the table name. Table name is writes raw. Yes. Silly mistake, but this is the life of a data engineer. Make mistakes, learn, develop, and repeat. Make mistakes, learn, develop, and repeat. Perfect. See, then you see the success. So I will show you the graph, and graph looks like this. Perfect. Here you can see that I have writes raw, I have staging rights as well, and I have just these two tables as a dependency. Now in the streaming table staging rights, where the writes raw? Okay, writes raw. Which is the writes raw? Writes raw is this one. Okay, so writes raw is definitely going to the staging rights for sure, and that is fine. And this table, which is the writes bulk, this is directly going to the staging tables. This is also good because this is directly going to the streaming table. That's why you are not seeing any kind of flow. And then you can see the dependency as well, as I have just mentioned, that this will directly go to this particular table. Let's try to run this pipeline and we should see now total 2000 plus 5, 2005 records in the staging rights. Simple. And then I will run this particular code again, and then also we will see what is the output. Let's see. So this is the output panel, and let's see. So this is, oh, we saw one error. Okay, exactly once writer only supports bash data frame. Okay, not a big deal. We can remove that tag, which is called once equals to true, because still it is good, because if we do not have any new data, it won't throw anything, or you can say it will not be an issue. So I can say dry run just to make sure this is fine. Let's wait. You see the DAG looks good. Run the pipeline. Performance tables. Okay, this is running. Streaming bronze, and exactly once writer only supports bash data frame, but I removed it, right? Oh, I didn't remove it from here. Oh man. Let's say now run pipeline finally. Perfect. So now you will see the output. The output is output record for this one. Uber.bronze_rights_raw is 0. Why? Because there is no new data. And staging rights just did the output for 5 records. Why? It should have just done for like 2000 records, right? If this has read the data from this particular thing, which is bulk rights, and I think we have bulk rights. So Uber, bronze, tables, yeah, we have bulk rights. So, okay, so staging rights, append flow, read stream. Interesting. So let me just check the total number of records now. Let me just duplicate it. Let's see. Because that's why we have testing here, and I will go to workspace, and here I can go to Uber project, and I can create the new notebook called silver OBT. Simple, good. So here I can say select asterisks from Uber.bronze. Oh, by the way, we missed one important thing because we need to create it in the silver schema. Yeah, but it's fine. Uber.bronze. Staging rights, because this is a kind of staging table, so it is fine. It is not a big deal. And I'm expecting 2000 records, 2000 plus records. If it is less, then obviously we need to see what is wrong and we will fix it. Don't worry at all. Oh wow, we have 2005 records. I was like, why just 5? So in the dashboard it was just returning the stream records for that particular thing. Now I want to confirm that my pipeline is running fine, because now what I will do, I will run this pipeline for one more time, and I should not see any more data because I do not have any new data in the streaming. Simple. I do not have any new data in the bulk, so I need to make sure that it is not keep on adding duplicate records, just to make sure. Let's see. Okay, now let's try to run this query again, and fingers crossed we should see only 2005 records, and wow, everything is running absolutely amazing. Okay, so it has simply performed this particular thing automatically. Amazing. But okay, what is this value? Rating key partition. Okay, not a big deal. Okay, makes sense, but that is fine. So 2000 records, and if I go to 2000 records, write ID, perfect. So here I have, yes, that's it. So now one test is done, that we have successfully performed the union. So that is done. Now we need to, obviously, like, this is not final, that's why I just call it as staging. So now one test is passed. That means we are able to process this data using our, you can say, using our idempotency behavior. We are not processing the data again and again. We are simply processing the data exactly once. That was my biggest test. So that is passed. So that is a good thing. Now, what we need to do, if you will closely observe, our initial load is absolutely fine. Why? Because we receive the data directly in the JSON format. Yes, but when we load the data in the form of stream, right, in the form of stream, we do not receive the data in a good shape. Why? Because it's not like in a good shape. It is the way we receive the data from the events hub. We receive our data in the form of string JSON, and now we need to convert that string JSON into normal JSON, right? So now we will normalize that data. Simple. Very good. So what we can do, we can simply go to our Databricks. Perfect. And we can also delete this table if you want to. Yeah, like I can drop this table because my test is completed. So I'll simply say drop table and Uber dot bronze dot staging rights. Perfect. Make sense? Delete it. Now what I will do, I will start performing my transformations for silver OBT. And first of all, I will say, let's say writes stream writes transformation. Perfect. Stream write transformation. So what I will do now, I will simply say, let me just first of all read the data. How my data look like? df equals spark dot read dot format. Format is, I know, like in the delta format. Yeah. Or I can also say dot table, which is uber dot bronze dot what is the table name? Stream writes raw. Simple. So this is my raw data, and you will learn amazing transformation techniques as well. Okay, that will help you a lot. Perfect. Okay, as you can see that we have columns such as key, value, and we have topic name, partition, offset, timestamp, and then writes. This is the main column that we want to normalize because there are so many columns inside this. See, and this column is of type string. So now whenever you have the data frame, or basically column in the data frame, and the data inside that column is in the JSON format, but that JSON is in the form of string, then we have a special function called from JSON, not to JSON, from JSON. So what we can do, we can use from JSON and we can just put that column name, and then we can define the schema we want on top of this particular table, or basically, because this is a data, this is a table in itself, right? See, there are so many columns, and then it will automatically create the columns on top of this particular string JSON. I know you didn't understand everything because this is a complex thing, but you are learning complex thing because then only you will land your dream job or whatever you want to do, right? With the knowledge. So now let me just explain step by step. Let me try my best. So now we have this data in the JSON format, right? Yes. Agree. Okay, good. Now we have this data in the JSON format. Good. Now I know that I have key value pairs inside this JSON. Agree? Good. Now what I will do, I will apply my schema. I will say, hey, ride ID is of string type. Hey, vehicle ID is of integer type. Hey, vehicle make ID is of integer type. So when I define schema like this, and when I pass this schema along with from JSON function, it normalizes our JSON column. Simple. Now understood? Good. So now let's try to do it. Now the biggest question for me is, where is my schema? Ansh Lamba, you can just create your own schema because you can see the data types and you can just create it. Do you really think I will create the schema like this? Not at all. So what I will do, I know that the similar data that I have is in this table as well, which is called bulk writes, right? And this table is like very intact, very like well formatted, right? So do you know what I will do? I will simply grab the schema from this table. How? Let me just show you. So I will simply say spark.sql and then select asterisk from uber.bronze.bulk writes. Simple. This is my data frame. And then I will say df.schema. I think so. Yeah, see, I have got the schema. This is the schema. Wow. And I can even save this thing in the variable, right? Schema. That's how you play smart, right? So now I will simply put the schema here. Simple. And now I will use this schema. So what I will do, I will simply say df equals spark.read.table, or just to be professional, I can even copy and paste the schema as well like this. It's not a big deal. Okay, it's not a big deal at all. So I'll simply say rides schema equals this thing. Perfect. Struct type, yes, obviously we have not imported that thing from yeah, good. So see, this is my schema. So let me just run this. Perfect. So now what I will do, I will simply say df equals to spark.read and blah blah blah. Then I will normalize it. I will simply say df equals df dot with column. Okay, and not just with column. I will simply say df parsed df dot with column, and here I need to pick a new column name. I will simply say parsed rights. Simple. And now I will use from JSON, which is the column value. Okay, and not value, it is called rights. If you remember, see, this is the rights column. Perfect. And then I simply need to pass the schema. Simple. And at the end, which is the most important thing, I also need to pass, what is this thing? Parse right dot asterisk. Let me just tell you. So this is the way, and for now, let me just remove it. Let's do it one by one. And I will simply say df parse. Let's see what do we get. So this time I have got this column parse right, and see, this time it is not a kind of you can say string column. Why? Because this time you are seeing a hierarchy button, and this is the schema. See, this is not a string, this is a string, this is a string ABC, but this is not a string at all. Parsed rights. Simple. Now this is a pure JSON column, and how you simply fetch the columns from a JSON? How? Simply use dot notation. So let's say you want to get this column only. Let's say ride ID. So you simply say dot select. You will simply say dot select parsed rides dot ride ID. Let's say like this, right? And if you just run this, you will see the ride ID column. Simple. If you say, let's say vehicle type ID, then you will see just one column, but we want all the columns. And again, do you really think I will type all of the columns like this? Not at all. I will simply say asterisk. When we say asterisk, it will simply grab all of the columns, and now you will see your data frame in an accurate way. And this is the thing. See, wow. And this is the exact schema, exact data frame that we want to union. Wow. Simple. Now we will apply this transformation in DLT. Now you need to simply copy all of these things. Not this thing, basically, only this thing and the schema. Let's do it one by one. So you will go to Uber rides. Okay. And here for the streaming load, here you need to obviously perform the transformation. Just perform this thing, df parsed equals to this, and here you will also define the schema. So define schema at the top, so that code will look much more nice. I can also create a kind of configuration, but Ansh Lamba, why you want to make your code messy? Okay, let's keep it straightforward, because I was thinking to put everything, the schema, in the parameter, and then I can just fetch it. Then you will see, Ansh Lamba, why are you just adding more and more challenges? Okay, it's fine. Okay, this is fine. Okay, and what's wrong with you, bro? Why are you red? I don't know. So this is this thing, and then say display, not display, return df. Simple. Okay, let's do a dry run and let's see what will happen. Let's say because this is a big win. Once we can achieve this, then okay, let's run the pipeline and let's see. Fingers crossed, fingers crossed, fingers crossed. And I hope you understood what we have done. See, it was tricky. It was very tricky. It was very complex. But the good thing is now you understood what we did. So I am really happy for you. I'm really happy from the bottom of my heart. This is done and I want to see second green, please. Yes. Yes. And you can see 2000 records in the output. Very good. Let me just run this pipeline for one more time, just for the duplicates, right? Let's see. Just for the duplicates. This time run complete. Yes, zero records. Perfect, because no new data is there. Very good, very good, very good. So now I will test my data. I will simply say select asterisk from uber dot bronze dot staging rights. I will keep it in the bronze schema because this is still staging table, not the silver table, final table, because we still need to apply a lot of joins. So bro, this looks absolutely amazing. And we have these columns. Why? Let me just check. I think something is wrong. Okay, because it has not performed this 2001, 2003, 4, 5. Okay. So something is wrong. It has not performed the transformation. I don't know why. Let me just check the code. So stream write, streaming table, writes raw, df parsed is this one. Okay, from JSON, write schema. This is done. So why? Oh, see, silly mistake. Just identify what is that. Let me just give you 5 seconds. It is very obvious. Okay, and my cursor is also there. So I returned simply the df. I should return df parsed. Obviously, whatever I will return, it will be the result of the table. Oh, Ansh, Lamba. Overexcited creature. See, I am really happy for you that you are learning and you are saying this thing to me. Not good. So let's drop this table for one more time. Let's see. Let's run this particular thing for one more time. And this time it will be awesome. And you know what? I want to run my web application for one more time. I really like it. So what I can do, I can simply run it here. And let's say this is the, I will simply book a ride. Simple, ride confirmed. So now we have one more data. So now we will be having a quick test as well of that particular thing. And I think this web application is actually very good. We can actually have fun while building the project, because see, it gives us the real world simulation, and that is everything in the learning. That is everything. So this is completed and you can see 2000 records. Now I will run this for one more time, and this time we should see one new record in the streaming, right? Because we have booked a new ride, and this will just keep on running for the new data as well. Okay, let's see. Fingers crossed. Fingers crossed. Okay, perfect. I can see one record here and 0 records in the, and 1 obviously, because this will obviously go for the, you can say, union. Amazing. Lovely. Very beautiful. So now let's try to query the table. Now let's see. 2006 records. Number of records are fine, but the real test is the bottom records. Finally, you can see my data frame, and it's looking amazing, looking like a wow, amazing, bro. I love it. Perfect. So my test is completed and I am really happy. Okay, so now the next thing that we need to do is we need to transform the other data frames, and we need to apply the joins as well. Now I will teach you a very important skill which will boost your learning a lot, and I'm not kidding. So now what I'm gonna do, let me just show you. Where is my web application? Not web application, wait, I have opened so many tabs. Wait. Okay, perfect. So our this point is done. Streaming table done. Now we have to apply the join with these mapping tables. Now I am going to show you a very important skill. We will be building metadata driven pipeline for silver layer, which is called OBT, and we will use something called as Jinja. Yes, you heard it right, Jinja. What is Jinja and Lamba? Hold on, I will just tell you. Okay, Jinja. And let's use, let's say, black opacity, this one. So we'll be using Jinja. What is this thing? This is the most powerful thing that you can learn in today's era. Okay, most powerful thing. And this is something that I love a lot. While discovering DBT, okay, while discovering DBT and while working with DBT a lot, I realized that we can build our own version of DBT as well. No need to rely on a dedicated framework for it. And then I just started exploring about the libraries that we have for the templating. I found this library, Jinja. And obviously we use Jinja with HTML a lot. If you are familiar with APIs and all, HTML, CSS, we use Jinja a lot. Then I realized HTML is also a text. SQL is also a text. And we can combine both the things. And then at the same time, I was exploring DBT a lot. Then I realized that DBT is actually doing something similar that I am planning. So I was like, okay, this thing is working because that is already validated by the industry. Then I realized to build my own metadata driven pipeline. Okay. So I built a lot of metadata driven pipelines for Silver Layer, for OBT, and now I want to share that knowledge with you as well. I think I have shared the similar knowledge only one time in the past when I was building one project, but after that I am just sharing this knowledge right now. So now what are we trying to do? So now the problem, let me just tell you the problem statement first of all, what that Jinja will solve. We have this table, that is fine. We have these tables as well, fine. We need to apply a join, right? Yes. Let's say today we are applying join with this one table, one big table, and 1, 2, 3, 4, 5, 6, 6 tables, total 7 tables. Tomorrow, your manager will say, hey, just add this table as well, and this is the joining key. Day after tomorrow, let's say next week, he or she will say, hey, add this table, and this is the joining key, and this is the transformation I want to apply. Then so on, then so on, then so on. This is a very normal practice. Every time you add a table, you break the code. I'm so sure about it. I'm so sure. I'm so sure if you are working with PySpark, if you have like a very big notebook which is performing transformations and everything, you will break your code. I'm 99% sure. But then with this particular, you can say, approach, your code will not be broken at all. And I'm not kidding. I am not kidding. So now what this will do? This will build a Jinja template for your SQL, not for HTML, for your SQL. Okay. And then whenever you want to add a new table, you can simply add the new table in the configuration file, and it will automatically pick the table name. It will automatically pick the join condition. It will automatically pick the transformation, and it will add that table in the join. We are not using list comprehension. We are not using Python comprehension, nothing. Jinja, pure Jinja. Because I have built the similar code with Python list comprehension, with your Python classes and function. It requires you to write a lot of code, and that becomes messy. That is just a waste of time. When you apply Jinja here, you solve the problem with much cleaner code that you can maintain, because maintaining a code is one thing, writing a code is one thing. You can write any code, that's not a big deal. You can just go to ChatGPT and get the code written. It's not a big deal. You need to maintain the code throughout the organization. That is the bigger problem, right? ChatGPT cannot solve it. It cannot standardize your coding. No, not at all. So let's learn that thing. So now, what are we trying to do in the Jinja? So first of all, I will just show you the Databricks. Perfect. So here you would need to install one library. Okay. And let me just do it step by step. Okay, perfect. So let me just write it here. I will say Jinja template for OBT. Simple. Jinja template for OBT. So first of all, you need to install Jinja. pip install Jinja 2, and it will take some time to install the Jinja 2 on your requirement already satisfied. Okay, so Databricks free edition has already installed Jinja 2. That is a good thing. Now you need to write the code. Okay, simple. So now how can you just write the code? Let me just tell you step by step. Okay, do not rush. So first of all, before continuing with this particular approach, let me just tell you, whenever we just build any kind of template with Jinja, we have to write our code and then render it, then see the errors. Not errors, basically the small syntax missings, or you can say syntax errors that can throw the, you can say that can actually show you so many errors. So just in brief, I am just trying to tell you, whenever you are just trying to build anything with Jinja 2, with SQL, with PySpark, you will see a lot of errors. So just accept this thing beforehand, because you will see the errors because you are trying to render it before rendering it. Because you do not know the results of rendering it, right? When you render this template, then you see the results, then you just correct it, and then you get just keep on doing, and finally you will see, just get the template which will be free of errors. And this is a kind of one-time effort that you do, because after that it will not be any kind of, there will be no errors in your code. Okay, so if you are new to this Jinja 2, if you see errors, do not feel frustrated, because I can feel you, because when you are learning something new, okay, and especially Jinja 2, if you are seeing some errors, you can feel frustrated, but it's fine. Okay, so this is a kind of prerequisite that you should feel okay if you are seeing errors, especially with Jinja 2. Very good. So now let's start our amazing code. So this is pip install Jinja 2. This is already installed, but still let's keep it there. So first of all, we will just take the scenario where we first of all want to apply a join between our main table, which is staging rights, with map vehicle type, let's say. Or let's try to apply join between three tables just to test the syntax, because once you can apply the joins between three tables, you can keep on adding the stuff. Simple. So we always start like this. So let's say we want to apply a join between bronze tables 9. So we want to apply joins between staging rights. Okay, and let's say these two tables. Okay, simple. Very good. So now what I will do, first of all, whenever you want to build anything, we need to create, or basically kind of blueprint that we are trying to achieve. So I will first of all write the query, the basic query that I will write for the join. Simple. So select asterisk from, not actually asterisk, and let me just select asterisk from, and not asterisk, it's stg rights dot asterisk, because we always use alias. Okay, so select stg rights from uber dot bronze dot staging rights. Simple. So we just do this thing, and then we say alias as staging rights. Perfect. And then I will say left join. Left join, I want to apply it with dot map vehicle types, and again the alias is map vehicle types on type id. Perfect. So this is my join, and let's add the third table as well. On left join, first of all, map vehicle makes. Okay, simple, like this. On and make id, I guess, make vehicle make id. Let's try to run this and let's see if this is working or not. Simple. Okay, this is working absolutely fine, and we can see the result as well. Perfect. Very good, very good, very good, very good. And now obviously we need to print the columns from the other table as well. So, but that is fine. That is, we will just do meanwhile while building the template. Now we are trying to build the metadata driven pipeline. What is the backbone of metadata driven pipeline? The configuration, obviously. So let's try to define the configuration. So I will simply write, and I can just do it here. So Jinja config equals array, because obviously this will be array because there will be like so many objects. So let's define the dictionary. Okay, so what should be the first thing in the dictionary? Let's say table name. Table. Okay, and table name will be, let's say, Uber dot bronze dot I think staging rights. Simple. Okay, perfect. The second thing will be select statement, like what columns I want to select. Simple. And here the user has full freedom. The user can write some transformations as well. Let's say the user wants to perform upper of right ID or anything. This is a kind of template which allows user to do everything, transformations, and you can say everything. So I will for now not perform anything, but I'm simply telling you. And just a quick you can say tip, or not a tip, info. We are trying to build this template obviously on the fly, before testing anything, before doing anything. You will see the power of this template even if you are building this template on the fly. Just think about the power when you will build this template on your own, with obviously full focus, by devoting some extra time, by considering your organization's requirements and everything. Then just feel the power of this template that you will build. Okay, so this is actually very, very, very powerful, very powerful. And this is the knowledge that you are getting it right now. Just encourage, if you feel happy, just write the thing in the comment section. I will also feel happy when you will write those things. I will feel much happy, and obviously I feel happy when you feel happy, so let's feel happy together. So over dot, and this will become bronze dot map. Okay, map vehicle. Type it types. What is the table name? Let me just open the GitHub file as well, meanwhile, like in parallel, so that I can just match quickly the file names, or basically table names, both are same things. Types. Perfect. So this is my select statement. Do I have any kind of where clause? I can just allow the user, if you have any where clause, you can simply add it. I want to apply, like provide as much transformations as I can. We do not need to apply group by, because in joins we do not apply group by at all, usually not. So now, and again, like if you want to dedicatedly put time, you can just do anything, but this is our first object. Let's create the second object. So second object will be let me just copy and paste it. Perfect. So here, so table name will become, what is this? This is not map, this is staging rights. So I want obviously all the columns from this particular table. Simple. And here it will become staging rights, and I do not want all the columns, because obviously whenever we apply join, we can have redundant columns, because staging rights will also have the joining column, and this will also have the joining column. We do not do that thing. Okay, so we can simply say I just want the columns from staging rights, not from staging rights, from the vehicle map vehicle, and then makes. Simple. And I can quickly check the columns. Map vehicle has just 2 columns, and here I will simply get the vehicle make. Simple. I just want this column, vehicle make, and I don't want any where clause, and I have a join condition, obviously. Simple. On, and I will say on condition will become uber dot bronze dot staging rights equals, and dot id as well, vehicle make id, and this is the make id. Perfect. And join type, we usually apply left join in most of the cases, so let's keep it left, because we do not apply inner join at all, but you can provide that parameter as well. You have full freedom. Okay, so 1 2 3 4, what else we can just add? On is done. Perfect. So now let's try to do the same thing with vehicle types, and let me just take the column names with the type. For types we have much columns. Yes, we have so many columns. Let me just write it. So we have vehicle type first of all, then we have description, then we have base rate, then we have per mile. Wow. Then we have per minute. Simple. So these are all of the information that we have. Perfect. Then what we will do, where clause is fine, and we just need to write it here, type. Yeah, type and type ID. Perfect. So this is my config. This is just for 3 tables. We will add more and more tables, but let's test it for the first 3 tables first of all. So this is my config. Now do you know what? Now magic will happen. Now I will simply say from Jinja to import template. Simple. So now what I need to do, I need to simply write my query. Okay, so what I will do, I will simply say, let's try to write the query in the SQL form first of all, so that you can just see the context. Okay, see the text in a better way. So I will say select asterisk, and not actually asterisk. Now I will do the Jinja magic. Now I want to bring all of the select statement of all of the config file, right? All of the array, all of the dictionaries of the array, right? So I will run a loop in the Jinja. Now, yes, you should know some basics of Jinja. Even if you do not know the basics of Jinja, it's fine because you are learning new thing. And yes, there's a small homework for you that you should explore some Jinja functions. Now there are so many Jinja functions, so you do not need to explore all of the functions. You just need to explore the functions that I'm just telling you here. For loop, if condition, and variable, and that's it. These 3 things. Basically, whatever I'm telling you here, just explore those things and you are good to go. Simple, good. Because Jinja has a very detailed documentation. Okay, so you don't need to worry about that thing. So what I will do now here, I will run a loop, and in order to run a loop in Jinja, you use this thing, curly brace and percentage sign, and then you write your for loop. And the best thing is the syntax is very similar to Python, so it will be like very easy learning curve. So I will say for, okay, and then I will say select in selects basically. And what kind of selects? Not actually, let's say selects, let's say config in configs. Simple. Okay, so this is my config in configs. So this is my loop starting point. Okay, now what I will do, let me just undo. So now what I will do, I just need to fetch the select statement from this particular config, right? Because config is this one, the complete config, right? So this is the complete config. Now if I want to fetch just this particular thing, okay, then I can simply pass that value here. So for config in configs, or you can say configs of select, you can just do anything. Okay, but I will simply say config of select. Simple. What this will do, this will only fetch the select dictionary, select key of this particular array. Treat it very similar to how you just write your code in Python. Simple. And let me just remove this percentage equal sign because it gives me like red warnings, because whenever we just write our code, we always write it in the Python string. Okay, so let me just remove this thing and let's write our Jinja string equals use 3, you can say quotes, single quotes. You can also do it like this or double quotes. Okay, now you can just write it in a better way. You will see 0 warnings. So now let's try to write it again. Select. Simple. Okay, and now within the select, I will simply pass the Jinja like this. So I'll simply say for okay, and config and configs, because the variable name is configs here. Perfect. Or Jinja config. I can also say Jinja config. Simple. So this is my for loop. That means my for loop is initiated. Now within this for loop, I want to simply fetch the, you can say each config. Each config is a dictionary, right? So I'll simply say config and dot select, or you can say dictionary notation. So this means now I am selecting only the select key of the dictionary. Make sense? So whenever you want to use any kind of variable, we use double curly braces. Whenever you want to use for loop or if condition, we use curly brace and percentage sign. Simple. Okay. Now it is very interesting. Now you know that I want to add the comma as well. Okay, and just let me just tell you, it is a complex topic. You would need to just rewatch this part multiple times, but it's fine. It's worth it. So now what we are trying to do, we need to add a comma after each select. Obviously, when I just write this, I need to add a comma. When I write this, I need to add a comma. When I will write all of these things, right, I do not need to write a comma. Why? Because this is the last thing. Last comma should not be there. Let me just show you. So here I will say, if you can say, if not loop dot last, if not loop dot last, then simply say comma. Okay, if not, and then end if. Simple. And I can also say end for as well. And 4. Now do you know what will happen? Let me just show you the results of this first of all, then you will understand better. So this is my Jinja string. What will happen? It will run a for loop on the entire array. Then it will simply fetch the select statement. Then we need to make sure that we are adding a comma only and only if my object is not the last one. Why? Because if I add comma after this last object, this one, then it will be a kind of error. Right, it will be a kind of error, because when we just say select this. So let's say I have this particular thing. Let me just copy and paste it here, the same simulation. So here you have the first object. Is this the last element of the array? No. Add a comma and put this thing. Very good. Is this the last object of the array? No. So simply add a comma and put this thing. Okay. Is this the last object of the array? Yes. Do not add a comma, because if I add a comma like this, it will be an error, because I cannot have the comma after last particular object. Simple. This is exactly what we are trying to do here. See, if not loop dot last, then comma, otherwise do not do anything. Select statement is done. Now here comes the from clause. I will say from. Now I need to just go it like one by one, from this, right? Same thing. So let's run a loop again for config in Jinja config. Simple. And here I will simply say config dot from, or not from, basically table, right? Table. Simple. Okay, very good. Table. And I can also do one more thing. I can also say as, because we are using the alias. Simple. Because it is user's choice what alias the person wants to pick. So I'll simply say as. I don't need to put as, I can simply say this thing. Yeah, perfect. And perfect. So here we have this particular thing from config.table. Again, whenever you will be just doing from clause, now just tell me one thing. Do we need to run a loop over all the tables? Not really. Not really. We just need to put from table when we have only the first object, because rest of the objects will go under left join. Oh, so here we have another object, if condition. So we will run the loop and we will simply say if loop dot first, that means if it is the first element of the loop, then simply write config dot table. Otherwise if it is not, then we need to write left join, right? Exactly. And then we also need to write on, like what is the condition? On config dot on and if. Perfect. Perfect. Wow. Exactly. And we also need to make sure the where clause. Okay. Let's see. What do we have in the where clause? Then I will say where. Then again run a loop. First of all, for config in Jinja config dot where. We do not have any kind of where, so it's good. It's good, right? And it will simply say if we have multiple where clauses, then we can simply say and, otherwise and if. But in our case, we do not have any kind of where clauses, so that is why it is good. But this is, you can say, for future use cases. Simple, very good. So this is our Jinja template that we have built for our query. Let me just show you what is the result of it. So now this is my string. So I will simply say from Jinja to import template, and I will say templates equal template, and I can pass Jinja string, and then I can say rendered template equals template dot render, and Jinja config equals to Jinja config. Simple. And I will just show you the query as well. So what it has returned. Let's see. Unexpected end of template. Jinja was looking for the following end for. Okay, I think one for or end if is missing. Yeah, this one. Not a big deal. We just need to close this end for. Perfect. And let me just rerun it. Unexpected is closed for end for. Okay, end for. Okay, this one is also not closed. It's fine, because usually we do not close the for loop in Python, so I forgot to close it, but not a big deal. Let's see, Jinja config is not defined. Yes, because we didn't run this cell. Let me just run this, and let me just run this as well. Very good. This is my query. See, this is dynamically created. First of all, select uber dot this thing, comma, uber dot this thing, comma, then tuck, no comma, because this is the last object. Then from clause. Very good. Let's read the query. From clause, because this is the first object, then left join. Very good. And we have the condition as well. Then left join, then we have condition as well. Then where, and. Okay, this is actually a problem because we cannot have and like this. I think I should add a condition on the size of the where. If the where is empty, then I should not add and. Let's do it. Let's apply that condition. If not, loop dot last and if. Let me add one more if config dot where. Yeah, this is perfect. And let me just say end if. And if. Perfect. Let's see this. I think this will work. Let's see. Yeah, not really, because where clause should not also be there if we do not have that thing, so I cannot hard code it. Okay, let me do one thing. I will remove it from here. I will say if not loop dot last. Okay, then this is the thing. So I can say oh yeah, it's fine. I got it. I will simply say if config loop dot first. Okay, if loop dot first, then where. Exact, bro, what are you doing? If loop dot first, then simply add where, otherwise do not do it. End if. Simple. End if. Perfect. Simple. Let's test it. I think it should work. Encountered unknown tag end for. Okay, let's see what is wrong. Oh, who wrote it else? I wrote it end if, bro. Okay, let's see the query now. Oh, we still have where. How? Oh, because obviously the where will be there because loop dot first is there, the element is there. Okay, I can write this condition as well again. This one, not a big deal. Not a big deal. I will simply say this thing. Where end if and end if. Perfect. We have all the solutions, bro. No need to worry at all. Yes, now it is good. Wow, this is good. Now this is the perfect query that is there for me. Yes. So now do you know what? I can run this query and you will see the result. Let me just show you. So this is my query, right? Now I will simply say, let me just delete this query and I will run my rendered query. I will say df equals, or let's say spark.sql, and I will say rendered template. Let's see what do we get. Dot staging rights cannot be resolved. Did you mean one of the following? Vehicle make ID. What is this thing? Vehicle model, a column variable or function parameter with Uber bronze dot rights dot vehicle make ID. Okay. Dot vehicle make ID. So if we just try to run this query as it is, if I copy it and if I paste it here, and if I just try to run this, let's see the error directly here. Okay, so this failed. A column variable, I think this is just a typo with the column name. Let's confirm. Staging rights on this thing, Uber dot bronze. Oh, I know the error, because we are using this particular thing. On condition should not be like this. On condition should be a kind of alias. So I found the issue as well. Not a big deal. So issue is in the on condition. So we do not need to write it like this because we are using the alias. Simple. Okay. And perfect. And perfect. So let's see. And let's see this time. Did we run this thing? Yeah. And can we see this thing now? In the from clause, on staging rights or vehicle make ID, staging rights or vehicle. This is fine now. So now what is the issue? Render template. Okay. A column function name, map vehicle makes dot vehicle type ID cannot be resolved. Okay. Vehicle type ID, map vehicle makes. If we have map vehicle makes, let me just bring the map vehicle makes. Okay, so we have vehicle make ID. Yeah, we have vehicle make ID. And what is it saying? Vehicle. Oh, we are using vehicle type ID in the make ID. Again, config level thing. Okay. So here we need to use type ID, obviously. And we are seeing make ID or basically type ID here. I don't know. Let me just see. I think I found the issue. We are using my map vehicle make ID, or you can say type ID. Oh, okay. Silly mistake. We need to use types. Silly mistakes. It's fine. Let's try to now see staging rights dot asterisk. Okay. Given input. Yeah, that is also fine. I already told you, you need to just do a lot of back and forth, because whenever you're just rendering the template, only then you can see the errors, right? And here we also need to see, so in the select statement, I will simply say this dot this, and here it will become map vehicle types. Okay, this one is good, this one is good, this one is good, this one is good. Perfect. Now let's see, do we have any other errors? No. Finally, congratulations on Lamba and my lovely family members. So let's try to say display. Finally, That's how you build metadata driven pipeline. So now do you know what? What we have achieved? Let me just tell you. Now let's say we have built this final Jinja template. That is a good thing. That is a very good thing. Now let's say your manager, your director, your team lead, whatever, okay, whoever, ask you to, hey, can you please add one more table? Hey, can you just please perform this transformation? Hey, can you please add this where condition? Hey, can you please do this? Can you please do that? Instead of breaking your code, now you simply need to add that configuration in your array, in your config file, and boom, your query will be automatically ready. You do not need to touch your code. That's it. And see, this code, this is like little code. And if you will just try to build the same thing with the list comprehensions, it will be a mess. I'm telling you, because I've tried building that. So like you can achieve it, but you will not be able to understand what you have written. So just forget about the other people will be able to understand what you have written. Simple. So I love this particular thing, Jinja. And now we simply need to complete this configuration file just to put all of the objects that we have and all of the table names that we have. And once we do that, our silver layer is ready. And then we will just move toward the gold layer. And I hope this was helpful. I hope. Make sense? And just tell me in the comment section, how was it? Because this is the kind of knowledge which is rare, I'm telling you. Okay, just trust me. And I'm so sure that you would not have seen this code before. I'm so sure about it. I'm so sure. Because I'm not saying like I have invented this thing, but this is something which I have tested a lot of times. And this is something that I love building. Okay. And this is something that all of those big tech companies, I would say DBT and all, are using similar things, but obviously we do not know the code. But this is the thing that you would use in your case as well. If you do not want to just rely on DBT, you can just build your own version. So you can say that, yeah, we have built our own DBT, kind of, obviously. So yeah, so I hope this was helpful, this was insightful, very well done. And let's see, let's quickly complete our configuration file and let's build our final OBT. Then we can say our silver layer is ready. Hands off. Okay, very good. So now I have finally completed the config file for you. And now our silver OBT script, or you can say configuration, is finally completed. So let me just show you what I have done. I have simply added more and more tables with their selected columns and their finally selected join conditions as well. And I have also put the column names for my staging rides as well, because it is always a good practice to just put the column names whenever we are trying to build the tables, and this is the backbone for the next step as well. So that is why we are just trying to do this. Okay, so our configuration is done, and let me just show you by running this. Let's make sure like everything is running fine. And I can say template equals template, and this is our template, Jinja string and random template. And I can say spark.sql render template. Okay, perfect. Display, perfect. So this will just give us the result, and let's make sure like everything is fine. Okay, perfect, everything is fine. So our silver OBT is ready, not actually ready. Why? Let me just tell you. So now we are going to make some changes, because first of all, silver OBT is obviously kind of ready, but it is not ready for the gold layer. Okay, so now let me just tell you what are we trying to do. So let me just show you first of all the business problem, and this is the kind of problem that we always try to solve, like we data engineers, and this is one of the biggest pain as well. So let me just tell you what is that pain. And this is my repo. So now obviously we are using these files, mappings and all, and these mapping files contain some contextual data. But just be honest with me that will this static data, will this particular mapping files be same throughout the lifespan? Obviously not. These data files will always be changing, right? Yes. So now this comes up with a problem that how we will be just managing that data which will be changing. I would say which will be always changing. So for that we have a concept called slowly changing dimensions. Slowly changing dimensions are the dimensions that we build in the gold layer, not in the silver layer, but we need to prepare for the gold layer since the beginning. Now, why I didn't add this particular column or this particular thing in the beginning, I wanted to show you and I wanted you to feel the problem instead of directly showing you, hey, we are building slowly changing dimension. Now you can relate that why we build slowly changing dimension, because these are our mapping files, and obviously city ID equals to 1. For now it is called New York, maybe tomorrow it will be like called as Vegas, right? So we need to like build a system which will take care of the changes as well. So for that, do you know what we do? We build slowly changing dimensions, obviously, and there are basically 6 types of slowly changing dimensions, but in the industry we just use type 1 and type 2 most of the time, not even type 3. So for now we would need a kind of flag that when this value was changed, if we want to build type 2, okay, if we want to build type 2. So I will just show you how you can just build type 1 and type 2 both. 90% of the time people will build just type 1, 90% of the time, especially in the case of lake houses. But yes, type 2 is becoming more and more popular, and obviously after these kind of frameworks, SDP, it is so easy to build type 2 as well. But with type 2 we always need a kind of timestamp, always. And obviously we will just learn about type 1 and type 2 in detail in gold layer, but for now we need to prepare the thing, right? So obviously I'll be just building both the kind of you can say your dimensions, but I want to build type 2 dimension as well for city, or you can say for region, or for demographics basically, right? So what I will do in my this file, I will simply add one more column, which is let me just click on edit. So I will simply insert one more record. I will say updated at, simple, updated at, and I just need to pass the timestamp. So timestamp can be, I can just grab the timestamp from here. So let's say select UTC now. Do we have UTC now or current timestamp? Oh yeah, I can use current timestamp. Current timestamp. Perfect. So this is the value that I can just simply copy and I can paste it here. Simple. So that means this value was last updated at this timestamp. This is the meaning of this thing. Simple. Very good. So I can insert this thing in all of the key value pairs, and perfect, perfect, and perfect. I could have used for loop for it to insert the values easily, but I think they're just 9 values, so it's fine. Good. Oh, 10 values. Okay, no worries. So I can just save this now. So now what I need to do, I will simply go to my ADF and then I need to run my pipeline again so that I can just get the latest files, right? And obviously we are just loading the data in a streaming manner, so it will simply override the data. It will not create the duplicates. So let's quickly run our pipeline, and I can go to pipeline. This is my pipeline, and I can click on debug directly because I know it will directly fetch the data from the HTTPS. Perfect. Meanwhile it is running, I also want to do one more thing. So now if you remember when we created our table, let me just bring that file, our bronze file, this one, bronze ADLS. So when we just created this file, or basically notebook, we can also add one more transformation for, you can say, basically all of the files if I want to. So now in my all the files, I don't want to create any transformation because my other mapping files are like nice and good. So I can only add the special transformation for my map cities. See, so I can remove map cities from my list because I will manually create the transformation for this. Simple. So let's try to do that. And what kind of transformation? Just a hint. So transformation is very simple. So transformation that we are trying to do is we will simply try to you can say convert our timestamp into the, or basically the timestamp column into the timestamp format, because sometimes it cannot infer the schema, right? And sometimes it can. So let's actually try to see if it can. If it can, then we do not need to change anything. If it does not, then we have to just provide it. Simple. So let's try to see if our data is first of all uploaded. Yes, it is done. So I hope it will be done. Very good. So what I will do, I will simply say import pandas as PD, df equals pd dot read JSON, and then URL. Not this one, I would say this URL. Perfect. And I can just fill the value manually here. So the value will become map cities. And this is a kind of advanced skill that you are learning. So you have to put some extra efforts to learn the slowly changing dimensions and all, because this is not like a beginner level thing. But now you're not a beginner. Beginner things are over. Now you are growing with this project, right? So now let's say df equals spark.create data frame, first of all, like this, and display df. Oops, not df spark. Make sure the value of authorization, which authorization do you want? Okay, I think SAS token is expired, so I can create a new SAS token. No worries at all. I think so this is the issue. So I can go to my data lake and I can go to containers. I can go to access key directly. Not access key, shared access signature. And I can create one more. Container. Generate. And this is my connection string. I can copy it because it was expired. So this is my new token. I will put my token in after the question mark. Perfect. Okay. So now let's try to run this again. Make sure, I think it is it copied or what? Let me just check. SV, it is starting from SV. No, I think it was not copied. Yeah, now it is good. No, this is not authorized to perform this operation. Are you serious? SAS token, connection string. Okay, file queue read permission. Let me just go inside this raw and then I can just create one. Okay, generate SAS token, SP. Now I have just got this one. So let's say, because earlier I just created the token from the outside. So now I have just created the token within the container. So now it is good. So now let's see if, oh yeah, it is good because it is automatically converting that timestamp into the timestamp format. It is really good. So we are good with that. So very good. That's what we wanted. And I do not need to make any changes then. So my code is good. Obviously, now I can simply run this code for one more time because it will simply override the data. And now in order to just do this thing, I would first need to drop the column, drop the tables, obviously. But do you know what? You do not actually need to drop any table because when you use override command, it simply overrides the data. But just a pro tip, when you are working with delta tables, it does not override the schema as well. So if you have a schema mismatch, it will throw the error. So if you also want to override the schema as well, then you can say override schema and true, and that's it. Then it will simply overwrite everything and it will create a fresh table. And yes, I need to use the new URL, like new token here as well. Perfect. So this should now just replace all of my tables. So if I just try to look at any table, let's say map cities, I should see that column. Map cities. Let's wait first of all. Okay. Let me just run one more time. Where is map cities? I think we added that column map cities. Okay. Oh, we just removed it from here, so it didn't override that. No worries. I can now add it. No worries at all. Perfect. Now let's run one more time and let's run this as well. This should now return the timestamp column. So this is just a kind of, you can say, prerequisite for your gold layer, and we have to take care of this thing. But I wanted you to realize why do we need slowly changing dimension, because see, this is the only area where interviewers trick you. And if you are confident with this area, you can actually behave much more, you can say, well in the interviews. So this is my column updated at, simple. So this column means that all of my these values were last updated at this timestamp. So now if I update any value, let's say instead of writing it here Los Angeles, if I say Las Vegas, then I can simply change the value, but I have to also tell that when this value was updated. This is very important for type 2. This is not important for type 1. Okay, so just a pro tip. Now this is done, very good. Now if I just go to my staging rights, and you know that we created staging rights here in the silver OBT, right? So if I just scroll up, and I think I should just actually, it's fine. So in the streaming basically staging rights, we also want to do one thing. So we have already a timestamp column. Don't worry, we do not need to add one. But here what we can do, we can actually convert that column into a timestamp column, because it is converted into a string format by default. So now let's try to do that. So here we have parsed rights, where we have display this thing, because when it parsed the column, it didn't parse it like a timestamp column. Or we can just change the schema as well, that will also do the work. If we just try to find the column called booking timestamp, where is booking timestamp? Booking, yeah, here, booking timestamp. So it is saying string type. I don't want to say string type. I want to say timestamp type. What is the timestamp type? I think timestamp type is timestamp type. I don't know. Let's see. Yeah, timestamp type. So it will simply convert it into timestamp type. Simple. Now let's try to run this thing. Okay. Struct field is not defined. Yes, I know, because I didn't run this thing. So this is good. And let's try to run this as well. So df parse is this one, 6 rows. We know that. And this is where is our booking? Yeah, booking timestamp is now timestamp column. Very good. So this is good. And we can also query it like with using select asterisk, obviously. This is my staging rights. So this is staging rights. Staging rights means the bulk load, right? So we can do the, you can say, transformation here as well in the staging rights, obviously, right? So this is my bulk rights, not the staging rights. So where is my bulk rights? Where we are just applying the union. Oh, so we are applying union there in the, you can say, DLT. So what I can do now, I can just go to my DLT. Where is my DLT? So this is my DLT, and I was just testing something, so you can just ignore. So I will simply replace this, and in the silver.py, and just ignore test.sql, because this is for advanced thing that we are just going to do right now, but don't worry at all. So now what I can do, I can simply change the schema here as well, because that's the thing we are doing here. So I will simply say booking timestamp here. So I will say timestamp type. Perfect, timestamp type. And now what I will do here in the df, I will do the transformation for bulk rights as well. Simple, because we need to keep the schema intact. So df.with column, and then booking timestamp. So we use .with column, like .with column method, whenever we just want to convert or make any transformation to our column. Simple. Okay. So now here is the booking timestamp, or I can say simple .cast method is also good. Column of booking timestamp .cast timestamp. Simple. So it will automatically convert it. So now what I can do, now obviously this will be a kind of new table because the schema will be changing. So just to be on the safer side, I can drop this staging rights just to be on the safer side. I know it can handle even if I just rerun it. Uber.bronze.staging rights. Simple. So we have dropped this table. Now let's try to run the pipeline, and I can just comment it out, everything that I have written here in the test.sql. because this is the next step that we are trying to do. Simple. So let's say dry run first of all, and let's wait, and let's see what do we get. Because the next step is very interesting. This is like one of my favorite as well in this entire development. Like all the things are favorites of mine, but this is like a little bit challenging. So if it is challenging, it is interesting. So you will learn that as well. So now let's wait and wait. So dry run will be completed. Okay, so now it is almost done, and then I can simply say run pipeline to just populate my table. So I have got the error. They are saying like unable to merge incompatible data types. And why? Because we have both the data types in the form of timestamp, right? So this is interesting. So staging rights is done, and we have here booking timestamp here in the timestamp type. Okay, this is done. And here we have from JSON write schema, df parsed. Okay, and this is also in the form of cast and timestamp. Interesting, because both are now in the form of timestamp, so it should not be a problem to just simply append this thing. Let me just check. So I think according to me everything is fine. I do not think anything is wrong. I was just investigating the error. So I will simply click on run pipeline, and I will say run pipeline now with full table refresh. Yeah, so what it will do, it will simply run the pipeline. I know like it is fine, and we just need to refresh the table, because even if we drop the table in the SDP, we need to just refresh everything. So let's see if it works, because I think both the data frames are of same data type, like the column. And oh, it is running. Let's hope for the best. Let's see. Right. Okay, 2000 and this. Yeah, I think it is good. So this is staging. Oh yeah, it worked. Yeah, I knew it. So what you need to do, if you have also created the table, even if you see the error with dry run, simply click on this drop down and say run pipeline with full refresh. Do not directly click on run pipeline, because you need to do the full refresh, because you are changing the schema. Now you will say we just dropped the table, why do we need to do full refresh? You have to do it because metadata is still there. It didn't just remove the table. Oh, okay. See, so now if I just click on, or you can say run this particular code, it should work. And I should see the column of the timestamp type. Perfect. Where is that? But yeah, perfect. Booking timestamp. So everything is fine. And I can confirm till the end. Yes, everything is fine. So those prerequisites for gold layer is done. But now for silver layer. Now what we need to do, let me just show you the our whiteboard. So now let's discuss what are we actually trying to do. So now what is the scenario? The scenario is that we have the streaming table, obviously, which is this one, and we have the batch tables, which are these mapping files, obviously. Now we need to apply the join, and we want to build the OPT. Now we have the query ready. Yes, we have the query ready, but we want to apply this operation in the streaming manner, obviously. So now in order to apply the joins with the streaming, we have to use a special concept called streaming joins. Okay, so now let me just show you the documentation as well. And you just need to type streaming joins STP. Let me just bring the screen here. Arbitrary pipelines. Perfect. So here stream joins. Yeah, this one. So in the SDP, whenever we, oh, what is this documentation? Yeah, this is what I'm expecting. Okay, let me just open the documentation by myself, because we can't rely on these people. So let's say develop pipelines. Base develop pipeline, streaming tables, perfect. So streamful processing. So what is this thing? Whenever we want to perform joins with the streaming table especially, then we have to use something called as watermark. Now what is a watermark? Watermark is basically used for stateful transformation. Now what are stateful transformations? Now do not need to worry, these are the concepts for Spark structured streaming. Okay, so let me just still explain you what is the scenario. So let's say you are using a streaming table, let's say this one. Okay, this is your streaming table. Okay, perfect. Let me just remove this as well. Let's say this is the only streaming table. Perfect. Now this streaming table will be receiving the streams like this, like this, like this, right? Now we need to decide, or we need to define the watermark. Now watermark is for the expiry of the data, because sometimes when we receive these events, some events that we receive can have a late arrival time as well. For example, there is a event which was supposed to arrive at this time, okay, but arrived after so late, after so many hours. So we cannot keep the state in our memory. In such scenarios, we have to say that watermark. That means the time that we will wait for you. If you are late after that, then we are not going to process your data for the late arrival. So this is just a kind of scenario that we deal with the late arrival data. In our case, nothing is late arriving, because the moment we hit the book write button, we directly get the data in our, you can say, stream. But in some scenarios, you can have the late arrival incidents as well. That is why we use this concept here. Simple. I hope it makes sense. Okay, so we have to use this concept here as well. So whenever we apply the query, like the join, we have to use this code. What is this code? Simple. So far we were using SDP with Python code. So now this time we'll be using SDP with SQL code. Why? Because it is always better to build your joining tables with SQL command. And obviously we have also built our beautiful template that generates a SQL command. So we'll be using SQL query for that. Simple. Very good. We just need to make a very small change, not a change, just a kind of add-on. Whenever we want to read any table with the streaming behavior, in the PySpark code, we simply write read stream. So it would know that we are just reading the data as a table as a stream. But in order to read the table as a stream in the SQL code, then we just need to add a keyword called stream before the table name, so that Spark would know that we want to read this table as a streaming table, and that is it. Everything else is exactly same. And then yes, we will simply add a watermark for our streaming table, and that is it. Simple. This is the code, and you simply say, hey, create or refresh streaming table, and this is the table name. And in PySpark, we simply write def and table name or function name. Simple. Let's try to build this thing. Okay. This is very simple. Don't worry. I know whenever you just look at these things initially, it looks messy, but it's easy. So let me just create a new file, and this file this time will be a SQL file, not a Python file. Okay. Change the language and simply say silverobt.sql. Simple. Okay. So this is our silver OBT. Now in the silver OBT, what we need to do? We simply need to bring the query here, like this query, this query, this one, right? So let me just copy this and let me just paste it here. So I will say from Jinja 2 import, not Jinja 2, because I think Jinja 2 will already be installed. And if it is not installed, what you can do, you can install Jinja in any of the Python file, because it will install Jinja in the entire, you can say, environment. Okay. So what I can do, I will go to silver.py and I will install Jinja for you here. So you will say pip install Jinja 2. Simple. So you can simply add this code here, because you cannot install it in SQL file. So that is why I'm adding it here. Simple. Very good. So now I will say create or refresh. By the way, you do not need Jinja, because we directly have the query. Yeah. So you can simply skip it. It's fine. So create or refresh streaming table, and table name what you want to provide. So I will simply say silver OBT, and here I can say as, and then my query. So my query is this one. Let me just remove the spaces. Okay, so this is my query. And as I just mentioned that I need to write one small thing, which is stream, right? Let's say from this table, and I will simply add stream. I can also make this change in my Jinja code as well, but why I'm not making this change in Jinja? Because you can use that particular code for your PySpark processing as well, for your batch processing as well. And we just need to add stream here if we are just building the SQL query. And you can also automate this particular code transfer thing. You can simply build a Python ETL to copy the code here directly. It's not a big deal. It's not a big deal. You can simply write the SQL file here and then it will simply generate this thing. It is a very basic moving or migration of data. So you can ask like how we will simply populate the SQL code automatically. You can simply use dbutils module, okay, to just create the SQL file directly in this directory. It's not a big deal. It's not a big deal. So it's very simple. So stream and then this table name. And we cannot provide alias here. We provide alias after doing everything. So the next thing is we need to add the watermark. So I'll simply say watermark and we need to provide the column name. So column name will be, let's say, booking timestamp, because I think that is a good column. Booking timestamp, and I can say delay of 3 minutes. Simple. And then I can say staging rights. Okay. Simple. Delay, and we can just confirm everything is fine. Delay of interval, sorry. Delay of interval. Perfect. So this is good. Delay of interval 3 minutes. Perfect. 3 minutes or MINS. Let me just confirm. So it is delay of interval. Delay of interval 3 minutes. Yeah, it is fine. So now this is our query that we are just trying to run, and now let's see if everything is fine or not. So staging rights. Okay, and I can also put this thing in the, I think it's good. Let me just try to dry run it and let's see if there are any errors. Something is wrong. Oh, spelling. Okay. Now let's try to run this. So this should create our streaming OBT, right? And then let's see what will happen. Okay, let's wait. Okay, so this is done and graph is done and perfect. Now I can simply run this pipeline just to see the result. What do we get? So this ran fine and this has 2000 records, and let me just run it for one more time just to check the duplicates and all. And if everything is fine, I can simply test it here. So this is my template, current timestamp, and I can say select asterisk from uber dot bronze dot obt silver obt. Let's try to run this and let's see if we have like all the columns, everything that we want for silver table in the streaming manner. So there should not be any duplicates, nothing. So this is also running. Perfect. Now let's wait here. Ideally there should not be any duplicates, but let's see. We cannot say anything. Now let's wait. So it is running fine. So we have 2006 records and absolutely fine. All the columns are here intact and perfect. So this is our silver OBT table that we have created. Now, yes, we have created this table in the bronze schema because we are using the same DLT pipeline. Ideally, we should create a new DBT pipeline for this, like not DBT, like sorry, DLT or SDP pipeline. But when we create like more than 1 or 2 pipelines, our free edition will be over consumed and it can just throw the error that we cannot build more pipelines. But in the real world, you can create different pipelines. Like you can just create a new pipeline for bronze, new for silver, new for gold, just to keep the things separate. But we do not need to do that. We just need to create our tables and we can just simply change the schema in the during the deployment as well, during a dab as well. So it's not a big deal. Simple. So our silver OBT is done. Silver one big table is done, including the streaming manner. That was very, very important. Now let's see what do we have next. So now let's try to create our gold layer, which is nothing but our data model. And this is the most important layer because this will be used by all of the people. They will complain if they will not find good data here. So this is the most important. But as I just said, silver layer is also becoming more important nowadays. But yeah, gold layer is like gold. It is like gold is gold. So now in the gold layer, what we are trying to achieve. So here we have OBT. That means one big table. Now, yes, there will be some people who will be using OBT, but now we also need to deliver the data in the form of data model. What type of data model? Dimensional data model. Dimensional data model. Okay. Now, when we talk about dimensional data modeling is a technique where we store our data in the form of fact and dimension tables. Fact and dimension tables. Simple. So now what are fact and dimension tables? So let me just tell you. So let's say this is a very big table which has everything, all the information, right? Everything. Now we create first of all the dimension tables. Now what are dimension tables? So let's say out of this big table, you know that I have certain similar columns for, let's say, demographics, which tells me about the location, city, region, country, zip code, address, all of these things. So what you will do, you will create a dedicated table for all of this similar information. So this can become, let's say, dim demographic, or let's say dim location. Dim means dimension. Okay, dim location. Let's say this is one. Now you have figured out that along with this, okay, you have some columns which are very, very related towards, let's say, booking location, or let's say booking, obviously, right? So you can create dim booking, which will have the information about booking, or basically rides. Simple. Okay. Then you figured out that I have some columns related to payment methods, cancellation, all of those things. Then you can create, let's say, dim after booking. Okay, let's say after booking, something like that. Dim after booking, like which tells you about, or let's say dim operations. Okay. Dim ops. Simple. Dim ops. So this thing. Then you have, let's say, one more category where you have data for it can be, let's say, for finances, for or you can say related to coupons or anything. Okay, so let's say dim suspicious. This can be anything. Okay, so when you have created these different tables, these are called dimensions. Dimension tables mean contextual data. This will simply provide the context. This will not provide the numbers. Then who will provide the numbers? The number will be provided by the fact table. Which table? Fact table. Okay, so this is my fact table. Fact table will contain all of my numbers, all of the numerical data, everything. Okay, all of the numerical data. And my dimension will contain the contextual data. This model is called dimensional data model. This is the model, or you can say this is the modeling technique that we data engineers use. Simple, makes sense? So we need to break this big table and we need to create these small dimensions first of all, and then we need to finally build the fact table. Got it? Simple? Yes. Now here comes the concept of business requirements. Now we know that these kind of dimension tables will only contain the context, but sometimes business says that we also want to store some, let's say, dates, some numbers which are not actually the numbers. For example, let's say ID. ID is written in the form of number 1, 2, 3, but it is not actually a number, right? We cannot cannot find any insights using that number. It cannot be aggregated, right? So even if some columns are in the numeric format, it doesn't mean that it will directly go to the fact table. Simple. This is point number 1. Second, this is your definition. But before building the final dimension data model, you have to consult the business that we will be just creating this dimension data model. Each table will contain these columns. Are you okay with that, or you need some changes? Because at the end of the day, you will not be the one who will be using the data, right? Or you can say who will be using the tables. They need to use the table. So you have to sometimes modify your definition as well according to the requirements. So this is the standard, but yes, it is subject to change as per the business. Simple. So if you enter into an organization and if you feel something is like different, it is not as per the standard, it is not as per the books, so it is fine. Data engineering is 80% is as per the standards or books, and 20% is like subject to change. You can just make the modifications, and there is no rule in that. Okay, good. So let's see how we can also create our dimension tables. Okay, so let's see how many dimension tables we can create and which columns we will pick in that. So I know we have so many columns. So first of all, you can see ride ID. Yes, confirmation number, passenger ID, driver ID. So we need to now figure out which columns are related. Okay, so I can see ride ID, which is related to booking, confirmation related to booking, passenger is related to passenger. It is not related to me. But if I do not have much more columns related to passenger, then I will simply add this passenger ID as well in my booking. This is called, you can say, dynamic dimensions. We need to look at the data as well. We cannot just create a dimension just for one column. It doesn't make any sense. So driver ID, vehicle ID, pickup location ID, drop off location ID. Simple. Obviously we have location data, that means city and all, so we do not need to keep it here, so that is fine. Then we have vehicle type ID, then we have some vehicle as well, so we do not need to keep it here. So ride status ID, so we have ride status as well. We have pickup city, drop off city, we have this cancellation as well. Passenger name, oh, so we have some passenger information as well, so we can get started with the passenger dimension. So we have passenger ID, as you saw, passenger name, passenger email, passenger phone, and yes, that's it. So we have passenger information. So let's try to create our passenger. So how we can just create that? So I will simply say passenger, select passenger name, and then let me first of all write from uber dot bronze dot silver obt. Simple. Passenger name, and then we have passenger email, we have passenger ID, we have passenger phone, and all of these things. So if I just query this table, this piece of table, I will get these columns, and now this table will become my dimension table. Oh really? Yes, this table will become my dimension table. Okay, so that's how we create the dimension tables. And how we can create the dimension table, let me just show you. So there's a special, you can say, API we have in the SDB. It is called auto CDC. So let me just show you. Auto CDC flow Databricks. It is basically a CDC flow. Auto CDC, perfect. So here what we need to do, we simply need to write this code, and that's it. This will automatically create the slowly changing dimension for us, because we want to create the slowly changing dimension. Not all the slowly changing dimension, like not all the dimensions are slowly changing dimensions, but some are, right? Some are slowly changing dimensions. So here we simply need to copy this code and we need to simply paste it. So what it will do, let me just show you one by one. So I will go to my pipelines and I will create one more notebook, and I can delete this test. Perfect. So I will create one new notebook or new file, and this will be a Python file. Let me click here, create file. So I will say model.py. Simple. So in the model.py, what I need to do, first of all, from PySpark, import pipelines as db, and then simply paste this code. So now what are we trying to do? First of all, we need to create a dp.create auto cdc flow. Let me just add a comment that we are just trying to create the dim passenger. So here I want to create a target table. So now what is my target table? I do not have any kind of target table, right? If you just click here, it will show you that you need a target table. So if I want to create a target table, I need to use create streaming table. Remember, we used it here in the past when we were just using that append flow here. See, this is the same thing that we need to do it here as well. Let me just close the tabs. Perfect. So here I will simply say, this is my streaming table, which is called dim passenger, and I want to store this data in this particular table, dim passenger. Now what is my source? I would need a source as well. So I have not created any kind of source for now. So whenever we want to create streaming tables, we always create the views. Why? Because you know the answer. We want to pick only these columns, this, right? So now what is the source for this? There's no source. Exactly. So we need to create the source. Basically, we need to create an object which will hold these columns. So that's why we always create a view. And if we want to work with streaming, we always create the streaming view. Let me just show you how you can just create that. So you will simply go here and you will simply say @dp dot view, simple view, not materialized view, simple view. Okay. And here you will say df, and you can say dim passenger view just for the consistent naming convention. And here you need to just write the same thing. So you will say df equals spark dot read stream, because you want to read this data as a stream. Okay. Then format, or let's say dot table, and the table will become, I think we can just directly write the table name. What did we do in the past? Did we write directly the table name, or yeah, we simply write the table name. Okay, I can also write the table name. So the table name is silver OPT. Simple. And this is not it. I also want to select the table like columns. So I will say df equals df.select, and there I will just put my table names. So table name, or basically column names, passenger ID, passenger name, passenger email, passenger phone, and that's it. 1, 2, 3, 4. 4 columns. 1, 2, 3, 4. Yes, 4 columns. So this is my view that I have created. So this will become my source. Simple. This will become my source. So I will simply say the source is dim passenger view. Perfect. Now it is asking me for the key column. Key columns means what is the primary key of this. Now this is very interesting. Now when I created this particular thing, now if you just look at the passenger ID, will you always see the passenger ID as non-duplicated? I don't think so, because same passenger can just book the same ride for like multiple times. So here you have to apply the logic as well for deduplicating. Okay, here you want to apply the logic as well. So yes, when you just write this thing, let's say select distinct here, it will automatically pick the select passenger distinct, or let's say as passenger ID. Simple. When you just query this, you will only get the deduplicated data. Here we are getting 2006 records because the assumption is each passenger is common, but maybe we will be just getting the same passenger booking the ride for multiple times. So we have to make sure we have to guardrail our development. So you would need to apply this distinct property as well in your code in your PySpark. Simple. So let's try to do it. So I can say that df equals df dot drop duplicates, or I can also pick it like this, drop duplicates, subset equals to You can say passenger ID, simple, right? So we can just do it like this as well. So this will become my source, and we can also confirm it with the code as well. So let me just write it here, this one, and let me just remove stream because we are just reading the bash data here for the testing. So silver obt, so uber dot bronze dot silver obt, and if we say display df, then we should just see the data. Subset should be, oh yeah, obviously this should be a list. Okay, so we should see only the known duplicated data. Perfect. So it is working fine. So I can just simply run this here as well. So this way we can just drop the duplicates. Simple. So this thing is done. So now key will become my passenger ID, right? Passenger ID, perfect. Sequence by column, this is very important. Now when we have slowly changing dimensions, I know like passenger is not a slowly changing dimension at all, just in our case it can be, but we will just handle slow changing dimension type 2 as well, so that you can learn. But for now we do not have slow changing dimension. So for sequence by column you can simply say passenger ID. But when it is a kind of slowly changing dimension, then you have to provide a timestamp column so that it will decide like which value is the latest and which value was the earlier value. Simple. Good. And we do not need these values at all. And here I will simply say stored as SE type. So I just want to stored as SE type 1. Okay. And I do not need this value as well. So that's it. This is my code to create the slowly changing dimension type 1. And if it is type 2, we just need to say type 2 and we just need to put it here date column, and that's it. See, this is the difference only. And when you just try to create the slowly changing dimensions type 2 especially on your own, it will take so much of efforts to create that thing. And I'm not kidding, because it is not very easy to handle all of the edge cases as well, but it is not impossible as well, but I'm just simply telling you. So now let's try to dry run and let's see if our dimension passenger is ready. And same way we will create all the other dimensions as well. But first of all, let's go with this one. Let's wait. And if everything is fine, I can even run the dimension as well. Not a big deal. Okay, it ran fine. I can click on run pipeline just to show you like what do we get as the end table. Okay, let's see. Create streaming table, dp.view, dim passenger. Yeah, perfect. And just as a kind of homework, you can also now create your own dimensions by grouping the similar columns together. Obviously, I will just provide you the code as well, but this will make you a better developer when you will be just picking the columns by yourself. When you will just try to look at the columns from a business point of view, not just a developer point of view. Because for you as a developer, all the columns are same, right? So you can just do that practice as well, and it will actually help you a lot. So this is running. Now let's wait. And I think view is running first of all. No, this is table. View is, I think, done. Yeah. Okay, so my pipeline is done. Okay. So now what I can do, I can simply do a quick test if everything is fine. Select asterisk from uber dot bronze dot dim passenger. And let's see our table. Oh, perfect. Our table is ready. See, this is my dim table. Okay, makes sense. Now let's try to create the other dimensions as well. Now let's create the cities dimension, which is a slowly changing dimension, right? Or let's create the other two dimensions first of all, because all the other dimensions are type 1. Okay, and not even slowly changing dimension at all, because these are just like mapping, static mapping files. Only one file will be evolving. This is the requirement. Okay, so now let's try to see other dimensions. So if you will see, we already have one more dimension ready in front of our eyes, which is nothing but the dim driver. So if you will see it here, let me just check. Oh man, the scroll bar. So I can just show you, wait. So now let's try to create our next dimension. And if I just look at the column, so these are the columns. So the next column, or basically next dimension, can be driver. If I just scroll here, perfect. So this is this one. So see, after passenger, I have driver ID. If I just scroll towards left, driver ID, perfect. And I just mentioned that you need to create these tables on your own, okay? But still, if you want to confirm that, okay, are my tables good, are my columns good, then obviously now you can just refer to this section. But I would really love if you would just create your own dimension tables by picking your columns, because by that way, it will test your knowledge as well, right? What have you learned in this first dimension? So let's try to learn that way. So I will pick driver ID, this one, okay? And then I will pick driver name, driver rating, and driver phone, driver license, these things, okay? Let's do this. So this time I will go here and I will say driver ID, driver name, driver rating, phone, driver license, perfect. This one, enough, very good. And this time my subset will become driver ID, obviously, because that is a primary key. Very good. And let's say display. Okay, this is perfect. So now what I can do, I can simply take this code and I can just paste it here. Okay, so let's create our dim driver. Okay, let me just have some space. And we can copy all of the code that we need to create. Okay, this is dim passenger. And this will be my dim driver. Perfect. And this code will go here. Simple. Very good. So this will create my dim driver. So just try to rename everything because it can mess up the things. Dim driver, dim driver. Here dim driver, and the key is driver ID. Simple. This was simple, right? So very good. So this dimension is also ready. Perfect. Now for our third dimension, let's try to see what dimension we can build as our third dimension. Okay, so if I go to third dimension, let's explore. Okay, so our dim driver is also done. Now we can create one dimension for a vehicle. See, we have vehicle ID. If you can see vehicle ID here, vehicle ID. Then what I will do, I will simply say vehicle ID and then vehicle type ID, and then I can say vehicle make ID, right? And then let's try to just write these column names together so that we do not forget. Vehicle ID, vehicle make ID, vehicle type ID, and then what do we have? Let's say we have vehicle make ID, vehicle type ID, and then we have vehicle model, vehicle color, and license plate. Obviously, vehicle model, vehicle color, license plate. Perfect. Do we have anything else for dim vehicles? Let's see. License plate. I think that is fine. Enough. And drop off address. These are like booking related details, so we are good. And duration minutes. Okay, this is fine. These timestamps which should go to the dim booking. And we are good. Oh, we have vehicle make, vehicle type. Okay, vehicle make, vehicle type. Okay, vehicle type, anything else? And obviously if I forget any column, do not shout, just simply add that column. Okay. Then yeah, this is fine. So we have created our vehicle as well, dim vehicle. Let's test it. Vehicle ID. So perfect, this is our vehicle, dim vehicles. So I can simply go here and I can copy everything. Dim vehicles, or let's say vehicle. Yeah, vehicle. So here we will simply change the name, vehicle view, and vehicle, and here it will become vehicle. Perfect, simple, very good. Let me just copy this code, just 2 lines of code, and perfect. Simple, very good. So my dim vehicle is also ready. Now what's next? Now I think we should create dim location, obviously, because we have some information related to city, address and all, but dim location is like totally different thing, because we will be just using our you can say slowly changing dimension type 2 for dim city. Okay, so we will just keep that particular dimension at the end, for the end. And now what I can do, I can simply scan it again. So ride ID, confirmation number, and passage and passenger ID is for passengers, pickup location ID, pickup drop off location ID, and this is already done, right? So now let's create our dim booking that will create a special table to provide context regarding the bookings. Simple, because rest of the dimensions are done, and driver rating is also done, so this is also good. Pickup address, obviously booking related information, and drop off booking, and timestamps will obviously go in the booking. Now I can do one thing. I can add these timestamps in my fact table, because it is a kind of choice. Some people prefer keeping the timestamp columns in the fact table, some people do not, but I would like to keep the date columns in the fact table as well. It's fine. So that you can just apply the groupings and all, and it's fine, totally fine, because I don't want to create a dim date as a separate table. Some people prefer creating the dim table as well. I'm not denying that thing, but I would personally say like it is totally depend, like it's totally depends upon the requirements. Simple. So I will simply keep that all of the dates and everything in the fact table itself, and fact table will obviously keep all of these numbers, so we are good. Description, okay, base rate, and oh, we can also create payment as well. See, we have one thing which is called payment, so we can create dim payments quickly. So dim payment, do we have payment ID, payment method ID? I think I will have for sure. So let's create a dim payment. So payment method ID or payment method is card, requires authentication, and these 3 columns. Simple. And yes, so let's create that thing, so it will be very handy. So if I say payment method ID, yeah, I have payment method ID. That means I can use this as a dimension. So I'll simply go and create payment method ID and payment method itself, and then is card and requires authentication. Simple, good. Payment method ID, simple. Let's try to confirm everything is good. Yes, this is good. So this is my all of the payment method. So this is a very good example when we have just 4 records, okay, but in reality we have 2006 records. Why? Because we have simply replaced all of the duplicates. This is the very good example for it. Very good. So now let's try to create this dimension as well. Dim payments. Dim payment. Yeah, perfect. So now, so here let's change this to dim payment. payment method ID, and here sequence by payment method ID. Simple, very good. And let's copy this code as well and paste it here. Perfect. So our dim payment is also ready. Now let's finally create the final dimension, not final, second last dimension, which is called dim bookings. And in dim bookings, we will put everything: ride ID, confirmation number, all of the things. Okay, so ride ID, confirmation number, let's try to put it here. So let me just write the code here so that we can just see the columns side by side. Or let's do it here as well. Let me just complete this particular dimension. Okay, let me just quickly pull all of the column names. So these are all of my columns that I have picked for my dim bookings. So if I just run this, I should see it now. Perfect. So now what I can do, I can quickly create the dim bookings. Or let's say dim booking. So now this dim booking is obviously a pretty much wide table because it has all of the information regarding the booking. Or you can also say this is one of the main dimension, or this is also called as, this was a technical name for it. Master data, kind of master data for our entire data model. Okay, so I will simply say dim booking view, and this will become my ride ID. Simple. And this will be 1, and let me just copy the code here. Simple. So now if we just try to do dry run, let's see if our all of the dimensions are good, and if good, then we can just get started with our last dimension, which is for dim pickup city, or basically dim pickup location, because that is a kind of slowly changing dimension that we want to build. We are just building one slowly changing dimension, but yes, you can build as many slowly changing dimensions. You just need to make sure that you have the timestamp column in the source in that particular thing, right? Very good. And don't worry, I will also explain you the difference between slowly changing dimension type 1 and type 2, but by doing it, because when I will be just explaining you the concept, you can understand it obviously, but when I will just show you the difference parallelly while building the dimension table 1 and dimension table 2, you will understand the concept in a better way. Okay, so we will follow the second approach. We will build it and then we will learn it. Okay, let's wait. It is just running this particular thing. So I have got the error dim vehicle view. Yes, obviously we cannot say dim vehicle view. We have to say dim payment, and we didn't change the name in any of the dimension. Not a big deal. Yeah. So this is good, vehicle payment, and then this dim booking. So just make sure it is good. So okay, dry run. Let's see. We have got another error, but this is not an error. This is again a typo. So remember, we simply copy pasted the code, but we didn't change the read to read stream. So we have to just say read stream in all of the thing. Let's say like this. So not an error, just a typo. So simply say read stream and read stream, because we simply copy pasted the code from notebook, and in notebook we are not using read stream. So let's say read stream, and yeah, good. Let's run it one more time. Let's see. So this is fine. This is absolutely done and very well done. So now what we can do, we can simply say run pipeline. We just want to make sure like our all the dimension tables are good. So now meanwhile it is running and we know that it will run fine. So let me just bring my Azure screen. Now let's say we want to make a change in this particular dimension. Let's say I want to say city ID 2 is not Los Angeles. It is, let's say Las Vegas. Simple. Let's say this thing. And I also want to change the time. Makes sense. So I will simply say let's say 20, let's say, and I will simply commit this change. So now when I will again run my ADF pipeline, If I simply ingest all of the data again, let's do it quickly. Now let's wait. So I know that my one record will be overwritten with a change, obviously, right? That will be overwritten. We know that with a different timestamp. Okay. Now let's see what will be the impact of this thing. So now let's wait, and we will not process this data. Don't worry. We have simply made a change in the, you can say, in just the JSON file. We have not processed this thing. We have simply made a change. Okay, so this is done. Very good. Now let's go back to our Databricks, and this is still running. Okay, so this will take some time because there are so many dimension tables, and we can also open the graph view if you want to see what we have built. So perfect, this looks amazing. So here we have writes raw, staging writes, silver OBT, and then these are the views and these are the dimension tables. Simple. So these are running now. Let's wait, and this will simply generate the dimension. So we have 1 2 3 4 5 dimensions and one slowly changing dimension. So we have total 6 dimensions that we are building for this particular data model and one fact table. Okay, let's wait till the time it is running. Okay, 2 are done. So this will be running fine, we know that. So let it run in the background, and let's do our next dimension. Yeah, only 2 are left. It's fine. So now what we need to do, we need to build the slowly changing dimension for our pickup city or pickup location. So for pickup city or pickup location, we have columns such as pickup city, state, region, right? And city updated at, obviously the most important column. So let's try to put all of those columns. So I will simply say pickup city ID, pickup city. Do we have pickup city ID? Let me just check. I think it should be there. So we have pickup location ID for sure, so I will just use it. And then we have pickup address, so I will use pickup address as well. Pickup latitude, longitude. Okay, and then we have, where's pickup city ID? If not, I can create one. It's not a big deal at all. Or we can also use, you can say, but I think there was a kind of ID. It's called pickup city ID. Let me just check if we have. So let me just write it here. Pickup. Yeah, we have pickup city ID. Perfect. So I will simply say pickup city ID, pickup city or updated at, obviously. Then region, then pickup address, what do we have else? Pickup latitude, pickup longitude. We do not want any kind of drop off because we are not getting drop off dimension. That information is stored in the booking. Okay, now we have, I think we are good. We have state. Okay, let me just add state as well. Pickup state. And again, I'm repeating, if I miss any column, it's fine. You can just add it on your own. Let me just say state. And this will become my pickup city ID. So let's see, what do we have here? Pickup city updated at. Okay, I think then it is called city updated at, not pickup city updated at. Yeah, perfect. So we have got 10 records, and as we know that we should receive only 10 records. Okay, that makes sense. So now what we need to do, so again, this is a kind of pickup city. This is a kind of pickup city dimension. Okay, or I can do one thing. instead of creating pickup city dimension, I should create the pickup location dimension. Why? Because that way we will have much more granular view. Otherwise, we will simply cut off my pickup city ID, because we have obviously much more addresses as well, but we have much less cities. So let's do one thing. Let's add here pickup city, pickup location ID. Simple, because that way we will be having much more records. Pickup location ID. Did we pick pickup location ID? No, let me just pick it. Pickup location ID. Simple. Perfect. So now we have got 2006 records. So that means we have 2006 different records. So that makes sense. That makes sense. So now if we have, let's first of all create the dimension, and let me just, okay, these are all done. Very good. So now this is very critical. Our dimension type 2. And not just type 2, because this is the only slowly changing dimension type that we are building. Other dimensions are actually called as slowly changing dimension, but they are not actually slowly changing dimension. Slowly changing dimension is just this one, dim pickup location. Simple. Okay. I could have also created like location, but it's fine. Simple. So let's say pickup location. Okay. Now I would need to make some changes. So I will simply say pickup location. Okay, makes sense. Or let's do one thing, because actually it should not be a pickup location, because pickup information is actually a kind of booking information. It is not a kind of location information, right? I need to just keep it very, very generic. So let's make that change, and let's copy pickup city ID. That is fine. Updated, fine. Region, fine. And then state, I can just move here. State should be here. Perfect. And then all of these things, pickup address, pickup latitude, longitude, pickup location ID should go in my above data frame, which is this one, dim booking. Simple. That is what I personally feel, because this is not a kind of generic dim that I should create. I should keep only and only the information till location, because I just want information related to the city, or let's say location. So pickup city, pickup updated at region, state, and perfect. And we do not need to worry about this pickup city ID, because its alias is called as pickup city, but actually it is just a kind of city. So we can simply say pickup city ID as my drop duplicate subset. So what will happen? It will simply drop all of the duplicate from this pickup city ID. Simple. And I can even show you as well. So if I just go here, if I simply say pickup city ID, and if I just drop everything till here, let's see what do we get. Perfect. Now we have got 10 records. This is fine. This makes sense. This makes a lot of sense. Okay. So I can simply go with that, and this is perfect. So I will simply say, I know this like name is weird, but this is like fulfilling my dim city or dim location requirements. So I'll simply say dim location, not just pickup location. Dim location, and this is fine. This is fine. This is fine. This will become my dim location. Now you need to be very, very careful, because now the question is up to you. Now just tell me one thing, that what will be the sequence by column, because we know that the key will become pickup city ID. Now just tell me what will be the sequence by column, and what do I mean by sequence by column. So for example, let's say currently if I look at my all of the values, this is like this, right? Yes. So this particular table has the column city updated at like this, and we have changed the value for LA, right? So this value will be updated. So I want to say if there is a new value, who will decide that there is a new value? This column city updated at. So if I will say that there's a new value, or let's say there's a value, there's just a value called Las Vegas, but the value of city updated at of Las Vegas is greater than the city updated at value of Los Angeles. That means Las Vegas is the updated value. I need to use that value. So this is a kind of, you can say, condition that we create using this key, using sequence by. Simple. I hope it makes sense. So I will simply say pickup city updated at, not pickup, city updated at, and I want to create a slowly changing dimension type 2. Now what is the difference between slowly changing dimension type 1 and type 2? Let's talk about it now. Okay, or let's see first of all like how does it look like, and then I will just show you what is the difference. So let me just click on run pipeline and let's do a full refresh. Okay, and let's see what do we have, and then we will confirm that we have our dimensions ready. And this should have dim location, perfect, and this should have booking information. Okay, perfect. So let's do it. Let's wait. So perfect, my pipeline is completed, and now let's try to see the data of these pipelines. So I will simply go and test dim let's say bookings first of all, because dim booking is a kind of master data for our data model. And perfect, this is very good. This has all the information including pickup address and all, because we shifted that thing there, right? Perfect, very good. Now what we need to do, now we will simply, so now I will simply query my slowly changing dimension type 2, because this is type 1, we know that. So this will become dim location, and now you will see what is different in that particular thing. So perfect. So now you will see that we have this dimension 10 records, 1 2 3 4 5 6 7 8 9 10. Perfect. Pickup city, city updated at region, state. Ansh, Lamba, who added these two columns, start at and end at? I didn't add these columns. And why do we have these columns then? These are automatically created by Databricks. Why? Let me just show you why. So now what will happen? Now we have new data, updated data for our city. Now city name is changed to Las Vegas. And now I want you to make a small change in your code first of all before proceeding further. So I have created this or converted this view into a table, because I thought of let's create a staging table instead of creating a view, so that we can just better monitor our code. Okay, because we cannot query the view directly. And I have also added one more column which is called city updated at in my subset, because it will prevent us from having multiple changes before processing our data. This is a very rare edge case that I have added, but this will actually make your code much more stronger. Make sense? And one more thing, if you just open your bronze ADLS, I have made a small change in the file. So as you know, like this is the loop that we are running, right? So what I have done, I have removed the map, basically bulk writes file from this. Why? Because see, these are the mapping files. We can just override these files again and again, because we are not treating these tables as a streaming table, but we are using bulk writes as a streaming table, right? So I have added a separate cell just for processing only the bulk writes. Okay, here is it, here it is, bulk writes. Why? Because you cannot overwrite or you cannot make changes in this table, because if you do so, then it will simply throw the error that you cannot make changes in the bulk writes table, because it is being used as a streaming table. Okay, and I have also added a guardrail, because even if you run this cell multiple times, it will not throw the error, because I know some of you will be just rerunning this cell even if I just ask you not to do that. So I have simply added this guardrail. If table does not exist, only then run this cell, otherwise do not run this cell. Simple. Okay, so these are some changes. So now let's get back to the point. Now what we need to do, we will simply make some changes in our GitHub. So let's say this is our file. So now what I will do, I will simply make some changes in all of the records. Let's say in all of the records. Why all of the records? I will let you know. Just hold a second. So let's say, let me just say 24. Not 24 actually. Time, let's say 23 for all. And this will also become 23. And then let's say 23, and let me just add new, and let me just say new, or let's add new in the prefix, new New York. Okay, and let's say new Las Vegas, all of the changes. Simple. And then I can say, and let me just copy this whole value instead of making change and all. So let's say new, Okay, perfect. And we have changes in this as well, so this will also be new. And I will also remove these changes because you will be just using this file for the initial loads and all, so you have to manually make these changes in the file. Okay, like the same way I'm doing it here. Okay, this is also good. Let's say new. This is also good. Let's say new. So now why I'm making changes in all of the records? Because I do not know which city will be assigned to the ride, obviously, and I want to just test it quickly. So I cannot wait for my city to reflect, because obviously whenever I'm booking a ride, I do not know like which city will be assigned to the data. So I need to just make sure that changes are there. So I'm just making changes in all of the values. Make sense? So let's say commit changes and commit. Simple. Let me just run this pipeline for one more time. And perfect. So this will load the data. So now what I will do, so this will first of all load the data, all the data that we have loaded so far. Very good. Now you know that in our data frame we have 2006 records. Okay, so now I was doing some testing, so I have some extra records. So I have at least now 2018, 19, 20 records. Okay, so you can just ignore that. So I will just tell you what is the exact number now, and we need to just test it after that. Simple. So it will be loaded there. This is good. And meanwhile I can book some rides, because if we have new data, only then the streaming tables will take that data and then it will just make some changes. Otherwise it won't. Why I made the changes in all of the dimensions? See, let's say you made a change in one city, and if I book a ride, and if that is not my city, then obviously I will not see the change immediately, right? Same with other records as well. So it will not process those records. So I want to do the testing quickly for my development. So I will simply say book a ride. So obviously if any city is assigned to it, oh, I think my API is closed. So let me just turn it on quickly. So let me just go to my folder, and this is my project. Okay, so this is Uber data engineering project. Okay, perfect. So I have turned on my API, my web application. So now let's wait. Perfect. So this is this book a ride confirmed, book a ride confirmed, one more, book a ride, and ride confirmed. Perfect. So these are the three records that I have recently inserted. Okay, and this is also done. Now what we need to do, we need to simply load our bronze tables again, obviously, because we have some new files here. So I will run this code, okay, just to load everything. Now let's wait. So this is done. Now if I now run my pipeline, if I run my SDP pipeline, what will happen? It will process your silver OBT first of all, and in the silver OBT it will only get the three new records, right? Yes, 3 new records. Perfect. So it will get only the 3 new records. Makes sense? So when it will get only the 3 new records, only those 3 new records will travel to the next stage, which is the dimension stage. And if there are any changes in the values, it will simply reflect those changes in my dim location. This is the flow. Understood? Very good. So now let's try to run our pipeline, and we'll simply say run pipeline. So now what will happen? You have understood the flow, right? Let me just explain with the help of DAG as well. So now here in this DAG, first of all, this staging rides, or basically you can say rides raw, will receive 3 new records. These 3 new records will go to staging rights, and these 3 new records will be appended to the silver OPT. Perfect. Very good. Now what will happen? Now only these 3 records will be traveling. Okay, and we know that our dimension is dim location, this one. So only these 3 records will travel to dim location staging. Then these 3 records will be compared with the end table, which is your final dimension table. That's how it works. But now here one thing to note is we are not applying upsort in the silver layer, because we cannot do that in the streaming architecture. We have to keep on appending the data. Okay, We have to keep on appending the data for our all of the records. Make sense? And this is like a normal behavior. That's not a big deal. So now let's see what is the output of it. It is working. So now you can see in the dim location, I can see that output is 3 records and upsert is 6 records. You will understand what is this thing. But I think this is like now self-explanatory. This is very simple. We will see like what is this thing. So now let's wait. And perfect. All of the dimensions are ready. Only one is left. Which one? Yeah, now it is ready. Now if I just try to query this dimension for one more time, now I will see 13 records. Wow. And let's see why. So as you can see that New York record is still there, but you know what? It is there, but now basically we have multiple values. Why? Let me just show you. So if I just scroll down, we have New York, Phoenix, like older values. That is fine. But we have 3 new values. Why 3 new values? Because we ordered cab for 3 times. And obviously, randomly, I will get some ID. I will get some city out of all the cities. In these 3 orders, only these 3 cities were assigned. One was Houston, and second one was Chicago, and third one was Los Angeles. Okay. And now we know that these values are updated with new Chicago, new Las Vegas, and new Austin. That is why you are seeing that end at. That means this value was valid, but only and only till this time frame. Okay. Now the new value for this key, that means the primary key, which is like 4 here, the city ID, is this. Oh, okay. That is the concept of slowly changing dimension type 2. Slowly changing dimension type 2 means we want to retain the history of the dimension table as well. Like what was the previous value? What was the previous value than previous value? Like we maintain the record. We maintain the entire history of our records. Okay. That's why if the value is not changed, which is in this scenario, then end at column will be empty. That means null. But if the value is changed, then obviously we need some guidance like, hey, which value is changed and when it was changed. So that is why we see the date here. Oh, so this is your slowly changing dimension type 2. Type 2 means if you have a new record which is changed, obviously, then you will simply insert it. And if there are any changes, you will simply update it as well, but you will create the history instead of making in place changes. This is the concept of slowly changing dimensions. Now in the future, let's say we book a ride and we get assigned to this city, Phoenix, then obviously this data will travel to the next stage and this record will also be updated with the new timestamp. This is the concept of slowly changing dimension type 2, but in streaming, in structured streaming. If we want to build a solution where we want to make immediate changes, then obviously we need to process it like a batch, where we need to make changes immediately in all of the dimensions. We are not doing that thing here. We are processing the data using Silver OPT. So if there are new records and if cities are assigned to that record, only then it will be changed. But yes, sooner or later it will be changed automatically. I hope it makes sense. Okay, good. Very good. So this was all about your slowly changing dimension type 2. Was it easy? Yes. With the help of SDB, it was easy. Very good. Now we need to build the fact table. Now, before building the fact table, I want to ask you one simple question. Now, obviously in the fact table, we need to keep all of the numeric columns, right? And we just need to keep the joining keys so that we can just make the joins. One very important concept. Now you can see that in case of slowly changing dimension type 2, we do not make the in-place changes. When we do not make the in-place changes, in that scenario, while applying the join, it can create duplicates. Why? Just look at it. So this is the joining key in this particular table. Do I have duplicates? Yes. So while applying the join, we just need to make join with only those records which are not expired. Make sense? Which are not expired. So in this scenario, which record is not expired? Where the end at column is null. So we should always add this particular, you can say, condition in our join. Always. Simple? Okay, very good. So now let's do one thing. Let's create our fact table. Okay. So now in order to create our fact table, so we just need to pick the numeric columns and along with obviously the joining keys, right? So I will simply pick the numeric columns such as, I think we have a lot of numeric columns. We have numeric columns such as distance, miles, duration, minutes. These are all numeric columns. So let me just zoom out a little bit just to write all of the column names. So it will be like this. Oh man, their UI experience is like, so let me just write the code here just to see what we are doing. Simple. So now let me just do OBT. Okay, so the column that I want to pick is, first of all, I want to pick distance miles, and then I want to pick duration minutes, and then I want to pick other columns. So other columns are base fare, distance fare. All of these columns will go under your fact table. Okay, good. So I will simply say there's one more fare. I think base fare. Yeah, base fare. So let's say base fare, then distance fare, then time fare, then surge multiplier, then subtotal, then tip amount, tip amount, then total fare. Okay, then what do we have? Rating is already done, I think. Oh, rating is done. Yeah, so here we have, I think, included rating in the driver. Yeah, no, rating is like overall rating. Okay, makes sense. So driver rating is different and rating is different. Okay, let's include rating as well, because that is a kind of generic rating. Let's say rating, then we have base rate, then we have per mile, and then we have per minute, and then we have, yeah, I think that's it. Payment method is already done, is card, state is done, cancellation reason is done. Yeah, I think that is good, and we can simply say ride ID as our subset. Basically, in ideal scenarios, we just pick all of the you can say your subset of all of the primary keys of dimensions. That is a kind of standard rule that we have. So I will also do that. So let's say let's say fact. So for fact, I will simply create, and fact, we should never create a kind of you can say slowly changing dimension type 1 or type 2. To be honest, it should be like ever appending, but some people prefer to keep the fact table as absurd tables, but it should never be an absurd table, because fact table are facts and facts are never changed. Simple. So we should not keep that table as a, you can say, a kind of table in such a way that will just behave like absurd table, but we can have that particular rule so that we will not have duplicates, just to remove duplicates, but that doesn't mean we should have this table. Okay, so now what I need to do, I will simply build this fact table like this. So I will simply say fact table, and let's close this. Okay, perfect. So now what I need to do, I need to simply say this is my transformation, and I can create it like this, remove it, and I will simply say view, and then this will become my fact view, and this is the transformation. Just 2 pieces of code. and that's it. Perfect. And this will become my fact, and this will become my fact. This is not a dim fact view, this is a fact view. Simple. So now here ideally we have the single key, but in some scenarios we do not have like keys when we have like so many dimensions. So in that scenario we simply pick write id. Okay, like in short, the combination of all of the primary keys of dimension tables. This is the basic rule. Write id, and then you can have pickup city id, then you can have all of these. So here we have pickup city id, here we have write id, here we have payment method id. So let me just add that as well. Payment method id, and then we have driver id and passenger id. That's it. How many dimension keys we have? 1 2 3 4 5. There should be like one more. Yeah, vehicle id. So this is the thing, and we want write id as our sequence by. Usually we will not be having any absurd scenarios, but still. Okay, so this is our table that we want to create, and we should be good. Simple. It is like mentioned here as SCD, but this is not actually an SCD. So when we have this table, then we can just create our fact table, and we can connect our fact table with any dimension table. Simple. Like you can have like join, and it will simply create the join, and that's it. And here, whenever you want to create a join, remember one thing, because whenever we create join, you cannot directly connect your fact table with the dimension tables. You will see duplicates, you will see much more records than 2000 plus records, obviously, because you will not add the filter that I have just mentioned, that end add should be null. If you will not add that filter in your join, then it will simply bombard your fact table with so many, like it will literally multiply your records, because then it will behave like a cross join. Simple. So yes, we are creating the fact table, but when you are building, let's say, report using this fact table, you are writing your custom SQL queries, you need to just combine this fact with dimension. You have to make sure that you are applying that filter in every dimension, not in every, because we just have type 2 in this particular thing, dim location. So you need to add where dim location dot end at equals to null. Simple. Otherwise you do not want to bring any key. Simple. Just a quick tip. Okay, so now let's say dry run. Yeah, just to make sure like everything is fine, and then we can simply run our all the pipelines. Then we can just say, okay, our development is done and our project is completed. Obviously there are small things that we need to just take care, but yeah, fact view is not a streaming view, must be referenced using read. Obviously we need to just say read stream. Simple. Dry run. That's why dry runs are very good, because you see the error before breaking anything. Okay, so by the way, in development, if you do not break the things, you are not a developer. To be honest, yeah, development environment is meant to be broken, and then only you will learn what it is saying. Function parameter with name write id. What do you mean? Sequence by equals write id. Don't we have write id? I think we didn't bring the write id in the select columns. Okay, no worries at all. I can just bring it right now. Write id. And one more thing, I also didn't bring the pickup city id and payment, like all the IDs. So let me just bring it. So let me just check all the IDs are here. 1 2 3 4 5 6. Perfect. Now it should run fine. Very good. Okay, this is fine, because I remember in my previous project when I just showed them slowly changing dimension type 2, they were saying, hey Ansh, Lamba, when we are just applying join, it is simply giving us 10 times more records. I was like, bro, you forgot to apply a filter. So I thought of just mentioning that very critical point in this particular project so that you do not miss that. That is a very common thing, but when you are busy with so many things, you can skip that. So this is fine. Now let me just run the pipeline and everything should be fine. Yes, let's wait. And let's see. And I told you that I just tested some records. So in my case, I will be having some 10 to 15 records more than you. Okay, so it's fine. I think I would have 12 to 15 more records, because I was just doing some testing for gold layer, just to setting up the base. So do not worry at all, because now when I'll be just querying how many records do I have in fact table, I will be having more. Okay. So, okay, now let's try to test quickly how many records do I have in the fact table. So I'll simply say fact and just fact. And it should show 2024. Makes sense. Makes sense. Yeah, I am expecting these much of records because I was just testing so many things. So I have 2024 records and it has just performed everything that I wanted, and it has everything, literally everything. And if I just want to apply a join, let me just show you that point as well so that you will know what I was talking about. So let's say now I want to build a solution where I want to combine all the things from the fact table. Let's say I want to bring fact dot ride id, and I want to bring fact dot, let's say, base fare. Okay, and I want to bring some information from my dim, which is uber dot bronze dot dim location. Okay, dim location, and I want to bring it here. Let's say this is dim. So dim dot, let's say I want to bring city, or let's say region. Simple. Let's say I want to bring that information. So if I say on, and obviously I know that it will be pickup, not location ID. I think pickup city ID. Perfect. So if I just do this only, let's see what do I get. Error. Wow. Fact dot write ID, fact dot this. What's wrong? Do I need to use as? I never use as in my workbench. Fact dot write ID over bronze dot fact. Let me just add it here as well. Oh really? I think comma is missing. I was like, what's wrong? And now let's try to run it. Dim dot city ID. What do you mean? Don't we have city ID? No. So what do we have in dim? I think in dim location we have maybe dim pickup city ID. Maybe. Yeah, dim pickup city ID. So if I just run this query, I will see much more than 2024 records. Why? Because it will simply bombard it. Like it will simply apply multiple joins with the same key. That is like obvious, I told you. So you have to use a filter called, or you can say and dim dot pickup, not pickup, and that is null. Simple. So this will make sure that you are not bringing the records which are not null. See, now it is fixed. So just make sure you do not make this mistake, and it is very important. And I can also say testing gold layer. Simple. Okay, perfect. So now our gold layer is also completed. Where is my gold layer? Here. So our gold layer, our final table is done. And by the way, let's use the real names. So we have dim location, dim booking, then we have dim vehicle, then we have, I think, dim passengers, right? And 1 2 3 4 5, there was like one more, which was the one, I think, what was the name of it? Dim location, dim booking, and dim payment. Okay, so we have all the dimensions created. Woohoo! Finally, it was a great learning, to be honest. Great for me as well. I learned a lot of things from those errors, and I love that. So that is also good. So this is our fact table. Okay, and this is our model that we have built with one slowly changing dimension table as well. You can just build slowly changing dimension type table with all of the tables, but I just wanted to show you one example so that you can just take care of other as well. Simple. So this is our final project where you can see everything in our Databricks as well. So we have this final pipeline graph which looks amazing. Okay, And this is actually good. Now we have all of the tables that we wanted to create, and we have fact table as well, which is really, really nice. So now our next steps. Our next steps are, whenever you book a ride from here, let's say this is my web application. So whenever you book a ride, tuck, so it automatically goes here, right, in my event hub, obviously. Now you can just define how frequently you want to run this pipeline. Maybe you want to run this pipeline in every 2 minutes, in every 1 minute, maybe in every 5 minutes, maybe. So you can schedule this pipeline, okay, by clicking here, schedule. And obviously this is a production grade scenario. When you are good with your deployment, you are good with your testing, your QA testers are also happy, then you need to schedule, okay. Then, and obviously you can schedule in development phase as well. Let's say you want to schedule it for little time just to test everything. So when you click on schedule, you just need to tell everything that how frequently you want to schedule this pipeline. You can simply say I want to run in every 1 and then minute, or let's say every hour. Every hour will be too much. The person will book a ride and will wait for 1 hour to respond. So let's say in every minute. We don't have minute, no. Maybe it is not there for development, like this free edition, but obviously we can just run it in every minute. And we can also use the advanced tab just to show the cron syntax. We can just change the cron syntax as well, okay. And then you can simply say every minute, so you can just pick it from here as well. So let's say you want to run this in every 2 minutes, right? So that's how you can just schedule this pipeline. And what will happen, the moment you will book a ride, it will keep on listening to the events. It will keep on listening like this. It will just use this like ear, and it will keep on listening the events in every 2 minutes. And in every 2 minutes, it will run this entire pipeline like this SDP. Now, obviously there are some things that we run before running this SDP. What are those things? If we have any changes, in the dimension, right? So what you can do in that scenario, you can create a job. You can create what? A job. Let me just show you that as well. So now just go to jobs and pipelines, okay. And here are some jobs that I've created, so many. So let's create a new one, job. So now in this job, you can build your entire job. So first of all, what you do when you receive the data, obviously you run the notebook. Which notebook? Just click here, task name. So it will be like bronze, right? Bronze ADLS, right? And what is the path of that notebook? The path of that notebook is here, Uber project, bronze ADLS, and confirm. Simple like this. So you can simply say create task. So this is task number 1. Now you want to add another task. Again, notebook, perfect, pick it, and then say silver process. And what we do in process, we basically build our Jinja template. Now, yes, you would need to do a small homework how you can automatically convert that Jinja template. You do not need to convert, how you can automatically pass that Jinja code into the SQL. You can use DB utils, you can use OS module, you can literally do anything. Like this is a very basic thing that you can just do. It is totally up to you how you want to travel, how you want to transfer that Jinja code into a SQL file. Simple. So this will be up to you how you want to configure this activity. Once you configure this activity, let's say for now, I am just selecting the notebook just to show you the demo. Let's say this one. Let's say in this notebook, I have written that code. Simple. Once that is also done, then I can go to my task. So I will say save and continue. And then I will say add task, and then I will add an ETL pipeline task. So here I will simply say task name, and it will be, let's say, data model, OBT and data model. Simple. So here it is asking me to pick the pipeline. The pipeline is this one, Uber ride events, and that's it. And here I can simply say create task. So instead of scheduling only the pipeline, okay, I can schedule this entire job as well. See, now what I can do, I can simply run this entire job, and I can simply say schedule, or I can say run now as well. Run now is just like running now for just development, but you can also add schedule and trigger. So if you just click here, you will simply say add trigger, and it will simply add a kind of trigger or schedule to run your job on a regular basis. This is a better approach. Now I'm not saying like DLT schedule is not better or not good. See, you have some dependency before running the pipeline, right? So if you have some dependency, you need to make sure that you run that as well. Then only it is a good workflow. If you do not have any dependency, if you have written all of your code in DLT, then obviously you can directly schedule it. But usually in the real world, we always have some dependency on the notebooks, always. For basic tutorials, you will see, oh, there is no dependency, but actually, and see, this is also a real world project. Do we have dependency? Obviously. So we always have some dependency on our custom notebooks. Simple, very good. So this is everything for your project. And this is everything that and you know what? You can even schedule everything in the ADF as well, which is our Azure Data Factory. Because we have here Azure Databricks services, which is this one. So you can just schedule notebooks and that's it. It is totally up to you. So there are so many ways that you can just perform orchestration, and plus it totally depends upon the requirements as well, like how frequently you want to listen to the events, how you want to deliver. This part of the development is more of the operations work. I would say data ops thing, where you are not the one who is taking the decisions. You just need to follow the decisions and that's it. This comes under when you are trying to deploy the code into multiple, you can say, environments as well. So this kind of activity falls under that particular task. Make sense? Very good. So this is your complete end-to-end data engineering project, real-time data engineering project, where you built everything using structured streaming. And I hope you found it helpful. So if you found it helpful, just drop a lovely comment in the comment section. This will motivate me a lot. And you can just click on the video coming on your screen. It will actually help you a lot to learn a lot of things. So just click on the video and I'll see you there. Happy learning. Happy learning.